20 years ago, a seed was planted and cared for. We painstakingly nurtured it and weathered it against adversity until one day it blossomed and the fruits of our labor began to show. Today, millions have learned, shared, and been inspired by what our community has produced. We proudly served 21 million users from 204 countries in 2019. For our 85,000 technical articles, code samples, and videos, our 450,000 forum questions, and our highly anticipated conferences and events featuring keynote panels, live streams, and industry experts and influencers. We recognize and reward members for their dedication to the community. Through content contributions and mentorships, we ranked number 2,620 in the world with a reach of millions across our social media channels. Thanks to you, our global community of software and data developers grows stronger each day. For more information, visit us at csharpcorner.com.
Hi everyone, welcome to the C# Corner.net Conference 2022. This is day 2 and I'm your host Stephen Simon for the first half of the day. If you're someone who is joining us today for the first time, I would say you have missed a big part of the day 1 of conference. That was the other day. The other day, that was day 1, was focused on Blazor. We had a keynote by none other than Scott Hunter. And it was an absolutely amazing day filled with Blazor. We had sessions around Azure Functions, static web apps. I mean, it went all over my head, but definitely go ahead and check it out. If you have missed it, you can always find it on csharpcorner.com/live or csharp.tv. Or in any case, if you cannot find videos over there, you can always go to C# Corner YouTube channel and you can find all the live shows and virtual conferences over there. Having said that, this is day 2 of C# Corner.net conference. Today, we're going to have somewhere about 8 to 9 sessions. We couldn't host some of the speakers today because I would just encourage people to stay safe because COVID is bad. Many of our speakers have got COVID positive, so they cannot make it. So we really apologize for that. As you know, we have started a little late today anyway. The conference was scheduled to start about 30 to 40 minutes before. But because of this COVID situation, some of our speakers cannot make it. Having said that, today is the focus around C#, .NET 6, and Visual Studio. That's what we're going to talk about. And a very gentle reminder, I've been looking into the comments the other day that you all have been on the spot, and I want you all to continue it and follow the code of conduct. Be very kind to each other. And yeah, As always, there's always a contest running on. So use hashtag C sharp. Come on, let me try to share it. Yep. Use the hashtag C sharp 2020 when you drop your comments in the live chat, and we will make sure that we pick winner towards the end of the day. And we did pick a winner the other day. If you have missed it, and if you have not reached out, and if you don't reach out to us by the end of the conference, we will consider it gone. Okay, so definitely go ahead and check out the other day's video because we did announce a winner the other day. So I see many people are joining. Hi Rohit, welcome to day 2. Hi Mahesh. Mahesh is the founder of C Sharp Corner, and he hosted along with David the other day. He'll be joining me today after 11 a.m. Deepak, welcome. Hi Muhammad, and EDEF web server. I think I know this. I think he is Michael, if I'm not wrong. Hi Marcelo, welcome to the conference. Having said that, let's actually go ahead and invite our very first speaker of the day. Uh, I actually forgot how to say his name. I practiced it behind the scenes. Oh my goodness. But never mind. He is. I'll try. I'm really sorry. I'm bad with the names. Joe Antunes. Oh, I messed it. And he's gonna talk about. Oops, I did it again. I cannot even say it in a very plain way. I mean, whenever I say his session, I just say in this melody. Oops, I did it again. So we're really excited. Joe is a Microsoft MVP. He's a software engineer. He's a content creator. He's an architect, and he focuses on .NET. And without any further ado, let's bring him to the conference. Hi, Joe. Oh, how do you say your name?
Yeah, don't worry. I think my name is like impossible to say for anyone that is not Portuguese. My name is
Yeah,
João, but yeah,
Joe. All right,
nobody can
Joe.
say it, so no problem.
All right. So, welcome to the C Sharp Corner Conference 2022. I really want to thank you for accepting our invitation. And yeah, you have a very exciting session title. So, we all are really looking forward to it. I see you have shared your screen, and
Yeah,
I'm going to add it to the stream now. Everybody can see your screen, Joe, and the stage is all yours.
thank you. So, as Simon said, this session is titled Oops, I Did It Again. The original title was Untangling the Mess We're Making Out of Object-Oriented Programming, which is not as fancy. So, kudos to the JetBrains folks who came up with this much better title. And just before getting into things, a quick introduction about me. I'm João Antunes. I'm from Portugal. I'm a software engineer at Bold by Devo team. I'm a Microsoft MVP in the developer technologies category. And you can find me on Twitter and talk about these kinds of things that I will discuss today in this handle, João FB Antunes. So let's jump right into the content. So even if it wasn't clear by the musically titled session, this is about object-oriented, and not only that, because this is still one of the most broadly used programming paradigms. But I question if we are actually really doing object-oriented code, because I'd argue that a lot of the code that is supposed to be object-oriented is actually procedural, just written in a language that supports object-oriented constructs. And of course, this is my experience. Maybe you have been luckier over the years, but for me, procedural has been the norm and not really object-oriented. So my goals with this presentation is to actually remember some of the basics of object-oriented, but also other paradigms, provide some ideas to help improve code bases, hopefully. And it is not my goal to show the one true way, as I don't believe that there is such a thing, and also not my idea to start a paradigm flame war like OO versus functional. And as you will see, I will actually use both where I think it's appropriate along the way. So in terms of the structure of this presentation, it will focus on like a sample API where we go through steps, hopefully improving along the way. The first two steps, which I call the supercontroller and the super service, are mostly a description of the things that I usually see in production environments. But then from three individual request handlers, OOifying, making use of type safety, and minimizing exceptions, it's more of hopefully improving in several steps. As I briefly mentioned, it will be like an API example, and I chose to use like a supermarket API because it's simple enough so we can focus on what we are talking about, but at least has some complexity to not be just write things in the database and return them. So it has some logic, like for create the cart, getting information about the cart, adding items, and updating and removing items in the cart. Because this would be a lot if we try to do all of this, I will focus on a single operation, namely add item to cart. So let's get into the meat of this presentation and start with the supercontroller. If just by the name you don't see what's coming, I will show you. But basically what we have, I have a bunch of projects. Hopefully the font is big enough for you to see. And we have a cart, which basically, as you might assume for the name I gave it, supercontroller, has all the logic in it. So all the actions and all the logic is in the same place. And as we are focusing on add item to cart, let's take a look at how this is implemented. We log when we start handling the request. We do some validations like the inputs. Then we get the cart and the item from each repository. We check. This is where we start to do some business logic rules. So the item is already in the cart. If it is, we can't. So it would be a bad request. If it isn't, then we can add the item to the cart. Then some more business logic comes in, where maybe, let's imagine we are in a water shortage, so we can only sell a maximum of 6 bottles per day, for example. It could be something that we could do. Or maybe we could have a minimum time of day to sell certain items. For example, we don't want drunk people, so we only sell beer after midday. Something like that. It's kind of a stupid example, but you get the point. And then afterwards, after we did all these validations, business rules checks, we can finally actually add the item to the cart. So we create a cart item. And then because basically all these classes that we have are DTOs with public getters and setters, we need to manually do all the logic over here. So if the items exist, or in this case, if the items don't exist, we need to create a new collection and put it there. Otherwise, we just need to concatenate the items. And finally, save to a repository. Maybe we want to notify someone that an item which is in a watch list has been purchased and stuff like that. And finally, we log that the action ended. So as you can see, it's kind of a lot of logic, and it's a lot for everything. And in this case, we have a controller. So this is a controller with 200 lines of code, so it's not that big because it's a demo controller. But in reality, what we end up seeing when taking this approach is that we get into thousands of lines long controllers. So, but if in your case you have a 200-line controller, maybe just leave it like that because it's not worth to over-engineer solutions. But normally it will be more complex and this solution won't scale. So I'll use the solid principles as an example, even though I know some people love them, other people don't like it. I will use them because it's an easy reference to use, as most people have heard of them. And in this case, I would say solid principles are IP with this approach, because people love to preach solid, and I've been in countless interviews where I've been asked about solid and even what do the letters mean and stuff like that. But what I found after a while is that it isn't really being practiced. And as I mentioned in this example, if we go letter by letter, the single responsibility principle, not really respected, because we have one class, which is the controller, which does everything, all the logic, everything is in the same place. We can also talk about the open-close principle. So open for extension, close for modification. It's really not being respected here because every time we need to change something, we change it in the same place. So we're always hammering on the same class in the same file. Proceeding with the super service. So after coming from the supercontroller, hopefully you can imagine what I will show you right now. So let's go back to the IDE. But basically, we have almost exactly the same thing. But the difference is that we are taking what would normally folks assume is a 3-layer architecture, where we have a controller, service, and eventually a data layer. And the difference is that the controller now only handles the HTTP part, which by itself is not wrong, and delegates everything to a service. But this service, basically, I moved it. It's all the same things moving to a service. So we have the same problem. We just moved it from one place to the other. And now, instead of having a controller which does everything, we have a service that does everything. And besides that, because we can't return directly the HTTP status codes because that part stayed in the controller, now we are using exceptions to notify that something went wrong, which is not how we should do that, but we'll discuss that later. So I would say that this wasn't really an improvement, at least in my opinion. In fact, I would say this is worse, because we just coupled a controller with a bunch of methods to a service which has basically the same amount of methods. So if we go back here and we take a look again at the solid principles and how I feel that RIP in this case again, if we talk about single responsibility principle, it's about the same. The only responsibility we split was the HTTP part, but the rest is all in the same place, the same. Open close principle, same thing as before. And for the interface segregation principle, which is that I, not really, because I would say that this even already happened in the previous case. But in this case, it's even clearer because we actually have a code interface which has a bunch of methods. So we have no segregation. We always depend on everything. So let's now try to start actually improving things, hopefully. And we'll start to try to do that with individual request handlers. So we'll go look at the code. But the idea with these individual request handlers is that we will segregate the service responsibilities, and we'll basically have one handler act as a service responsible for a single use case or operation. And we will be able to reap some benefits of this segregation. So going back here, look at the controller is mostly the same. The difference is that I removed the other endpoints that were just here for show. And we have the same add item to cart endpoint, which instead of relying on the iCart service for everything, now relies on the iRequest handler request response. And if we take a look at this interface, it's just a simple interface with a single method handle, which gets an input and provides an output. Because it's an interface with a single method, this could be just a method, like just a function, like use a func. But as that is not really as usual in C#, I decided to keep it with something more common and use an interface. And by creating this interface, we open the door to a bunch of possible benefits. The first one is that we created this opportunity to create one handler following the exact same pattern for all our requests. So then we can implement it like this, for example. And this is just a simple implementation. We can think of it in other ways. But I created a static class, add item to cart, which inside has everything it needs. A request, a response, and a handler. And the handler is just the code that was in the add item to cart method was moved inside of here. So this is, just by doing this, we are not in object-oriented world yet. This is still procedural. Actually, it's like called the transaction script pattern, where we have one thing that does everything for a specific business logic process. But we at least no longer have a giant service assuming it would be a thousands of line service. Now we extracted some of those lines into one place. Depends on the likes of people. I don't like to have a giant file. I prefer to have a bunch of smaller files. So for me, this is already a win. Besides that, because we introduced this generic interface that can be used in all kinds of requests, we can, on top of this, use something like decorators. So in this case, I have an example decorator, which is a request logging. And that code that we needed to put manually in all action methods or in all service method implementations, now we can put this in this decorator. And in all calls, it will always write this automatically. We just need to configure things in dependency injection and stuff like that, but we don't need to do this manually anymore. And this is just an example. We could as well just use other things like, for example, timing. When we know where to know the time it took to handle a request, we could use it to instrument open telemetry stuff. Maybe create a caching layer for our queries, stuff like that. We could do all of that in this place, so we didn't need to put more and more code inside our request handler. Besides this, I wanted to give a shout out to a recent .NET 6 or ASP.NET Core 6 feature, which are the minimal APIs. And in this case, instead of having the controller, we could have an endpoint. And one of the things that I love about these minimal APIs is that even though it was, of course, possible with controllers, it seems easier to think about just split things. And in this case, I could put one endpoint in each file. Taking this approach, if we don't take advantage of that generic interface for anything, we could just get rid of it. If our only problem is to segregate the super service. Otherwise, we can make use of the interface that we created for those cross-cutting concerns, like I mentioned, using decorators. Or, for example, if we want to use the same approach for everything we do, for example, maybe we want to implement a web API, a gRPC service, or even message handling, and we would like to do it all in the same way. So we could reuse the interface to make our code more similar independently of how we connect it. But otherwise, if we don't take advantage of that, we could simplify and just do everything in the minimal APIs mapping. So depends on how you prefer to do things. So going back here, as I mentioned, this is still not object-oriented. So as I mentioned, but at least there's no more a giant class that does everything. And each class is a use case. So things get smaller, responsibilities get a better split. And another thing is that the relation between dependencies and use cases becomes clearer. What does this mean? When we had a super service, it was likely that we have dependencies that are used just in some methods and not in all the methods. By doing this segregation, the dependencies that we need to handle add item to cart are just that, and we don't need extra dependencies for the other operations that we need to implement. Finally, even though this is still not object-oriented, some typical object-oriented patterns started to emerge, namely the decorator pattern, where by having that generic interface, we can reuse those things to implement the cross-cutting concerns. But of course, as you might expect, we can go much further. And ideally, we'd like our handlers to orchestrate each use case logic and not do everything, because right now they still do a lot and it's all in the same place. So let's take a look at other options, namely OOifying things. So I like to start this with this tweet from Kevin Henny. And he's talking about POJO, so plain old Java objects, but this also applies to POCOs or plain old CLR objects. And I really like this because it's too true. So a POCO does not mean that it's a DTO. It doesn't mean that the class has to be dumb and only have getters and setters. It just means that it's not tied to a particular framework by inheritance or annotation. So, taking this into a diagram, basically what he's saying is that a DTO is like a subset of a POCO. Sure, it is a POCO, but it's a subset. And I wanted really to show this because I just get sad when people think about POCOs as if they only can have getters and setters. And even in Microsoft's documentation, there are occurrences of this, which is not great. So a POCO is just any normal object, and taking into account what object-oriented programming should be, an object should be data and behavior. Of course, I'm oversimplifying the whole paradigm to just one sentence, but you get what I mean. If all we have are data classes and behavior classes, we are not taking advantage of this paradigm. So let's take a look at the code, and let's try to consolidate the domain logic in specific classes. And each class will represent the concept and its capabilities, and enforce invariance to make sure that itself is still valid. The handlers, instead of doing everything, will now orchestrate these objects to achieve their goals. So going into this one, we'll see that now the handle part is smaller. So now you can take a look. We start with the repository stuff. But then where we had a bunch of rules to check if minimum time of day and stuff like that, now we have a item sale rule repository, which gets something for an item ID, and that something is an item sale rule, which has a single validate method of cart, item, and quantity. So these are the kinds of things that are required to validate that we can sell that item in these conditions. Another thing that I wanted to point out is, because it seems that we just want to use interfaces when we want to implement something that will be injected using our DI framework of choice. But the idea of interfaces, it's more than that. It's whenever we need polymorphic behavior, we can use an interface to expose what kind of behavior we allow, and then the details are implemented inside. And in this case, we implement something like one class for each of those rules. In this case, we have a maximum quantity per sale rule. So I just moved that code that was in the handler into here. And the same thing for minimum time of day. And anytime we need to add rules, we can just create a new one. So we don't need to be always touching the handler. We can just add this functionality here. And then anytime we need something new besides adding that functionality here, we go to the repository to map the new thing that might happen for an item. Then, if you look how I implemented this, I always call validate. I don't check if it exists or not. And that's because I use this, I called it the no-op item sale rule, which is an implementation of an object-oriented pattern called the null object pattern, which means that instead of having to check if the item is there or not, we can just call it and it won't blow up because it just doesn't do anything. Also, you might notice that I'm not checking what if items have more than one rule. So again, an object-oriented pattern emerges, which is the composite pattern, and we can just receive all the rules for a specific item and apply them here. And by doing this, we simplified a lot the code in the handler, which just gets the rule and calls validate and doesn't need to think about anything else. So we made it more extensible and simpler. After this, we have the rules in objects, all good. And then we have, if you notice, we're no longer doing all the tricks to know if we can add the item or not. We move that into the cart. And so the cart, which before, as I showed you, was a DTO, which only had a couple of properties with getters and setters all public, now actually has much more things inside of it. And now the get only has getters, no longer has setters. It has the getters because maybe we want to show the cart information on the UI or something like that. But then internally, it has a logic. And for example, it no longer is just an enumerable. It is exposed as an read-only collection, but it is internally using a dictionary because it's just more useful to use a dictionary for the implementation to check if the item exists and stuff like that. So, but this doesn't matter for the rest of the application. It's just an implementation detail of the cart. And the cart is implemented in the best way possible to achieve its goal. And in this case, to implement, for example, an item to cart, we can do all those checks inside of here, and we ensure the cart is always valid. And we don't have the problem that maybe one handler respects things and another handler doesn't respect. No, we are using encapsulation and calling the cart to do its thing. So right here, just a line saying add item to cart, and the cart needs to know how to add the item. Finally, we call save, and we might call an unadded on a listener. And this is basically using the same approach as I showed you for the rules. So we have this implementation, and we have the watch list. So it was that code that we had before in the handler, checking if the item is in the watch list. If it is, notifies. So again, we are taking things out of one place instead of having everything in the same place, and we are spreading the responsibility among objects that represent those concepts. So, what are the takeaways from this approach? We get even better separation of concerns, in my opinion, because now we are creating objects with very specific responsibilities. We get more readable inclusive components, and now the handler code really reads like steps of a recipe, because instead of being a mess with a lot of things happening, now we just call the various things, do this, do this, do this. It's imperative code, but it's, I guess, easier to read. And also, because we are getting rid of a giant thing with a lot of logic into multiple things with some logic, we get smaller units and simpler unit testing. So now the handler could be, for example, just integration tested, while the various classes that we are creating can be unit tested for the various things that they have. So it's much simpler than trying to test a giant thing, and probably we would need to mock a lot of things. And like this, we don't need to mock anything. We just need to pass the correct parameters to see that the things that we expect are happening. And for the rest, we can do integration tests and go to the database and stuff like that. As a bonus, we saw a couple of object-oriented patterns emerge, namely the null object and the composite pattern. And I want to alert that the idea is not to try to shove as many object-oriented patterns as possible into our code, but the other way around. We know that they exist, and as we are doing object-oriented design, we start to see these patterns emerge, and we see, oh, how do I avoid being null here? Do I need to check? Or can I just return the null object pattern, and the code is easier to reason with? So that's the point. Not try to do CV-driven development and put as much patterns in there, but see them emerge as we write code in the hopefully right way. Now, that was the biggest part of getting things to be object-oriented. And now we get to improve things on top of that, namely make use of type safety. And this is really not object-oriented specific, but it's common in such language, and C# is the type-safe language. But it's type-safe language if we make use of its features. So if all we do is pass integers, strings, and GUIDs and dates everywhere, it's not very type-safe, because we can easily use the wrong things in the wrong places because it's all the same type. So we'll look at code again, and we will try to avoid primitive obsession, this that I was talking about using all the same types. In this case, using strongly typed IDs. We'll also try to tackle the problem with the absence of a value by using maybe or enable reference types. And we'll also see a way to implement a discriminated union, which is a common functional programming concept, how we could do it in an object-oriented language, which at least right now doesn't support it natively. Back to the code. As you can see, most of this presentation is code. And we'll go here. And in general, you can see that it didn't change a lot, but it did change a bit. So let's start from the top. One thing that you might notice is that before, the cart ID and the item ID were actually strings, and now they have specific types for them. So one of the reasons this is interesting is because now we cannot make a mistake and pass an item ID where we should pass a cart ID. This is the most basic of things that we get from this type safety, is that we cannot mix things. I've heard people say that it's not worth to create a type just for that. I would disagree, because if you can take 5, 10, 15 minutes to create this type and then no longer have to worry about that, for me it's a win, because I've had situations where we passed the wrong string in the wrong place because we didn't know, or we didn't check correctly. But in addition to that, we can do other things. For example, in this case of the cart ID, there's not much relevant, because this is just, I'm putting a GUID in here, so we're just parsing it normally as a GUID. So besides getting that type safety and avoiding mix-ups, we didn't get a lot from this because it's a GUID. But for something like the item ID, imagine that the item ID, yes, it's a string, but it's actually a string that has a specific format. In this case, what I came up with as an example is, imagine that it has a 3-digit prefix, then a dash, and then a 7-digit suffix. And I've come up with this example because I've worked in projects which had IDs which had specific formats. It was not just a normal string, it was a string with a specific rule set. And normally, how we tackle this, if we don't create these types, is to use, for example, an attribute with a regex that says that it should be with this pattern. And then we need to put validators in multiple places to ensure that it's useful. But what about if we create a type and the type has the logic associated with that ID? In this case, we know that an item ID has this format. So as soon as we parse it and it was successful, for example, I have here the try parse method. As soon as we parse an item ID, we know that when we pass the value around, it is correct. And we no longer need to check, is the string valid? No, we have that object. We know it's valid. With the caveat that I'm using a record struct for this, and the struct has a default constructor. So it could be an empty value. So there's that, and then becomes the trade-off between performance and making really sure that things are correct. So it's a trade-off. But besides this little point, for the rest, the idea is, because we have a type, we are sure that after the first parse is successful, we can pass it around with confidence. So this is in regards to strongly typed IDs, and this is applicable to other kinds of objects. I'm just giving this example with IDs. So next step, I talked about making use of the type system to enforce that we know that the object exists or not. And we have a couple of approaches. First approach, as we can see here, in this cart repository, it no longer just returns a cart. It returns a maybe cart. And maybe, also known as optional or option, is a common type, again, used in functional languages, which doesn't mean that we can't use it in the object-oriented one. And primarily object-oriented one, because C# is multi-paradigm. And what this means is, when we get the cart, it might not exist. So we can make it clear with the maybe that it must exist, or better yet, that it either exists or not. And we must be explicit in trying to get the actual item in there. So here we by doing this, we couldn't mistakenly just try to use the card without getting it out of the maybe value. We always need to explicitly take it out, and that's what I'm doing here with the value war. So this is one option. Another option, which might be more familiar to C# developers because it was introduced as a feature in C#8, it's using nullable reference types. It's not exactly the same thing, but we can achieve similar results. And what we do is have an item and tell it might be null. What I do when I use this feature is I go into the CS_proj file and I add the attribute add warnings as errors nullable. What this means is now the compiler, when we try to use the item without checking if it's null or not, it doesn't compile. So by default it's a warning, but I put it as an error. So what happened is if I comment this part of the code, you see that now we have an error here because the reference of a possibly null reference. So we can no longer forget to do this. On the other hand, not only can we not forget, but if this code, instead of returning a nullable type, was like this, then in this case, we would know that it shouldn't return null, never. So we can avoid writing ifs if it's not needed. So it's not just for the forgetting part, it's always also for the it's not needed part. For the rest, it's mostly the same. So we saw improving type safety by ways of get rid of primitive obsession and in the absence of values. Final thing, and this is, as I mentioned, discriminated union. It's something common in functional languages. It's hopefully coming to C# at some point, but so far it wasn't implemented. So we can try to get to an object-oriented version of this. It's more verbose, but it works. So I didn't show you before, but basically we have, for these kinds of errors, I have a middleware that catches the exception and transforms it to a status code. So over here, what I did is, and why this discriminated union is important, is that what would happen if I created a new type of exception and forgot to go to the middleware and add the handling for that. So we would have an exception that would be handled and we didn't know what was going on. The point of having a discriminated union and making sure that it's checked exhaustively is that we enforce that every case, every scenario is handled. So in this case, I'm implementing it again using object-oriented constructs. In this case, I'm creating an abstract record, but then I'm using a private constructor. What this means is that the only ones who can inherit from error detail are classes internal to error detail. So I'll skip this part, we'll get back in a minute. And then we have the implementations like not found and invalid, and notice that they are sealed. So this means that not only can no one inherit from error detail from the outside, but these not found and invalid are also not possible to inherit from the outside. So we're basically creating a closed hierarchy that can only be changed from here. And the idea of this is that now, if we wanted to include a new type of error, we would need to do some extra changes. Namely, I'm using here another pattern, which is called the visitor pattern. So we have an accept method that gets a visitor, and the visitor has an interface. This interface has a visit method for each type of error. So what we can do here, if I wanted to add a new type of error, I would comment this in this case, and we get an error because there is no visit method. There is no visit method that gets an unexpected error. It just has not found and invalid. So to fix this error, we need to change the iVisitor interface. So we've solved the error here. But if I go to the Explorer, you'll see that over here in the middlewares, we have an error. So this is where I'm doing the mapping between the error and the status code. and it implements that interface. And it has an error because we didn't implement the new value. So this is basically, and as you can see, is a very verbose way to implement a switch statement that is exhaustive so that we cannot forget to implement a scenario. In this case, we cannot forget to handle a new type of error. So again, hopefully in the future, C# will support this natively. It would be great. But until then, at least we have an object-oriented way to achieve it. So after all of this, I probably went too fast on some things, so feel free to ping me afterwards on specific things. But my idea is just to give you some ideas, and then in the future we can learn more about them. So some takeaways of this: we try to avoid primitive obsession, so that it's harder to mix up values rather than solely relying on primitive types. And we could encapsulate logic where it makes sense. I focused on IDs, but this also applies to other usages of primitive types. A common example is, for example, the money type, which is created and has a decimal value and eventually a string representing the currency. So this is applied to more things, not just IDs, but hopefully this was good enough to illustrate why you should care about these kinds of things. Also, maybe nullable reference types forces us to think. We cannot no longer forget to use them, and we can, when not needed, not use them. So it can help clean up the code. Finally, I showed you that weird way of implementing a discriminated union to make it harder to forget to handle a new scenario, in this case, a new error that occurs. So final section, and I will make it quick because it's a complicated thing and not very much. Some people might not agree because we'll see why. But in general, my biggest problem with the exceptions is that in these previous samples, I've been misusing them. And some domain rule would fail and I would throw, and that doesn't really make much sense. Because exception should be exceptional. And even ignoring the performance penalty, we should strive to make the possible domain errors obvious. Not all errors, exceptions make sense. At least I think exception makes sense, but not always. And exceptions related to domain errors are the ones that don't really make sense. So let's take a final look at some code, and we'll return explicit success and error information instead of throwing all the time. So back to the example. And over here. So it's mostly similar, but one thing that you'll notice is that the handle method no longer returns. In our case, it was basically void because we were just doing something and then continue. So in this case, now we are returning either, and the name is very good because it's exactly what it is. We return either an error or a unit, and unit is basically, think of it like void, but it's a type that represents void. So this is again a normally used construct in functional languages, but again, we are in a multi-paradigm language, so we can make use of all of that. So what we have is this either error or unit. So along the way, where we were throwing exceptions for things that are not exceptional, like the cart doesn't exist, it might happen, and the item doesn't exist, might happen. So we will return either left, and this is an important thing. Left is normally an error, and right is normally a success information. There are other ways to implement these kinds of things, but the cool thing of using something like either is that it's a generic construct that we can use in a lot of places and make use of that, of being reused to achieve some interesting things. I'll show you in a bit. But mostly, I changed everything where it was throwing exceptions to using the either. For example, one interesting thing is add item to cart, which now returns either error or the cart item that was invalid. We return left, If it's all good, we return right with the cart item that was created and added to the cart. So this is great, in my opinion, because now it's explicit. We no longer just think exceptions get thrown when things happen that we didn't expect. This way, we need to make sure that we handle all cases, and because they are domain logic related cases, we should be taking a look at them. The problem is, as you can see, the code becomes a little less linear because we need to handle these cases. One approach we can take to avoid this problem is to take an even more functional approach, and I will show you here. And we have this code, which is a same implementation, but making use of some extension methods. And now that code looks like link, or for example, RxJS. So the rules, now this uses something called the railway programming, which means that we are chaining together these calls. And as soon as an error occurs, it basically short circuit and nothing else is called. It just returns the error. Otherwise, it will call the various things to check. Not everyone likes this approach. Some because they find it harder to debug. Others because it feels like it doesn't belong. We should be using a functional language if we are doing this. They're not wrong. It's better in a functional language like F#. But I would say that it doesn't look that bad in C# as well, even if not as optimized as it is in F#. So these are two approaches of using either. You can take this one, more link-like, or something like this, more imperative check. It's a bit more annoying, but even though it's a bit more complicated code, it is it's more explicit, and that's important. And then we can make use of the same things, like handling these errors. Instead of being in a middleware, we can just call toResult and map the results correctly. Again, discriminated units work very well with this. So, final takeaways from the code. Handling the errors became explicit and forces us to think about it, not just exceptions that get thrown and we don't know that's what's going on. It's not the goal to replace all exceptions, but at least the domain-specific exceptions. So, for example, a method receives null on a non-optional parameter. That's an exception. It's probably a programmer failure that we are passing in the wrong thing. But trying to buy more items than allowed, it's not an exception. It's a domain error, and it's something that might occur. So we should just return the information that happened. The downside, as I showed you, is that the code may become a little less linear. Wrong switch. So, wrapping up, revisiting this subject reminded me when I first learned object-oriented programming and got me thinking why, as soon as I started working, all was mostly forgotten. I got into the super service DTO bandwagon. And I really don't want to be preaching object-oriented code. Procedural, object-oriented, and functional are all valid, but I just wanted to say that don't hate on object-oriented languages when you're writing procedural. So I've seen a lot folks complaining about object-oriented being bad or something like that. If you're actually doing object-oriented and prefer the other ones, that's great. You can use the other ones. But in most cases, you are writing procedural code and then complaining, but the language doesn't have the fault that you are not writing in the correct paradigm. So, also, probably some samples that I showed you might remind you of content about DDD, CQRS, and stuff like that. But I'd argue that's because these went back and to the basics to use tried and true patterns and not the other way around. In fact, you can implement DDD and CQRS in functional languages, and it won't look the same because it will be done in the completely different way. It's just that it's common to have literature about DDD with object-oriented languages, and they use object-oriented design to do that. But you can do object-oriented design and not be using DDD. So it's not the same thing. So if you're interested in the demo code, it's available on my GitHub. You can check it out over here. And thanks for coming. Feel free to reach out if you want to discuss some of these subjects. You can reach out through Twitter, as I mentioned, and also through my website. I have a bunch of contacts there, so feel free. Thank you again.
All right, Zhao, that was an absolutely amazing session. I was just looking back and I was looking, seeing that you had not only slides, but a lot of the demos that you had. That was all you might have learned all throughout your time, right? And we don't have many sessions around Oops. So some tips and tricks over there, some of the best practices. So my only quick question to you is how long it took you to build this presentation?
Hey, I don't know.
I think it must be a process, right? It must be a continuous process to build this.
Yes, and the
Mhm.
most, I would say that the most annoying thing is that, as you notice, I have 6 different projects. So I
Yeah.
had to like do something in the first, then copy to the second, then
Hmm.
do the change with the improvements, and then the same for the third, and something like that. And the other annoying thing is that if I needed to change something in the last one, I needed to propagate that to the other one. So
Yeah, I could
it took
see.
a
I
long
could
time.
see it was complex, right? I mean, everything
Yeah.
you stated on the slides, you had something to back it up with the demo. So that was absolutely great. My other quick question is, what's there in the background? Is that a violin that you have in your background?
Over
Yeah,
there,
there is a guitar or a violin. What is
it's a
that?
guitar. It's a guitar.
Guitar. So you play it?
Yes, sometimes
Okay.
when I'm not coding.
Perfect. Next time when we host you, we would ask you to go ahead and play guitar for us. Any final thing, Zhao, you would like to plug in before we move to the next session?
No, not really. I just I think the most important thing is for people, if they actually are interested in object-oriented programming, use object-oriented programming and not the things that I showed you, that it's the most common thing in our industry, but then we complain that we don't like it, but we are using it wrong, basically. We are pulling
Yeah.
an apple. You are using it wrong.
Yeah. So, Zhao, thank you so much for being a part of this .NET Conference 2022. We would love to have you back whenever you're available. We do many live shows and conferences throughout the year, 20 conferences every year. That's what we do. And yeah, we'd love to have you back in some other live shows and conferences. Until then, see you soon and bye.
Thank you.
Take care.
See ya.
All right, now with that absolutely amazing session of Zhao, I think by end of his session, I have learned how to say his name. We now move to our next session. That's by Chris. But before we move there, we have a minute, right? And a gentle reminder that we are supporting our NGO, that's Arman Drive Foundation. We have listed the details on the website. I'm going to quickly play a minute video of them. And after we come back, after this break, we're going to start the next session that is on .NET configuration in depth.
Hi everyone, my name is Sonia Liu. I'm from Nigeria, but I live in Newark, New Jersey. And I want to say thank you to Aman Roy Foundation for, the opportunity to actually be a part of her scholars. Because of their funding and everything that they stand for, I'm able to be here today. So thank you guys very much.
All right, welcome back. So I have dropped the Arman Rai Foundation URL in the comments. If you want to go ahead and learn more about the organization, you can definitely go ahead and check their website. Having said that, it is now we move to our next session, second session of the day. That's by Chris. Chris is a senior customer success engineer at Microsoft on the fast track for Azure team at Microsoft. And I believe I've hosted quite a few people from his team. If I remember, I recently hosted Josh Liudman and Bradley Ball. I mean, you should definitely go back and check the session and see the number of traffic that we get. I love this team at Microsoft. So I'm really excited to host Chris. He has a focus in modern applications built with DevOps, microservices, containers, single page apps, RESTful APIs, and cloud technologies following agile practices. In his free time, Chris is a speaker at numerous meetups like this and conferences. An avid reader and a gamer. We would like to learn on what games does he like. So let's go ahead and bring Chris to .NET Conference 2022. Hi, Chris. Welcome to the .NET Conference 2022.
Welcome. Hi. Thank you. I'm super excited. This is going to be a lot of fun.
Yeah, so we're really excited to have you, Chris. As I was saying just a moment back, that we love your team and all that you do. The Fast Track team are very, very active in the community, and they always take out their time in for different meetups and all. So I'm really excited to host one more guy from that team. So thank you so much. I won't take much of your time, Chris. We're gonna do chit chat towards the end of your session.
Yeah.
I already see you have shared the screen. I've added it to the stream. Everybody else can see it, and next 45 minutes is all.
Great. So today we're going to be covering .NET configuration in depth. Let's go on. Just a little about me. A lot of it was covered in that intro, but if you want to follow me on Twitter or find me on LinkedIn or hit my blog, I've got articles I post there from time to time, and all of the code I'm going to be showing today is going to be in my GitHub repo. I will be sharing links to both the presentation and the code later. So let's dive in. We got a lot to cover. I want to start with talking about what is configuration. And then I want to look kind of historically just a little bit at how the .NET framework handled configuration, and then really focus on .NET today, which kind of evolved through Core, through .NET 5, .NET 6. .NET today kind of handles configuration much differently, and there's actually a difference between some of the console configuration, how that's handled, versus ASP. I want to touch on that. We're going to dive into configuration providers, talk about configuration binding, just so we get all the terms out there that people need to understand. The options pattern, and I've got lots of demos to go through all of this, and then we'll circle back, and if there's questions in the comments, we'll do that. So let's move on. Configuration. Well, I mean, configuration falls into a number of categories. Some of them are just settings, like runtime settings. Maybe it's how many times you want to retry something, or maybe a queue length, something that's tunable or configurable at compile time or at runtime. Maybe it's a feature flag, something that you want to turn on or off so that you can separate your deployment from a release of a feature. I have a whole talk on feature flags. I love them, and if you're not using them, I would definitely look into feature flags. And then the other category is secrets. These are things that have passwords potentially, or certificates, or IDs and secrets. These are things that you don't want checked into your code base. You don't want sitting plain text in a file that anyone can look at. And so we're going to look at all types of configuration, as well as when we apply it. So historically, and I've seen this happen so many times, people get into maybe something like Git flow, or they get into a pattern where they have a different branch for every environment, and they check in configuration for each branch. So the dev branch has some dev configuration. And so when they do a build for dev, they bake in their configuration at the build, and there's a special build just for dev. And then The dev looks at it and goes, oh man, this looks great. And so then they make a new build with the configuration for a test. And the testers look at that and go, oh man, this looks great. Perfect. We should send this to prod. And then we make a new build for prod. So we're not actually shipping the same bits of the application between each environment. There's actually different builds. And so there can be variances amongst those branches, amongst all sorts of those, bits and binaries. Additionally, maybe we do it at runtime. Maybe we have one build. We build once, we deploy it many times across multiple environments. And so the runtime part of the application looks up the configuration, be it on a file, be it environment variables, command line switches, database, whatever. It gets the configuration it needs at runtime, and it is the exact same bits that are deployed to each environment. That actually gives you more confidence over time that the bits we tested in dev are the same bits in QA or the same bits in production. So you can tell I'm slightly opinionated on which way I lean. So why don't we look at how configuration is handled in the .NET framework? This this was a fun one. A lot of it was limited to key value pairs. You would access it through this static class, this configuration manager class. That kind of made it hard to unit test. It made it hard to do separation of concerns. And original .NET framework and ASP, dependency injection was not provided out of the box. So you either had to kind of roll your own, or you had to leverage a large number of dependency ingestion frameworks like Simple Injector or Ninject. A lot of times people would leverage transformation at build time. And so there was a NuGet package called Slow Cheetah you would add in, and you could do transformation of all your different XML files. And because you had different XML files in your project, it was very easy to check them in. And then when you checked them in, suddenly now everyone could just pull down the file for production and see the connection string to your production database. Kind of look like this. And actually, I'm going to just quickly switch over to Visual Studio. So here is just kind of an idea of what this XML configuration file looked like. Lots of settings. They over time, they started adding config sections and capabilities to load like custom keys, and there were lots of brackets and quotes. And I can't tell you how many times I mismatched those, and you're trying to start your application and it won't load because it's invalid XML. And then when you're trying to access them, you would hit configuration manager and you had all these magic strings populating your code. Or you would have to parse your bools and your ints because they only came through as strings. So this is Visual Studio. This was a brand new ASP app I added from Framework. And you can see I've got my settings. I can't just store numbers. Everything's a string. I might have transformations between dev and release builds. And you had to do this. Let me make that a little bit bigger. You had to do this XDT transformation where you might add or remove elements from XML, and you would have to match it based on a name or a key. This is very complex. And there's whole books written about this document transformation. Not fun. So let's get to the fun stuff. Let's look at what it looks like in .NET 6 and ASP.NET. So there is an entirely new configuration engine. It's based on configuration sources, providers, a builder, and iConfiguration. And so configuration sources are pieces of data. Could be files. So we got JSON files, XML files, INI files sitting out on a file system somewhere. Maybe it's environmental variables. Those are the actual sources. Just because they're there doesn't mean the system is going to use those to provide configuration to your application. You actually have to define which configuration providers you want to use. Now, I'll explain later why a lot of it just works out of the box with ASP, because they give you a lot of things for free. But there are providers for, like I said, JSON XML, environment variables, command line. Then there's other ones that are provided by services from like Azure. So like Azure App Config or Key Vault, or you can make your own. Maybe you want to have a configuration provider pointing at like a NoSQL database or Cosmos or MySQL. You can write your own. There's a pretty simple schema to do that with. So we have our sources. The providers are defined. You say, I want to look at JSON files, and I want to look at app settings.json, and I want to look at environment variables, and I want to look at command line. Well, the order you define all of those providers in is extremely important, because the configuration builder is going to start at the top and go down the list and add in each provider to build the configuration and provide it as an iConfiguration. So let's kind of see what that looks like. I'm going to go through some of these slides pretty quick so that we can get to the actual demos. But let's say we've got a JSON file that has two keys in there, environment and DB. Well, the configuration builder will load that first JSON file, and you'll have those two keys. And then it'll look at the environment variables and sees, oh, DB really should be constraint. So it will actually override the value for DB. In the provider list, you really can't remove keys or configuration keys, but you can add or update them. So, we get to the command line and we said, hey, I want my log level to be info. So the final configuration that gets built by the configuration builder has three keys, with DB having a value of constraint. Now this configuration object is a type iConfiguration. So you can inject that, you can reference it, and I'm going to show you how we do that in Razor pages, controllers, services. We're gonna look at all that. So the order you define things is very important, because you can always override a value defined in a lower level configuration source. Additionally, the keys get flattened. So let's say we have a JSON file. We have this structure. We've got a secret key. We've got this object, transient fault handling. Well, that all gets flattened down, and it uses a colon to separate the hierarchies. So it doesn't matter if it's coming from a JSON file, from an environment variable, from a command line string. If there's a hierarchy there, it all gets flattened once it gets into the configuration builder into colon separated hierarchies. And I'm going to get into all of this, but we can define classes. And so instead of those string keys where we're having to do conversions and parsing, we can actually just say bind this transient fault options against a class. So that this class, this section we had right here with two values, we can just bind that right to a class. And I'm going to show you that shortly in our demos. So I hinted at it earlier. Out of the box with the console, if you do .NET New Console, you have no configuration added to the system. Like, it is just console write line. So I actually am going to start with some of those, and we're going to add in that configuration so we can see. But if you're doing ASP.NET and you say .NET New Web App, you'll see that it does a create default builder. Well, create default builder does some stuff inside of it. It loads the JSON file provider and says, look for an app settings JSON. It loads the environment and goes, am I in dev? Am I in prod? Load app settings.environment.json. Add user secrets, which I'll also show in the demos. Load environment variables, load command line. And so this hierarchy, pretty much out of the box, you get, which is why you can leverage environment variables. Why when we load things up into Azure or inside containers, we can pass environment variables to override the configuration in our JSON files. So let's actually look at what some of these look like. I'm gonna quickly go through these slides. I want to get to the real code, but yeah, JSON, XML, INI. There's command line environment, but then there's this keeper file, which is interesting. I'll mention that, show you a slide on that, and memory configuration provider. That is awesome for unit testing. So JSON, we've got our JSON files, and if I have, my configuration object, I could just say add JSON file and give it a path. I can make it optional. So if that file doesn't exist, my app won't blow up, or I can make it required. I can even have the configuration system reload the file on change without restarting the application. If you remember from .NET Framework, or maybe if you're not aware, if you change the web config in a .NET Framework app, the whole app would restart. We can prevent that now if we want. XML is not a web config format. This is literally like a class serialized out to XML. So we could read this in and bind it. You can see we have the same set of keys and values in the XML version as we did in the JSON version. So it is a serialized class essentially. Environment variables. We can actually do a couple of interesting things with this. We can define a prefix if we would like. So instead of just, secret key, we could say, hey, I need it to have this certain prefix. So I'm looking at a given, implementation. And notice we don't have colons here. We have double underscores. So some operating systems can't handle colons in their environment variables. And so anytime you use the double underscores as separators in environment variables, the system, when it reads them in, will automatically convert that into the colon in the final configuration. Command line. So command line actually gives you some really cool things. I'm going to show you this in our demo. You can define mappings. So I talked about that hierarchy where maybe we have multiple levels. You might not want to expose that on the command line. Maybe you want to make it easier and provide a shorter command line switch. Well, there's a mapping capability built into the command line provider. Key per file is something that is used in like a Docker situation where maybe you're mapping a secret collection or secret provider or configuration as a directory inside that container. And you could essentially have the application look at that directory or load the configuration from that key per file setup. So that's more of a container usage, but I wanted to call it out. And then, like I said, let's say we want to do some testing. You can invoke the memory collection provider. So maybe in dev or in a test scenario, we define a number of key configurations right through memory. And so now, right before we get to our demos, I just want to cover the other thing that's super powerful in the .NET configuration library, the options pattern. So I showed you quickly, and I'm going to spend more time in the code, binding a class to a section of the configuration. This really drives interface segregation and separation of concerns. We're depending on classes. We only need the configuration that we need, and things are more isolated from other parts. It gives you 3 different types of I options, and I'm going to go over all of these. But I options are singletons. Something to be very aware of, and I'm going to reinforce it in the demos, is when we start injecting options into our code, they're created at the start of the application, and they're singletons, and they just live forever. So they will not change values, and you can't use named properties, which I'm going to cover. There's 2 other mechanisms that allow you to support reloading of code, but snapshots are very transient, so you can't use them as singletons, which is why we'll use the monitor. So let's get over into the code, and let's start going through these concepts that I covered. This code is up on GitHub, so I will make sure we share that link. But let's say I do a .NET new console. All I've got is a console write line. There's no configuration here. But let's say we want to add some configuration. Let's say we want to add this config file, config JSON. I want to define a greeting and maybe an environment. So very simple configuration file. I did add it to my project just to copy it to my output directory. But here's my code. So I'm using this extension, this NuGet package, Microsoft Extensions Configuration, and I'm making a new configuration builder, and I'm adding in that JSON file, and I'm building it. And I'm pulling out the greeting. Again, I know this is magic strings, but I'm pulling out the configuration greeting, and I'm pulling out the environment name. So let's see what this looks like. So it's pulling that configuration. And so let me change this to, we'll rerun it. So very simple. I've been able, on my command line app, I'm able to leverage the configuration builder to load in this JSON file. All right, cool. Well, let's look at the next level. So let's look at this program. So I've added in another extension. This time I'm adding in environment variables. So if I look at my project, I've got a package reference for configuration, one for .json because I want to load in JSON files, and one for environment variables. So let's try running that one and see what we're going to do. Back to hello world. Well, maybe, so I'm running in a container, I'm running in bash. Maybe I want my, I'll do it this way. Maybe I want my environment to be stage. I haven't changed the config file, but the system pulled that environment variable I just defined. Usually when you define an environment variable on the same line as the application, it is only for that one invocation. So if I run it again, it's just going back to the normal config that's defined in there. If I wanted to make that kind of a permanent change for my shell, I can do an export. So I'm going to export, I'm in stage. When I run it again, what that means is from now on, any commands I invoke are also going to get that environment variable. So we've layered on from our JSON file, our environment file. All right, let's take this to the next level. Let's see what we got next. So next, we're going to add in command line. Remember, I exported my environment stage. It's still showing stage. If I look in my environment here, that says dev. And we've defined the order of things. I did add a little bit of code, so I can say .NET run. Chris should say, hi there, Chris. And now maybe I want to override the environment back to dev, or let's say it's prod. So you can see there's this hierarchy going on. Configuration has defined these two values. The environment has defined another value. And then my command line has provided another value. And so it's doing it in order, and my environment is overriding my command line is overriding what's in my environment. All right, let's keep going. So I added a couple things here just to show user secrets. I will go more in depth into Key Vault later, but user secrets are a way to have similar values in multiple environments. So I can do .NET user secrets init, and what that does is it creates an ID in my CSproj file. And in another directory under my user profile, there is this GUID, there's a secrets.json file that gets defined. And I can then list out the secrets that are defined in there. And when the program runs, it will load them. Now, if I don't have user secrets defined, this program would blow up. I might need to do optional true that says, hey, if I don't have any user secrets defined, it's okay, you can still run. Now, in my config JSON, I don't have any of those values. I don't have an Azure tenant or client ID or secret or Key Vault name. Maybe I'm expecting when I deploy it out to production, those will be environment variables, or they will be defined somewhere else, and so I don't have them, in checked in anywhere. I hate doing that. I hate the checking in of the code of secrets. But let me go out to my Azure portal real quick. And I'll just show you I have a key vault there. So here's a key vault. I have some secrets here. Don't tell anyone. And so I have a secret. It says test. So now if I run this, this has gotten the value test. So it loaded the configuration values needed for my Key Vault client from my user secrets, because I did a user secrets set, and I will set environment production. So now I've saved environment production to my local secrets. So environment still says stage, which you saw previously. I did not pass a command line overriding production, but it pulled that production from my secret store. And now if I do this again, yeah, command line should override what was defined in my user secrets, which it did. So order is important. You get to control it. You get to define it. All right, let's go into the next demo. And I will skip ahead shortly. Actually, I'm going to go ahead and skip ahead to so I mentioned the mappings earlier. So I have mappings, and I have this hierarchy of messages and configuration. So I have greeting, and then I have color, and I have message hello. And you can see I can override color by using the colon or by using the double dash. Right now it's showing hello world in red. So I can do hello Chris. I can say greeting color blue. Now it's showing hello Chris in blue. Well, I don't like doing all the colons and hierarchy. I'm letting a lot of details about my application out. I can now use the short mapping instead of the long mapping. And all I've done is use the command line, pass the args, and pass this dictionary of mappings. So that's pretty basic. Again, I wanted to, I'll just kind of show through these really quickly. Here I have a flat configuration. Maybe I'm making a markdown tool that's going to output in various formats, and I can pull out all my configuration one after another. Maybe I want to start remapping this stuff into a hierarchy. So I could say, hey, I have a PDF and it has these common properties. I can still do the same thing, PDF, file extension, PDF, output here. So I have that hierarchy. Well, we can start using sections. So this is a cool feature where you can say, I want to get a section. So I have my configuration. I want to get just the PDF section. And what that does is it kind of gets rid of the hierarchy. I can look at the configuration instead of looking at the entire configuration. I can look at just this one section, and now I don't need to define PDF colon. I don't need the hierarchy. I can just talk about file extension, output directory, and template file. So that makes it very easy to start having reusable code where I can start dealing with sections. And if I want, I can take that a step further. I could define a class where I have file options and it just has these three things. And I can bind a section to an object. So there's two ways to do it. You can make your own class and instantiate it and pass that into the bind function, and the configuration will match, ignoring case, the configuration keys and set them on the set the values. Or you can just say, hey, and for this section, give me one of these objects, and it will return an object. Now, these have to be public classes. They have to have a constructorless option, and they have to have getters and setters on all of the properties that you're setting. But this is one way that you can do it. Well, let's look at instead, because we got about 15 minutes left. Why don't we dive into ASP, because this is where things get fun. Go ahead and run this application. So here is my ASP app. Let me open it up in my browser. So I have added a Razor page to show the providers. So out of the box, you can see we have that memory provider, we have a change configuration provider, we've got app settings and development, we've got environmental variables with a default prefix, and yeah, we're getting all these things. Where's that coming from? Well, in our program, I'm getting that from Create Builder. So Create Builder is setting up all of those providers to injecting configuration. I'm going to cover what these are in just a sec, but I earlier talked about how we handled getting configuration. So, maybe I want to inject configuration so I can see these values. Those values are coming from my app settings. I've got this Markdown converter section. I've got settings here. That particular page was my injected configuration. And so I injected an iconfig. So I'm injecting all of the configuration in the system, everything built up from JSON files, environment. They're all sent here, and I'm saying, hey, give me a section. Give me the Markdown converter PDF section as a file option. Give me that one. Just kind of add it to this list, and then loop through it and show all the values. So I can now inject my configuration anywhere I want. I don't have to leverage a static configuration manager. Okay, that's pretty good. And I'm going to, just for clarity, I'm going to do this so that I can have them side by side. So now we're going to look at what I options look like. So this looks very similar. Let me go here, injected I options. So an I options, I'm injecting an I options of Markdown converter. Well, I don't remember seeing that in my program files. Where is this I options coming from? And I want to explain this because this is super, super powerful. So when I said builder services, I want to configure this type of class coming from this section. This is very similar to what we did before. We have our app settings. We have a Markdown section. I'm just pointing it at a class. That class is this Markdown converter. It's got a style. It's got PDF, HTML doc. These all match the names of these. But when you tell the system, actually, let me do this. When you tell it to configure this class against this section, it doesn't just give you a raw class. Like, it doesn't just say, hey, I'm going to inject a Markdown converter. That's not how it wires things up. What it does is it gives you an I options or an I snapshot or an I monitor. And so these have different behavior that I want to show. So let's go back to this I options. This I options, you can see I'm just using the markdown converter model. I'm just outputting it. That's all I'm doing. I just said I want an I options of markdown, and I'm getting the markdown value. So if I go in here in the app settings and maybe I change doc from false to true, and I save the file, this did not reload. But if I come in here, this did not change because this I options of markdown, this I options of markdown converter, that gets instantiated when the configuration is built and it's the first time it's injected. So what if we want to have our code reload on the fly? Well, see, this one says true. So why don't we look at the snapshot and kind of what that looks like. So again, the exact same thing. I just said I want to inject an I option snapshot of markdown converter. Again, I didn't wire that up in production or in the program CS. I just pretty much said map this class to this section. So again, I'm getting the value and assigning it here. But now, if I'm hitting F5, this says true. If I come in here, this is live updates that are not having to reload the application. Let's go back and look at monitor. So this is saying false. This is saying true. I hit F5 a couple of times. There's a small difference between a monitor and a snapshot. So a snapshot is anytime you request it, you get the latest current value right now. So if you have this huge chain of dependencies and at some point lower down, somebody requests the configuration, you might have a different configuration value from the initial, top of the chain all the way to the bottom. This one might get false. This one might get true because they requested them at different times in the request flow. Monitor, though, is kind of transient. It is per request. So once this request starts, everybody in that chain is going to have the exact same value until a new request comes along. And then everybody in that chain will have the exact same value. So there's advantages and disadvantages to using monitor and snapshot. But then we also can have another problem that I want to talk about. We've now depended our code on options code. We have to reference I options in our code. So we have using I options. We need to know about values. When I'm doing monitor, the monitor is its current value. So current value. Either way, we are now depending on the options classes. We have this dependency on them in our code. So one of the ways we can get around that is using the dependency framework inside of ASP. So we could maybe, if we wanted, we could define an interface that maybe just returns an instance of a configuration class. We could then have that depend on maybe an options, I snapshot, I monitor, and then this could have the dependency on options, and our code wouldn't have any dependencies in options. Now, I did have a couple of things here commented I wanted to show you specifically. We could do transient, we could do scoped. All these work great. There is one combination that won't work, and that's if we have this be an I options snapshot. And the reason why is I option snapshot, remember, it's transient. And so it actually will give you an error because export service, maybe I'm defining it as a singleton, but iOption snapshot is only transient. So or scoped. I can't inject a scoped service into a singleton service. So this is where I had that code originally as an options monitor. And then I could still get those updates. And I've only got about 5 minutes left, so let me show you a couple more demos real quick that I think are very interesting. So there is a thing called named options. So if I were trying to do file options, there's 3 different instances of file options. If I want to load multiple copies of that file options into the configuration, I can give them each a different name. So iOptions doesn't work with named options. So if I go into my pages here, and let me real quick. Here we go. This is how, so you can obtain named options where you can say get and give it the name of the option that you wanted. So looking at this one, I don't think I loaded the right screen. I can still load them, but if I try to do the named options in iOptions, it can't understand what those are. We only got a couple minutes left, so I will quickly show you Azure App Config. You can see this uses the default builder, and then it gets out a connection string and is using that connection string to configure Azure App Config. So I can this one I have I had set my connection string on another machine. I could do that real quick. But and let me look at this one. And this is Key Vault. This uses the AZ CLI. You can see this adds the .key vault and pulls the builder configuration value and loads secrets that way. Let's see. How are we doing on time? Are we right at time? Okay. So just going back real quick, this is what I was talking about with the options, where options is singleton and monitor is singleton. This does not support reloading or named, but these two do. So let's see now if I can take a minute and get that demo for the config running real quick. Add my secret in. Normally, I would be doing this through a CI/CD pipeline. Okay. Either way, demo gods as they be. I will wrap it up with that. I'll go ahead and make sure I share this repo out there. Let me see if there's a couple of comments or questions to ask. It doesn't seem like there's many questions. All right. Well, thank you all for joining me. Like I said, reach out or follow me on Twitter or LinkedIn. And thank you for having me today.
Hey, Chris, how's it going?
Going well, David. How are you?
Good. Glad to see you. I'm finally on the conference because I had to wake up and take a shower and on the West Coast, it's still kind of early here. So that was a great session.
Thank you.
Configuration is something that I don't think a lot of us think about, and it's super critically important. And I see most teams get it wrong. So.
Yeah, main things: never check it in. Do not check in your like secrets, leverage pipelines, and now as we move towards a lot of containerization and things like Docker and Kubernetes, environment variables are usually defined quite a bit, or tying into Key Vault, or in Azure we do managed identities. Don't even need really connection strings or secrets if you can trust the identities running on the platform.
Yeah. I did have one question while I was watching your session, and
sure.
The new stuff they have out for the configuration seems like it's really great for maybe very large applications. But how about somebody who's just writing an app that he's going to sell to people? And do you recommend using this or maybe something else that's in the .NET, .NET 5.6 world?
Well, I usually pair Azure App Config or Key Vault with most of my applications, just because I want my secret secure, so I leverage Key Vault, and Azure App Config provides a not only global kind of configuration that can leverage Key Vault to back some of its properties, but it provides feature flag capabilities. And then I only really have to worry about transforming or dealing with one thing, or two things: my connection strings to app config. Right. Now, if I'm just doing sample apps locally, I make an app settings, or I make some sort of JSON file and I just leverage that. I'm not a fan of hard coding things typically. No. So yeah,
never hard code stuff. I've been a software engineer for 30 freaking years, and I still see people do it.
Yeah.
And
some of these samples, I had a couple of strings for sections, but a lot of times you'll define a class and you'll use name of the class. That way, the sections and the classes all dynamically change, and there's no coded strings and magic values in there. And I just love, I don't have to deal with parsing and binding. I mean, how many times have we, in framework, tried to int parse a string because we got the wrong the wrong type and the wrong key name, and
right. Well, it just kind of reminded me, because Simon's going to get mad at me, I'm talking too much, but it reminds me, I was working for this biotech company here in San Diego, and the web guys gave me this DLL about credit card processing to put it up on the the web server, because I was in charge of all that stuff. And me being anal about kind of stuff like that, I looked at the DLL, and what was at the very top of the main class, the username and password to our ERP system. I said,
well, I mean, that's crazy.
Like,
man.
No, this is not going on our server. I gave it back to him. I go, try again, and it.
There's so much of a safety net nowadays that we don't even think about it in some cases. If you try checking in code in the GitHub that maybe has some of your secrets, it'll tell you, and then it'll go and validate the key. There is secret scanning and protections built in, but that's not on every platform, and that's not everywhere, especially a lot of enterprise internal systems where people can check in stuff and, in their JavaScript, there's some secrets to go connect to some backend API. And
Yeah.
Ooh.
And before I let you go, the one other thing is don't log stuff like that too. I mean, some people log, like their database connection strings or even
usernames and passwords.
No, don't do that.
Never log PII, never log secrets.
Yeah.
Never, 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 never.
Never, never, never. Well, thank you very much for that session. It was great. If you ever want to come on the Rockin' the Code World show, shoot me an email or
I'd be happy to.
Yeah, and we can talk more about this because this needs more than 45 minutes, I think.
Yeah, I agree, but
yeah,
it's still an important topic.
Yeah. Well, thank you very much, and I hope you have a great rest of the day.
Thank you.
Thanks. Well, that was a great session. Day 2 is off to Simon.
Hi, David.
Hey,
that's why good morning. How are you doing today? That's why I say you are the best guy when it comes to this .NET C# posting. You add a lot of good content after the session. You have a good thing to talk. You have so many stories to share. But for me, your best stories remains the AI Gen one. We're gonna talk about it some other
I can tell that story on the conference if you want, if we have a couple minutes.
Yeah, we would, but we are running a little late for the next session.
I know.
The next session is by Chris. He's going to talk about source and incremental generators under the hood. And David, you have helped us a lot with this session arrangement, right? And just filtering over like 130 sessions. What made you pick this particular session?
Well, partially, I'm really interested in source generators. I know source generators just came out, but what I've seen so far, and I'm still in the very beginning stage of learning source generators. What I've seen so far is they're good. They're very powerful, and I think there's going to be use of source generators more and more and more in .NET, and so that's why I made sure we had a couple of sessions about that in today's lineup.
Yeah. All right. So having said that, without any further ado, let's invite Chris second time, his second Chris, one after the other. He's a senior compiler engineer at Microsoft, and let's bring him in.
Hi, how's it going?
Hey, Chris, how's it going?
Hi, Chris.
Hey, yeah, nice to be here.
Yeah, I'm really looking forward to the session like Simon was just talking about. Source generators are going to be a big thing, I think. And so
I certainly hope so.
Yeah, well, we need to start learning it now because I think, it's going to allow us to do a lot of powerful things that we might have been able to do it before, but it'd be very painful, so.
Yeah, absolutely.
Yeah.
All right, Chris, we won't take much of your time. I see you have shared your screen. I'm going to add it to the stream now. Everybody else can see it. And next 45 minutes is all yours.
Perfect. Thank you so much. Okay, so hi, my name's Christian Kevich. So I'm a senior compiler engineer at Microsoft. I work on the C# compiler. And I've actually been at Microsoft for just over 10 years now. So I actually started way back when in the UK, which, as you can probably tell from my accent, is where I'm from, as a consultant. So I'd actually go in and work with companies and solve their business problems using .NET. In 2014, I moved over to Microsoft Research, where I was working on computational photography, machine learning, computer vision, and some of the early stages of what eventually became cognitive services. In 2017, I moved over to the .NET Runtime team, and I was working on some fairly low-level diagnostic stuff, and primarily the debugger bring-up for the ARM32 platform. And then in 2018, I joined the C# compiler, where I've been since. And for the last couple of years, I've been actually leading the source generators effort. So that's what we're here to talk about today. I should say, like, everyone, I'm still working from home. I have 2 great dogs, but they sure do love to let me know when the mail carrier turns up. So if you hear them in the background, then I apologize in advance. Okay, so what are we going to talk today? So we've kind of broken this talk into a few different parts. First, we're going to do a kind of high-level look at how source generators, that's iSource generator, actually works and how that fits into the compiler. And we'll just do a little bit of that because really it's going to give us some context about where that falls down. And then we're going to look at incremental generators and show how that fixes those problems and those issues we have. We'll go through, we'll actually learn how to build an incremental generator, what it's doing. We'll do a demo, we'll look at some code, we'll play around with the debugger, and then we'll go kind of low level and we'll see exactly what the compiler and the IDE is doing to actually enable that incrementalism. And then if we have some time at the end, we can maybe look at some of the things we're thinking about doing in the future. Okay, so start with the high level view. So at a sort of 40,000 foot view, a source generator really you can think of as just having a bunch of phases, right? It has an init phase, which is your initialize method. It has a post init phase. So if you register for post initialization during init, then you run this. And this is where you can basically add source trees that have no context, so they don't rely on any other code in the compilation. You can then also register a syntax receiver. So if you register that in your init, we'll basically create one of these, start throwing syntax at you, and you can start building up a picture of the world. And then finally, we have execution, right? So we actually run your execute method, you go through and you produce code. But how does that actually tie in with the compilation, right? Because you can see these individual stages, but it'd be nice to see how like the compiler sees it. So if we think about it from the compiler's point of view, the first thing we're obviously going to do is load the components, right? You have to remember these things exist outside in their own assembly. So we actually go in and we load that DLL and we go and find your generators. And then we're going to go find your generator. And the first thing we do is init it, right? So we really do. We load you, we call, hey, go initialize. If you register a post initialization step, that's when we run it. So again, it really is, there's a reason it's post init because we run it straight after initialization. And it's at that point that your generator can then provide a set of syntax trees back into the compiler. So we've loaded, we've posted it, and we've got these trees. The next step we're going to do in the compiler is actually go load the rest of the source code, right? So you can see how before we even look at any of the user source code, we go find your generators in it and do the post in it. So then we get the user source code. So we've now got two sets of syntax trees. And it's then that we actually go and create your syntax receiver if you've created one. And it's there that we start throwing all the syntax from both post init and source to you. And when you're in your receiver, you can then start asking these sort of semantic questions via the semantic model of, what are these things? Is this X the same as this X? And we call this like speculative binding, because at this point, stuff in the source could be referring to things that haven't been generated yet. So when your syntax receiver, the world you're seeing may have errors, it may not even compile. And so it's basically a sort of best effort view of the world we can give you at that point in time. Finally, we call execution, we pass your syntax receiver in, and that's where you actually then go do your generation. We now have three sets of trees. We've got those init ones, the actual user source trees, and the generated source trees. And it's at this point that we have a full view of the world. And that's when the compiler then goes on to do the full binding and lowering and everything else and creates your DLL. And so from then on, your generator isn't involved. And so from a source generator point of view, it's actually not that complicated, right? It's a relatively simple pipeline. But what's wrong with that? Well, the main problem with this design is basically perf. So the iSource generator model, it works really, really well in the command line where you do just have this linear pipeline, right? The compiler starts, it does some stuff, it does some more things, the compiler exits. And that's true of CI and stuff as well. But in the IDE, this is not totally true. And it mostly works well. But when we look at it from the IDE point of view, we have this kind of blue section, which is really running over and over again, right? So every time I'm typing keys, we've got to update the source, go run the syntax receiver, do the binding, do the execution, get it, and then go figure it out to decide what we're going to show in IntelliSense. And it turns out that actually that works quite well. Like we were surprised to ourselves when we first did this, that it seemed to work quite well. And the performance generally scaled linearly until it didn't. And we never actually saw this in our initial designs. So it was a bit of one of those, like, we started seeing these reports. And basically it turns out that, as you get bigger and as you add more files into the project, sure, syntax receiver architecture takes longer to run, but linearly. So, if you get, it's nothing runaway. But when you get up to a certain point, suddenly you just fall off a cliff. And it turns out that it took us a while to figure this out. But what's actually happening, if we think about how a syntax receiver works, at the bottom here, we have all these little green squares which represent syntax trees, right? And they have nodes in them. And if we want to pass the syntax in, what we do is essentially a linear scan, right? We send a node up, we send another node, we move on to the next tree, we look at those nodes, and so on and so forth. And we work through until eventually we get down to the other end of the trees, right? But if you have lots and lots of these, then by the time you get down to these nodes, these trees on the left actually start getting paged out of memory, right? The IDE cannot hold all of these syntax trees in memory at once. Now, in a linear scan, if you're then done, it's fine, right? We're never going to go back to them, so it makes sense to page them out. But in the IDE world, we loop back, right? We type a key and we loop back, and we've typed a key. We want to go and do a scan back of these nodes again. But the first thing we've got to do is actually rehydrate them, right? And that takes time. So suddenly it's much slower on the second run through. And then again on the next node. And what's happening is these are rehydrating, come back into memory. Of course, we couldn't fit all the trees in memory. So these ones at this end are now paging out. And so essentially what happens is when you get up to a certain size of project, suddenly when you can't fit all the trees in memory, that's where the perf just falls off, because every single time you hit with the syntax receiver, you've got to page the tree back in from memory. And so you just get into this horrible loop. And unfortunately, it's just kind of a fundamental limitation of the source generator design, well, specifically the syntax receiver design. And it's not one we foresaw. And unfortunately, there's nothing much we could do about it. And it kind of really gets to a bigger point, which is that everything in source generators, the compiler doesn't really know what you're using, right? It just kind of throws syntax at you. And then it goes, okay, here's the compilation and some other stuff. Go party and produce some source trees. It doesn't know what you've used. And so we kind of wanted to take a step back and reimagine what we could look like and say, well, what if we did know? What if we could actually track the different things that we're using in your source generators? And so that's where we came up with incremental generators. So incremental generators are a complementary API. They don't replace iSource generator. They live alongside it, and they're more complicated, but they do allow for much better perf. And so a sort of rule of thumb to think about this is that if you're building source generators on your internal business solutions and you know the size of them, then iSource generator is a fine API to use, right? If you're not seeing perf issues, there's nothing wrong with using that because you know the number of trees, you know you're not hitting this problem. If you're shipping them in NuGet packages to other users, then you really want to switch over to incremental generators because ultimately, you can test it on a large solution and then someone can come with it in a really big one and it will just slow everything down. So that's really the way to kind of think about these. So at its core, an incremental generator is quite similar to an iSource generator, right? We have this generator attribute. We implement this new interface, incremental generator. And what you'll probably notice is that we no longer have initialize and execute. We just have initialize, right? So all we're going to do is call the initialize method. So how do we do this if there's no execution method? Well, one way to think about it is that iSource generator is kind of procedural. What we saw that was do this, then do this, then do this, and then do this, right? Whereas incremental is sort of aims to be more declarative. And instead of really saying, oh, this is just the code that executes, what you do in incremental generator is build up a kind of model of execution. It's essentially a data structure that says, these are the things I want to perform on the data so that I can generate source. And then the compiler in the IDE can actually just execute that on demand as it needs to, rather than all the time calling execute. It just calls the bits that it needs into them. So this is how we get these insights into what you're using. And the real basic building block of all of this that makes this work is the I-value provider. And I said I-values provider because there's actually two. There's an I-value provider and an I-values provider. And these are basically just sort of opaque boxes, right? You can't actually get at them. You can't actually do anything with them. And if you dot onto them with IntelliSense, there's nothing you can do with them. And the way to think about them is essentially a container that's going to hold a value. So at some point in the future, this box will get a value put in it, be that a compilation or an additional file. And the reason we have value and values is that a compilation will only ever have one item in it. So it's always a value provider, whereas additional files has sort of 0 or more. So that's a values provider, right? So that's kind of the distinction. And out of the box, we actually give you a bunch of these. And so this is how you really start your transformation pipeline. So we give you things like the compilation, the additional files, some other things like metadata. And these are the things you start with. So these are the boxes that at some point will contain these values. But what do you actually do with these? So you get to these from the context, right? So you can go grab these off the context. So this is going to be the first thing you do in your initialize method is actually go pull these get these providers and then start doing things with them. You may notice that in that list there wasn't a syntax one, right? So there was compilers, there was compilation, and there was additional files, but there was no syntax. And so syntax works a little differently, and we'll go into this in a bit more detail later on. But essentially, you sort of make your own input provider. And you basically have two steps, and it's a syntactic check and then a semantic check. So this is the only one that we don't just give you out of the box. You basically say, this is the input I would like. All right, so how do we actually use these things once we've created them? So, they're not very useful on their own, right? So basically, the generator system has a set of transformations, and actually these are extension methods. So if you do dot on them, you do see things, right? So they actually take these value providers in, and they create a derivative value provider. So you have a value provider goes in, you perform some transformation on it, and you get a value provider out. And effectively, you can then chain and split and combine all these different value providers and transformations to build up an execution pipeline. And a good analogy to think of is this is quite like LINQ, right? So if you do, a select and a where, then that code doesn't actually execute at that point in time, right? If you then do dot to array or dot to list, or you enumerate it, that's when it actually happens. And so really what we're doing here is you build up a set of steps. You say, at some point in time, I want you to transform a compilation from this thing to this thing, and we will actually then call that as we need to. So LINQ is a good analogy. The first transformation we have is select, right? And so a select is just a simple one-to-one transformation. So you start with a value provider, you select it, you change, you do something to that result, and you end up with another value provider of the result. So a little more concretely in code, in this example, we start with the compilation provider here, and then we provide this select, right? And we pass in this lambda here that will be executed at some point in time, but actually not right now. So this execution is deferred. And when that does happen, we end up with this incremental value provider of string, right? And so this essentially here says this compilation provider is a box that at some point will contain a compilation. And when we want to, we can run this assembly name code on it to produce this other one. And this value provider is a box that when run will provide string. And so actually what we're doing here is we're just taking a compilation and we're selecting it to be a string. Now, value providers, with select, you always go as a value provider to a value provider, right? There's always one-to-one. But a values provider, how do you have a one-to-one mapping? Well, the way that works, and again, we can see this concretely, is if we look at the additional texts, it looks basically the same, except that the value that comes out is a values provider, and this is a values provider going in. And effectively what we do is we run this code here for every input. So rather than just running it the once, when we have these values, we push additional file 1 in, we run that code, we produce path 1, we push additional file 2 in, we run that code and produce path 2. So the derived values provider now also has 2 derived values. So that's the way it's a one-to-one. For every input value, if it's a single one, you get one output. If it's multi-value, you get the same number of multiple values out again, and you look at them one at a time. So a quick aside on this, some of you may be thinking, I kind of recognize some of this terminology, even more or less so than LINQ. And if you know what this word is, then congratulations. Yes, this is monadic composition, and essentially value providers are monads, and we have like bind in form of select. If you don't know what this is, don't worry. It's just oh, okay, this is kind of how it's based on under the hood. So if you do know that, then that's a good way to sort of think about some of this stuff. We have more transformations. We have a where transform, which again is very simple. It's just a Boolean filter. So you can say, oh, I don't want all of these additional texts. I just want to sample them down to some subset, and you get the same type out. We also have things like a select many, which is less useful, but sometimes you need it. And so this basically says, oh, for one input, I can actually produce multiple outputs. So here for my node 1, I've produced 1.1, and then for this one, I'm just going to produce 1 output, and then for 3, I'll produce 2 outputs. So you can basically fan out and select multiple items from the input items. The next transform we have is called collect. And essentially what collect does is turn a values provider, so one of multi-values, into a single value provider. And you can kind of think about this as like being a vector into a scalar operation. So here on the left, we have our 3 values. We have nodes 1, 2, and 3. But on the right, we've only got 1 value, and that's an array of all 3 nodes. So, when we said that select is 1 to 1, well, what if you want to look across different additional files? You can't, right? Because we're only going to call you for each additional file. There you can collect and then select. And so now we'll say, okay, here's all of the additional files. You can work between them and pull out the information you need. And then the final thing you can do, which is the sort of most powerful one, is to combine these, right? So up to now, we've had additional files, or we've had compilations or metadata, but at some point you're going to want to actually look something up in the compilation from an additional file. And that's where you can combine these input sources together. And so we end up saying, okay, for each item in the top one, pair it with the item in the bottom one as a tuple. And this can get a little unwieldy in code. It's quite low level, but it does let you do everything you need to do. Finally, of course, you're going to want to do something with these things, right? Like we've made these chains of stuff and you've got some information, but you actually want to generate some source, right? And so we have this method register source output, and we have a few other of these outputs as well. And essentially, so for every value in the provider, we're then going to run a function, and that function has a context on it. And you can really think about this as being finally being the analogy to the execute method, right? We say, okay, here's the input data that you've shaped and shown us what you want. Now go generate some source. So it has a .add source. You can also do your report diagnostic. And the source output is the end of the pipeline. You can't chain off of it again. It doesn't produce a value provider. It just returns void. But you can have multiples. So if you actually want to split your chain and send one to generate some sort of source and generate one to the other, you can do that if you want to. Okay, so there's a lot of terminology and slides. Let's go look at code so that we can actually try and make some sort of sense of what we're looking at. So we have here this tester project, and we've got a couple of additional files. We've got a dictionary, and we've got this other dictionary, another file, and then we have a couple of these class files, right? And if we actually go in and look at our dictionary, you can see they're pretty simple. They're just a key value pair. So we have some key and some string value we want to pull out from it. And the same with our second dictionary, just some other value, right? And what this generator does is allow us to basically define a partial method that will return the value from the dictionary. So we say, oh, I want this method to return the value from this key. Now, obviously, we could actually have the generator just generate this class for us, right? It could just go through the dictionary and make one for every single thing. But imagine if this dictionary has like 10,000 entries in and you only want 3 of them, right? There's no point putting all of this in. So the idea here is that you might have multiple data sources and you just want to pull out small slithers of it at compile time to put into your program. And so when we do that, we get this very exciting program where we can just write the value out. And if we run it, it's extremely exciting and says hello world. But I can go back to my dictionary and I can change this value and we can run it again. And we can see that indeed it is actually pulling the value from the XML, right? So it's changing it. And in fact, we can actually do better than just running it. We can actually go look at the code. So if we go look at our analyzers and the incremental analyzers here, you can see what we're doing. So the generator itself is creating 3 files. It's creating this from dictionary attribute, which is the thing you put on your methods, and that's done through post init. And then it produces a file for each one of our inputs, right? So the values that we looked at, or values 2, it generates a file called values and a file called values 2. And when we go look at those, we can see here's the generator code. We see this is auto-generated by our generator. And here we go. Here's the implementation. Get hello world, get other value. And again, I can actually go in and I can change this. And now when I go back and look at this generated code, you can see we really are doing this at compile time, right? So we're constantly reading in the XML doc and creating our values. So with the sort of exciting usage of the generator out of the way, let's actually go look at the generator and see how this incremental generator is actually built and what it's doing. So the first thing you'll notice, we've got this, again, our generator attribute, same as a source generator. And then we implement from our I incremental generator interface. So we get this initialize method. And actually, the first thing we do is this post init output. So much like a source generator can register context-free source in post init, so can an incremental generator, and this is how you do it. It's very simple in this case. We're just adding this dictionary attribute right There's no real magic here. It's just so that we have something we can read off and we can look up later on. So what we're then going to do is actually go through and build our pipeline, right? And you can see here there's a whole bunch of steps, and then eventually we call register source output, right? So you can sort of see there's this whole pipeline of steps we're going to build. So the first thing we want to actually do is go to the additional text provider and say, okay, I want to find all of the additional texts that end with XML. And so that's great. It's going to filter out our other file.txt because it doesn't end with XML. And so now this is just at some point going to be a values provider of additional text, but only ones that end in XML. The next step we want to do is actually go grab those values out. So we have the select many. We can go look at the extract file content method. And basically all we do is for every additional text, we just read the content of it, we load it into an X document, and we just go and grab the key and value attributes. And what we end up producing is just this list of key and value. So again, what we end up here with is this value provider. Oh, sorry, and we then collect. So we actually say, well, we don't just want each one, we want to be able to look at them all together. So we collect it into an array. And so in that point, we end up with a single value provider of an array of key and value, right? So we have this, at some point in the future, this box will contain an array that has all the key value pairs in. Right now, so we've read the XML, we need some way of actually going and like working out where we need to generate things in the code, right? So here we're going to then do the syntax provider. And this is where we'll get a little more into detail about this. So you can see here we do the create syntax provider. We don't actually have, this isn't a value provider. This is just a factory that allows you to create them. And we have these two methods, right? And so we have isStatic. And this is our syntactic method. So if we go look here, we know the methods we're looking for are going to be partial. We know they have to be static. We know that it has to have an attribute on it. It doesn't matter what attribute, but we know it, like the one that we're going to use must have at least one attribute on it. And we know that its parent has to be a class. And in fact, we have a partial class. And we say that that class has to be in a namespace, right? So you can't have like nested classes. And so what this does is this allows us syntactically to just scope the universe down from every possible node in the project to like a very select few. And they might not all be the right ones because we overselect, right? We don't know if that attribute is our attribute yet, but we know that this is the candidate set. And so we've got a very small number of things that could possibly be actually interesting to look at. And that's where we then call the second part, which is the semantic check, which is this method here, extract required method info. And here we just do a bunch of sort of traditional Roslyn stuff, right? We grab the node, we use the semantic model to get the symbol, we check it returns the right type, we go find the attribute. So we say, oh, is this actually our from dictionary attribute? And then if it is, we go pull that key out from the attribute. And finally, what we return is this little data structure, which just has the name of the method we need to generate, the key we want it to, the key that we want to look up the value to return, as well as the class name and the namespace name to generate it into. We also have these return defaults, right? So if there's an error, our error handling here isn't great, but we're just going to say, you know what, ignore it if we can't generate it. And so when we go back up to here, we can see that now will essentially produce this large syntax provider where the type we're returning is that little data structure we created with name, key, class name, and info. And then we do this filter here. So we say, if we didn't figure it out, just ignore it. Obviously, in a production one, it's here that we'd go and report diagnostics, say, this thing must be static, and it's not. For the purposes of the demo, we just say, nah, if you didn't do it right, we're just going to ignore you. So this now is basically a box that will contain a set of these method infos. But if you remember from the output, we wanted to generate one class per input class. So the next thing we want to do is just group these by their input class. So we have this group methods, and we collect them. So we put them into a big array, and then we select many of them out, right? So we actually just do this group by a class name, and that ends up now we have a grouping of them. So this is now a box that will contain sets of methods which are grouped by the class that they came from. So now we've got each set of class methods, and we've also got this other set of the XML values. We want to actually get them together and replace their values, right? So this is where we call combine. And so combine, we actually combine the key value pairs with our group methods to create this combined value source. And so this now has all that data in it, or will when we run it. And then finally, what we want to do is we want to just do a select over that. So this is a little wordy, but essentially what we're doing is saying, hey, for each method, just create a new derived value, which has the name, go find the key that we're trying to look up and grab its value, and then the info. So when we look at here in results, we've got this, we've got the name and then we've got the value. Rather than having the key that we wanted to look up, we've got the actual value from the XML file we want. And so finally now we've got these groups of methods per class with all the information we need. So we just pass that to register source output. So we pass this in, and then this here is our little method that runs, which is like our sort of mini execute method. We know that these methods are grouped by the class they're going to be generated into, so we can just grab the first one, and we know then what the namespace and the class to generate is. And then we just say, hey, for each method, just go over and generate the method name and return this hard-coded value, and then actually add the source in generated. So, it's a little complicated, but hopefully it's not too difficult to follow. But one of the interesting things is if we actually want to debug this, like, how do we step through? None of this is actually going to execute yet, right? So the first thing we'll do is we'll switch the profile. Now, if you've not seen this, we have this feature we introduced a little while back called is_Roslyn component. And we actually have a debugger now built into Visual Studio for debugging generators. And so once this is enabled, you can actually go in here and create a profile, and you can choose a project you want to debug. And so what we're going to do is we're going to compile our test project under the debugger, so that we can actually step through our generator. So let's go do that. So we're actually launching the compiler, and here we go. So now when we're in our initialize method, as we step through, none of our code is actually getting executed, right? It's just stepping. And in fact, we can even stick a breakpoint here and step over, and nothing happened, right? Because all we've actually done is build up this data structure at this point. So nothing's executed, right? It's like toArray hasn't been called. And so at some point, what's going to happen is the compiler is going to go off and do all the rest of that stuff we showed, and eventually it's going to come back and start calling into us. So we can, for instance, we can put a breakpoint here, and now other things happen, and eventually we come back, and it's tiny that you can see here, it was 28 milliseconds. So the compiler went and did some of its own things. Now we're actually here, and it's saying, oh, if for this given node does this match. We won't go through the nodes because we obviously see a lot of them, but then we can actually go into the semantic filter once we filter them through, and we can say, oh, okay, this one did match, right? This was this partial method we wanted. I can't get it to work, but so here's this one which is hello world, get hello world, and then if we run again, we'll see that this node is our other value, and so on and so forth. So we're now just doing it on the very small amounts of semantic. And eventually, if we run, our pipeline is going to run all the way through, and we get to our register source. And so the first time we call it, we're going to be called for this. We get called for methods. And you can see this is essentially the output of our pipeline, right? We ended up with this little data structure, which is the class name, the value we want it to return, and then some information about where to generate it. And you can see these are grouped by the values, right? Both of these entries are for class values. So we'll go through and we'll generate that. And then we're actually going to get called again. So this time we're going to be called the second time through for this values2 object. So you can see how we've made the pipeline to essentially end up with two sets of data, one for the values file, one for the values2 file. And in the compiler, that's actually it. That's all that really happens, and that's all that's really interesting, right? Because the compiler starts up, it runs all your code, and it shuts down again. But so, why do all this other stuff just so that we can throw it away? Well, actually, in the IDE, of course, that's not the case. So in order to see really the power of this, let's actually attach the IDE and see how the IDE is executing this. I should warn, I'm on a pre-version of Visual Studio, and this has crashed a couple of times I've tried it. So if it does, I apologize, but let's hope the demo gods are with us today. Okay, so we're now actually attached to Visual Studio. So we're debugging Visual Studio with our generator. And what we're going to do is go in and let's actually make a change, right? Let's go type something in this other class. And there we go, perfect. So nothing happened, right? It's extremely exciting, nothing happened. And you might think, well, we changed the source in the project. Why didn't we rerun the generator? And in fact, actually what's happening is that we just aren't getting to this point. And so if we go put a breakpoint here, we can actually then go and put a thing here. Now you'll see it did run. So what's happening is the node that's being run is, in fact, we're looking at other class, right? And so we're actually saying, okay, go scan the class you just changed and tell me if anything else changed. Tell me if any of these things match. And what's really interesting is I won't step through because there's a lot of syntax, but you'll only see it run for this other class. And so this is where the power of the create syntax provider really comes into its own. The IDE knows syntactically nothing else in any of those files can have changed, right? Because you've not typed in them. So there's absolutely no point rescanning through them just to find the same answer again. So instead, we only do a syntax scan for the file you're actively typing in or that's actively changing. What does then happen is there is still a semantic check, right? Because we don't know that the things you've looked up in a previous file haven't changed because of this edit you've made. So we only run the syntax scan for the changed file, but then we run the semantic change for all the other ones. So we basically cache the results of the other syntax trees and then rerun it during extracts. We'll see again, now if we continue, that we now get into here and we will run this 3 times. We have once. Oh yeah, because we're in the class. So we did the semantic check and we said, okay, we didn't need anything else on this. Again, there we go. But basically what happened, there's the 3. So what happens later on in our generator is we say, okay, well, what came out of this was actually the same, right? The 3 target methods we were interested were the exact same 3 methods last time. Last typing and comment didn't do anything. And so the IDE is able to say, well, in that case, we don't need to run any of this again, right? Because we know that the results will be the same. The same inputs produce the same outputs. So let's take a look at how that actually fits together in Visual Studio. In the slides. Sorry, let's go back to the slides. So when you think about this as a graph, when you think about the thing you're building, you can really think about it as being a graph, right? So all those steps we made actually essentially came to create this execution graph. And that's actually how Visual Studio itself sees this. It's how it views it, or how the IDE or the compiler actually views this. And when it wants to calculate what it needs to actually run, it starts at the end node. So it starts at the output nodes, and it basically works its way back through the graph. So we go generate, it says, generate, it says, I need to figure out the results. Okay, I need to get the combination. The combination says, okay, I'll go get one side of my graph, keys and values, XML files, additional files. And so we basically track through the graph until we hit this point where we say, oh, this is actually an input to our graph, right? So we now know that we've got something to calculate. And so what do we calculate? Basically, the compiler uses this internal structure, and you can go see this, called a node state table. And so for each node that you create in this execution graph, there's a corresponding state table. And that basically has an entry for every value. So in a compilation provider, it will have one value. For the additional files it'll have a value for each additional files. And alongside that value, it has a state, and that state can be added, modified, cached, or removed. And when you do this the first time through, you basically end up with everything being added, right? Because it's the first time through, the state tables were empty before. And so we end up building this state table where we say, okay, there's 3 additional files, there's dictionary 1, there's dictionary 2, and there's other file, and all 3 of them were added. And then we calculated the state for that node. We can then go back and unrecurse to our next node. And our next node is a filter, it has a where, and so we actually run that where on this state table. And this produces a new state table. This produces a state table for the XML files, right? So we end up with dictionary 1 and 2 as added. And we can basically keep tracking through here and figuring out the state as we go. So, so as we do the many, we actually project out, and you can see we actually end up with 3 states. We have the actual individual values we're interested in. And then from those values, we actually collect them into an array. So you can see here how we've taken 3 values and merged them into a single array. And then we get to the combine, right? And so the combine has to then track back up the other side of the branch until we get to syntax provider. And this is where we end up with these 2 steps, right? So the syntax filter runs first, and in this case, it runs over all of the syntax in the world and produces hello world other value in my string. And then we actually run the transform, and this is where we pick up the values. So we have like, here's the name, here's the key we want to look up, and here's those information about the class. We then do the group, which is where we collect, we select many, and we end up with these 2 groups. We've got them now grouped by the class they're in. And then we get to combine, and this is where it gets very difficult to actually show off, but hopefully some color will help. And essentially we end up with, one entry, which is these values, the values 1 paired with all the XML values, and a second entry, which is all the values 2 paired with the same set of XML. So this now gives us all of the things together. We can look at each value together and actually now do some selecting. And so that's when we do the select, and we actually project out. So we say, okay, no longer are we looking at the key here. We've actually got the value. So this is our some other value, hello world, some string value, right? And eventually we get down to generate. And so this is where we then go take these values and we run it once for this, which we saw in the debugger, and produce values 1. And we run it here for values 2 and produce values 2. And then that's it. So for the initial round, that's what happens, right? And in the compiler, that's what we saw in the debugger. Start to finish, we just went through and ran it. But then in the IDE, we obviously want to reuse that state. So the next step it does is it goes through and it actually marks all those entries now as being cached, because it knows they haven't changed since we last run. So it goes through and changes them all to cached and sits and waits for an edit. So let's make an edit, right? Let's imagine we rename a method in values 2, and let's track through again and see what happens, and you'll see why the incremental stuff is so powerful. So once again, we start at generate, even though everything's cached, we start at the end, and we work our way through until we chain up to an additional file, an input node. Now in this case, we get here and we say, well, since the last thing, we edited values 2, but these files haven't changed. So these are all cached. And in fact, we don't even need to run the transformation to figure out the next set of inputs. Because all the inputs were cached, we can just use the same cached results from last time. And the same with select many. We just say, you know what, we've got it. So we can instantly just say, nope, no need to calculate, no need to calculate, no need to calculate. Eventually, of course, we chain back up to the syntax provider. And this is where we do that. We have to consider the semantic differently from syntactic. So we only run for the change tree, right? We're only going to run for values 2. And so we can keep the cached values for hello world and get other value because we know they haven't changed. They're in a different file. That file hasn't changed. But that values 2 file has changed, so we get a new value. Now, what we then do is we have to run the semantic check for everything, right? Because this get hello world could be referring to something in values 2, which is now changed. So we now need to rerun it. So we actually rerun the transform for all 3 inputs. But what happens is for the first 2 inputs that come out, the generator driver, the compiler, notices that you just produced the same value. So it knows that the last thing you produced was get hello world, values 1 and tester. So actually, it can just use the cached value going forward. Although it made a new value, it was the same one. So we know that anything that is produced off of this value will also be the same. Say if we get other value and then get my string 2, we say, well, no, this is different. This one's modified, right? So we go back to our group. And again, the cached ones don't have to run now, because we know that the same value will come out. So we can basically ignore that whole line. And then we only run the collect and select many on the modified values. That then flows down through the combine. Again, the top one, we say it's cached, so we don't care. You notice that a cache and a cache creates a cached. If you join a cache to a modified, it's a modified, right? So something in it's changed. Finally, we select it out. Again, we don't need to do the select for the top one. And we get to the register output. And this is where we get very powerful, because we say, well, you know, the same inputs went in. We don't even need to generate the values 2 at all, because we know the result will be the same. So we don't generate any source for that. And in this case, values 2 we do, so we have to go run it. But that's why when I was typing in other class, we weren't even seeing those register source outputs get called, because by this stage, the results were all the same. They were all cached. And so there was no work to do. And so in that way, the IDE can actually just we basically go through and only do the minimum amount of work that's required to basically bring your source up to date with the changes that have happened. And so we're not running any of the additional files or any of those expensive options. So that's kind of really where the power comes from. Now, I did mention, we say, oh, we're going to compare this value with the previous version. Basically, by default, we just use the quality comparer of t. In this example, I'm actually using little tuples, just value tuples, and they obviously have comparison. They just do element-wise comparison. They were just strings, so everything just kind of worked out of the box. Obviously, you might not. You might want to use reference types or have complicated comparison logic. And so any of these nodes at any point in the graph, you can always do dot with comparer and actually pass in your own equality comparer. So you basically get to control that behavior. One thing to note is that the only time we call the comparer is if you have a modified value, right? Because if it's added, we know you've got to run because we've never seen this value before. If it's removed, there's no point running because it's going away. And if it's cached, we don't run because we just say, well, when it's cached, we're going to use the value we want to cut down on computation. So the only time we do it is if it's modified. And that gives you the chance. We say, well, we think this thing's changed, but actually has it, compared to what was generated last time and this time, is it actually the same? And that's where your comparer can run and say, oh, you know what, these two things are actually equal, especially if they're reference types, they might be different, but we can consider them equal, so we don't need to use the new value. Whew, okay, so we've just got a few minutes left, I think, for the future stuff. As always, I'm going to say, this is not definitely happening. These are just some ideas we're kicking around, so don't quote me on this. But one of the things we're really interested in exploring is actually some higher level syntax APIs. So, we were doing sort of attributes. It's kind of complicated. It's quite a lot of code to do something that feels like conceptually it should be quite simple. So we'd like to maybe think about doing something where you just say, give me all the syntax that's attached to this attribute, that has this attribute attached. And, we can do some very clever stuff under the hood as well to make that really fast. And the same with partial methods. Like, again, it's just, these are really common cases. You're like, I just want to see all the partial methods. I'm not interested in anything else. And we can do that very fast under the hood and just give you those things. So there's some of the things we're thinking about. And maybe, starting to now build these higher level constructs on top of these quite low level things, just to make life easier and do the right thing by default. At the other end, we're sort of thinking about adding new output types. So right now we just have like source and post init, the only ones we have. But we're thinking like one of the things that's really common people would like is artifacts, we call them. So you basically want to, things like WASM, you might want to put a JS file in the output directory as well, or some binary blob. And so this would basically be a thing where you can actually generate stuff other than source. And that's true for things like embedded files too. Or we're also thinking about maybe like additional files. So, like you could actually start communicating with analyzers and things if you wanted to. We think we have a good design for artifacts. We're unsure whether we need the other ones, but that's something we're sort of thinking about and playing around with. So with that, I think I'm done. Does anyone have questions? Can we, anything I can help with, basically? I've got my thing here. You can email me. I'm also at Chisel99 on Twitter if you want to come ask questions. Fairly active there, and we do quite a lot of sort of, Twitter-driven design in the generator space where customers come and we talk and we figure out what we're going to do next. So if you have thoughts or feelings on it, like that's a good place to come and talk about stuff. Okay, thank you.
Hey, Chris, that was a great session.
Hey, thanks.
I had a couple thoughts. One was, first is I think, since source generators are brand new, I'm really interested to see what people are going to do with them.
Yeah.
And I already have my plans. I wanted to do like a source generator kind of based on all the practices in my coding standards book,
Yeah.
And so that's kind of the first thing I'm going to work on. So the other question I had was, is there like a page or something you guys have that kind of features some source generators that have been created? Or
yeah, so we have for iSource generators, we have this thing called the cookbook, right? Which is just kind of a simple set of example kind of things you can do that says, oh, I want to work from an additional file. I'm going to do that. And that's in our GitHub. Right now, for incremental generators, we don't. It's very lacking, and I'll hand my hands up because that's entirely my fault. There is an open PR which has most of the documentation, which is all the stuff I covered today, which should be merged, as my boss will be happy to hear anytime soon, which will be there. And then I'm aware there is a third-party GitHub. I can't remember off the top of my head, but I can paste it in the chat after this, where someone's just collecting kind of a set of different source generators that people are building. And so, but right now, I mean, for incremental, basically all of the ones in the runtime. So things like the Razor source generator, the JSON, and the login generator that are in .NET itself, they've all transitioned over to incremental generators. And obviously we consider those to be best practice. So if you want to sort of especially see some more complicated implementations of how to do these things, they're really good references to go look at and play with. And they're obviously, you know, on your box already. They're actually there by default as part of a .NET new. So.
Oh, great. And the last thing before I let you go is I see you're a compiler engineer at Microsoft. So I'd like to have you on my show someday, the Rockin' the Code World show. And so we can talk about compiler things. You know, I've never had like somebody from the compiler team on my show. So I think that'd be great for everybody to kind of learn the secrets of the compiler and, you know, things like that. So please feel, so I'll reach out to you, or you can reach out to me, but I definitely want to try to get you on the show if you want to.
Yeah, for sure. That sounds great.
All right. Well, thank you very much, and have a great rest of the day. That was a great session.
Thank you so much.
Thanks. I think I'm using my hands too much. Well,
yeah, maybe your hands are going like this.
Well, that's what I do when I speak, and I haven't been able to speak for 2 years. Over 2 years. So
yeah,
my hands are lonely, you know, they're
Don't say that, David. Okay, let's move to a better topic. You have something to share about the show, right?
Yeah. So speaking of Rockin' the Code World with .NET Dave, I want to announce that, oops, I'm using my hands again. I want to announce that I'm having a very, very special .NET 20th anniversary show the day before the actual anniversary. And so far, I have 2 people that are going to be on the conference today. Will be my guests along with Carl Franklin. So we're going to sit around and talk about the past, the future, and all things .NET that day. It'll be an extended show, and I think it'll be really fun to, you know, kind of look back at, you know, the past 20 years with .NET and everything it's gone through all these years. So I hope everybody will go. Simon can flash up the URL to for the actual show, but I hope everybody will attend. It's going to be a great show.
So did you say it's going to be an extended show, which means it should be somewhere around more than an hour?
Yeah, right now I have it scheduled for an hour and a half, like the last panel show. I'm sorry. You know,
it's okay.
I know that's going to cut into your Saturday night festivities, but you know,
never mind.
There's no way I can have those 3 people on my show and only talk for an hour. I mean,
no, I just want Carl Franklin to do like one poop for me, then I'll be good. All right, David, I think hosting your shows, I'm turning into like you. I've started to talk a lot now. So let's move to our next session. That's why Daniel is going to talk about Code is Red. David, what do you think about this session? Quite an unusual session title, isn't it?
Yeah, I was rereading the description this morning, and I'm really glad that we picked the session because, you know, one of the things that, you know, I do lately is I go into companies and I fix all their spaghetti code, right? And part of the problem with that is, you know, most projects I go to have very little commenting, you know, no proper standards, and, you know, trying to figure out what the code is doing is a nightmare. You know, I was trying to fix some stuff this weekend, and my boss was trying to help me, and he finally realized the pain that I'm going through because of this kind of stuff, right? So, you know, I write code that's really easy to understand. You know, people have told me that before, But that's my goal. I want somebody to look at my code and go, oh, okay, I know exactly what he's doing there, or what this code is supposed to be doing. And unfortunately, that's not the case a lot of times these days. Yeah.
All right. So sounds very exciting session. So without any further ado, let's invite Daniel to the .NET Conference 2022.
Hello. Thank you for welcoming me.
Hi, Daniel.
Howdy, Simon. Howdy, David. Glad to see I'm in good company and talking with my hands.
I know.
Yeah, I've got to keep it down a little bit.
I know.
Oh, goodness.
I need some handcuffs.
Oh, yeah. I usually try and have something to do with my hands because I find it helps in illustrating a point most of the time.
Yeah.
Yeah.
All right, Daniel, we are really excited and looking forward for your session. I'm going to add your screen to the stream and everybody can see it. And next 45 minutes is all yours.
Awesome. Thank you guys again. So, hello, everyone. Welcome to Code is Red, an intentionally provocative session title wherein I'm sincerely hoping to add some value and, in particular, some principles you can apply to your practice, ideally to make your code easier to read, because, as David mentioned, there's nothing but pain in unreadable code. So, briefly, who is this guy talking to you? My name is Daniel Scheifler. I'm a Christian, husband, father of 3 expecting 2 more, and an improver. And it has been my great pleasure as a software consultant to bring honestly unusual perspective to every one of the clients that I've tried to serve. My goal has been to see with eyes unclouded, to look at the stuff that dead on may seem very simple and then look at it slightly askew and see what else might be there. And as a result of looking at things honestly a little peculiarly, a lot of the insights that I've come to today have come up. So what are we doing? Well, the goal of this session will be to illuminate and illustrate, I hope, about 3 major principles I have found leads to more readable code that can be applied regardless of the language you're writing in. While illustrating those principles, I am going to show some code examples, naturally just kind of made up on the spot to kind of illustrate the point. But I'm going to try and attach those to the patterns, the principles, and a number of the other thought leaders who have already worked in this space, like Uncle Bob. And so we're going to talk about how the patterns and tests will fit into the process, as well as the principles that I'm trying to provide a name to. And so without further ado, if you have any questions, of course, there is that comment feature running on the live stream within YouTube. And so if you see that little ribbon up there, ask your questions now, feel free to start typing them in. And as we're able, I'll try and pause to answer some of them. Of course, there will be a question period at the end as well. So let's start with a little practice of this little ribbon thing. What is the root activity of software development? And in particular, let's focus on those existing projects, like the brownfield projects, as we call them. And Simon, if you do me a kind favor and help me see if there are any answers coming in the chat right now. But when you think root activity, what is the stuff you're doing every day? No matter what kind of language, what software project you're doing, what is that activity? Oop. Let me bring that back. Let's see, we're seeing some comments here. So some of the answers I have seen to this in the past have been, we write bugs, or we complete features, new features. Yes, there you go. Ninja Turtle 11754. Yes, we sometimes write new features. I have found that both in writing bugs is the more humorous response and writing new features, that the common element, oddly enough, ends up being very similar. When we are writing code, our daily activity, I should say, is to change the code, especially in an existing project. We're not just creating code out of nothing. We're taking the existing functionality and we're changing it. And in order to effectively change our code, you kind of need to understand it, right? Like if you just decide, oh, I'm just going to change it like this and hope it works. That's called programming by coincidence, and generally leads to more bugs, where our goal usually is not to create more bugs, which is more work for us, but to actually change the code to create the new desired behavior. So the goal of this session is to enable us a finer grain understanding of what it takes to generate readable code, which yields faster understanding, allowing us to make faster changes, which ideally, in the end, will lead to faster delivery, less time wasted trying to figure out what this thing was supposed to be doing in the first place. So, principles. And here is the basis. All of this kind of hit me over the head when I was taking a vacation, probably about 3 or 4 years back. And I've been trying to teach myself Python. Now, I'm not going to recommend you go and use everything for Python, but I have found Python was a supremely easy language to teach myself. I found it read very much like terse prose, and it had stripped away a lot of the confusion for me in trying to read an unknown source code. And so I was reading through Python's own documentation, namely the PEPs, which is a series of guides on how to write Python well, and essentially the documentation standards. And out of PEP 8, found this quote, one of Guido's. Now, Guido is referring to the language creator Guido von Rossum. I apologize, it's a Danish name that I'm not entirely certain how to pronounce. But one of his key insights was that code is read much more often than it is written. So the guidelines provided in PEP 8 are there to improve the readability code and make it consistent across a wide spectrum. As PEP 20 says, readability counts. Now, separately in this presentation, I will strongly encourage you guys, even if you don't write Python code, read PEP 8 and PEP 20, commonly called the Zen of Python. And you'll find in them some principles illuminated and described not only humorously, but in a way that allows you to talk about it to others. So that no matter what code you're writing, you can start talking about these common principles, these common actions, these common governing ideas that should help you to write more readable code, be it in JavaScript, C#, or Java itself. So the basis is stripped down to its most fundamental piece is code is read the most often, easily 100 to 1 over the times you write it. Because it's not just you who's going to read it. It's going to be the guy who comes into the file later, and he may be changing a completely different segment of code. But he's still going to have to read over yours to make certain his code does what it's supposed to. Therefore, when we write code, we should optimize for the most common condition, optimize to deliver the most value. So we should write code that is easy to read. We should take on more effort on ourselves on the writing half of code to make it so that the most common use case, the reading of the code, is easier. So let me ask you a question real quick. Who is the code for? Right? Like our common job is to change code. But who do we write it for? Oftentimes I'll hear the answer, oh, well, we write it for the computer. Okay, honest question. Do you think your computer ever really recognizes your variable names? Strictly speaking, most of the languages nowadays are either transpiled, optimized, or otherwise changed so that the code you actually write in the editor is abstracted away and made as simple and efficient as possible as the compiler can make it. So frankly, the code you write never really makes it to the computer anymore because it's not the actual byte code that changes where a piece of memory is. And as a result, we shouldn't be optimizing for the computer, though very often I have seen that come up as a tendency. Now, there are, of course, cases where we should optimize for performance, but that's different. That's not the same as optimizing for the computer. So the very next answer, which actually comes from the comment that we write new features, is that, of course, the code is for the business. Again, I don't think that's quite accurate. Think about it. Does the business really want code? Like, could you print out the sheet of code and hand that to them and they'd be happy? No, not really. What they want is the behavior your code produces. They want the machine to go do the job instead of having to pay another person to crunch the numbers for 300 years. They'd much rather have the computer behave. And if they could get it without us having to write a whole lot of code, they'd probably take that solution. So that our code isn't for the computers and it isn't for the business. Who is it for? Let me submit to you that the code is for you. Or at least you and your brothers and sisters in development. We write code to communicate the intent, the idea, what is the behavior supposed to be to other developers in a language that the computer can compile down, of course. But the goal is communication between developers so that the daily activity of changing code can continue. Now, here's the trick. Code passes through time, and so do you. Unfortunately, how many times have you been in the middle of doing work when a bug report comes in and you were the last person to touch the code, so it gets dropped on your plate? And you go and read it and you have no idea what it was for or how. And in the end, you don't remember anything. It becomes harder to debug. You lost context because the code you wrote wasn't as readable. So it means that the code you write really is for use, specifically the future use, so you don't have to deal with the pain of, I don't remember what this was for. So, principle number 1, be informative. Now here over on here, the left, I have an example function, just some function, and you can kind of tell that I'm going to get an invoice from the database. Simple descriptive function name. Doesn't tell me a whole lot about which invoice, but ignore that for now. I want to focus on the line with temp, because naturally when we do initial development, modifying or anything like that, we're likely trying to feel out what the new development needs to be. And so we'll say var temp equals something. And in this case, I'll say the invoice billing total is greater than 1,000. No idea what that means right now, but obviously if that's the case, then I should do something, at least according to the code there. Please, oh please, when you write your code, don't leave temp as the name you commit. It's fine for a work in progress code, and it's fine for you to figure yourself out, but please don't leave it there. So very often, we'll find that the first step coming up will be, okay, so I'll rename the variable. And often it ends up being kind of a repetition of the code. Billing total greater than 1,000. That is accurate. That is what temp means. That billing total is greater than 1,000. But did I add anything useful to that code? Except that now temp actually has a description of what the computation that produced the value is. And so we can run into some pain in the future as code continues to mutate if we leave our variable name as billing total greater than 1,000. Suppose I recognize now as a new business requirement that 1,000 worked just fine for this customer, but for this one over here, I want to give it a different one. Like that one's less trusted, so I only want it to be 500. Well, obviously that means I need to abstract my credit limit, and I'll suppose that I put it into some configurable. But now look at the variable name, billing total greater than 1,000. Is that true? You don't know, unless you also know config.creditLimit. And as a result, the code has become misleading. This is actually the same reason why comments have fallen out of favor in most code bases, because comments are not required to be updated with the code they describe, and can very often, especially in older projects, end up being misleading because the code underneath the comment changed over time, no longer functioning as the comment describes. And so there has to be a better way, which is where I want to lean into informative. The informative name would be honestly around what the intended use of that computation is. Why did I perform it? Well, I should or should not do something, whatever that something is. And that's a slightly more useful name because it describes the intent of the computation, not literally redefining the declaration. So on the left, you'll see an intent associated name. Should I or should I not do something? Now, hopefully you have a better name than something, but maybe you need to go and do a special computation. Maybe you need to approve or straight up disapprove whatever the function action is. But by capturing the why did I perform this computation in your name, you get closer to adding information to your code. And as an added benefit, you are able to capture more of the relevant context for your code in the names, making it easier to read and easier to reason about the code underneath it. Now, with method names, there is an added challenge. As I mentioned, the should do something is not great. Do something isn't super descriptive. Now, Donald Knuth knew this years ago and mentioned, naming things is hard. It's one of the several things hard in comp sci. So please, don't just stick verbs together. Naturally, we can follow the kind of same stepwise updates of temporary sum function to descriptive of check for taxable and compute the taxes and mark it ready for post. But that'll be exhaustive. And then when I change it for it's no longer marking it ready for post, or I change the order, the function name has to change. That's not great. So we want to aim towards informative names. And I want to revisit this when I get to applications of principles and testing. But for now, remember, just don't stick a bunch of verbs together. Even though that is helpful, your goal is to describe why a computation is or would be performed, not what the computation is necessarily. So let's move forward. And to principle number 2, be respectful. So let me set the context here again. Remember that code is written for you and for other developers, which includes future you, which unfortunately means we have to account for some very human limitations. Because, after all, we are not automata. I cannot fundamentally remember everything that a computer can. So I want you to think about it like wet RAM. There's only so much information I can keep readily in memory to understand the context of the code I'm in currently. It takes mental resources to understand code. If I add more branches, I have to keep track of more. If I add more variables or more steps to compute those variables, I have to remember more, at least in the short term. And those resources are incredibly limited. In fact, most research has indicated that people can keep at best, let me go back by one, at best between 3 and 7 items in memory actively. That is, on average, 5, give or take 2. And so if your if statement, the value being assigned to the temp variable for if do this, takes 5 steps, if this condition or that condition and this condition or either of these conditions, suddenly you're going to be running into a chance where a good portion of your team just can't keep it all in mind when they try and figure out what that value might be in a given condition. And so I want you to see how that can play out. And this is actually a decent example. var temp is equal to invoice billing total greater than 1,000. And in this case, the invoice rate has some value, or it's a special state based upon the invoice's location. Or, and of course, now you have to figure out, does that or go with the first and, or is it really about the secondary 2 conditions? And then it has this complex piece here, which is the invoice has a late fee and all of the line items on the invoice are late fees. And then, of course, as you're reading through this, you realize, oh, I implemented a feature flag and some, giant wall of text for all of the things that go into this new feature flag come through. And at about line 114, you come back to realizing, okay, so here's temp and here's where it's actually used, still under the feature flag. But do you remember what temp means? Me neither. So be respectful. Exit early. Dump your context early. How much of this function do you need to read in order to tell what you should return if there are no line items in the invoice? You have to read most of it, all the way through the if statement until you get to the little thing at the end with the else, return 0. That's a lot of noise for you to have to answer the question of what am I returning if I have no line items? By contrast, if you move it up here, you'll find that, hey, cool. I can now dump the entire context of if I have no line items, I don't need to think about the rest of this. Or I can assume for the rest of the function, I have some line items, which makes my life easier. But one thing I want to caution you against is do not think of exit early as being for the compiler. The computer doesn't care. What will happen is it'll read through its code, it'll perform the evaluation of the if condition, and it will either jump to a new location in code or jump to another location in code. It does not care. It'll either move to the next pointer or it won't, and it'll just proceed. But the compiler doesn't gain any benefit from jumping early or jumping, well, anytime, because it's always going to just jump. The computer could do this with ease. It's the human who's reading your code who has to figure out, where do I need to jump to? Now, modern IDEs have made this easier because we can collapse sections of code, which makes my life much easier when reading large functions. But that's not always the best way. Because while I'm scrolling rapidly through this, I'll likely see the if statement and then go looking for its else or looking for what am I supposed to do under it, trying to understand. So while I'm trying to optimize for understanding, I need to be respectful not only of the memory limitations of the people who are reading my code, but also of their understanding of their context. So I want to introduce this idea of, there we go, a contextual burden. How much of the context, be it what the business context is, what this class is supposed to be doing, what else is happening in the method, how I got into the particular branch of code I'm in, how much do I need to remember in order to effectively understand this block of code? And as you add more and more and more to actually effectively understand it, the less and less understandable your code becomes. Because if I drop one piece of that context, either by error or by skipping it, now I'm going to have a harder time doing my job. And so if you look at a function like this, where I'm just as a simple compute bill function, but I've got this gigantic conditional, it can actually be pretty daunting to figure out, okay, so when am I actually computing the bill versus this return 0? And so I recommend 2 steps. And this borrows from my first principle, being informative. What does that condition mean? It means I can or cannot compute the total bill. And I can see here I have to have a bill to, I have to have a rate sheet, or I'm a special case and my rate sheet is null. Okay, cool. And if I cannot compute it, I return 0. Fine, nice and simple. And then I can start looking at, okay, so how do I actually get the rate that I need to use? How do I compute the line costs and get the total value of the invoice? But one thing that this still can do is it'll hide things from you unless you're very communicative in what you're doing. Because that can compute total bill still has 2 reasonably complex components. And while the strong naming allows me to essentially dump all of that context while I'm going through, because now all of the lines about whether or not I can compute have been handled, I don't need to remember any of that. I can now focus on the actual computation. And there's actually an error hidden in this code here that I can start to see better if I can understand what the intent behind my code above is. But let's move on to principle number 3. Be trustworthy. Remember that our goal is to change code, to change it effectively, which means ideally we want our changes to behave in a predictable fashion. Now, that's all well and good, but what happens if the cornerstone of the application you just placed suddenly turned into sand? That's not how rocks are supposed to behave, but sometimes code can do that. We usually call this side effects. Thank you, Uncle Bob. Now, the good news is dealing with trust in code, you actually already have a good context for. You interact with humans all the time. And you kind of just internalize some of this as part of social norms. In a human, being trustworthy might look like they do what they say they will. They'll talk openly about what their plans are. And if they're really good, they'll offer you the option to look at their same data for independently verifying their conclusion. And as a result, the higher the trust you build with someone, the faster you two can operate together. Because instead of having to spend all of the time constantly verifying or checking over their work or any of the other pieces there, you can simply trust them, not have to do the extra overhead work, and accept the work coming from them. In the same way, code, doing what they say they would look like no side effects. Talking openly about what they're doing would look like using the pattern or the domain names appropriately, based upon where you are. Independent verification, unit tests, automated tests, our strong friend as good developers. And of course, being trustworthy means I can trust it. I don't have to dive into every sub-function to make certain it does what I think it does. Instead, I can just accept that this name means what it means and move on. So let's look a little deeper at that. Looking at this example, we have an example service. It's got an ID for someone, probably some other entity handling it, some status of where it is. It's got a name, whether or not it's enabled, the last time it was modified, and who changed it. And I've got this function, reconcile services. I probably have 2 services, like maybe one's a duplicate, and I want to say, okay, so this one is a duplicate, turn it off, only handle this one, so I don't accidentally double charge a customer. So I'll call out and say the from service I need to disable, presuming I've already gotten it from the ID, from the database. And then I'll call mark the service assigned on the from with the to services handler ID. And then I'll save my changes. So on the surface, what would you think the mark service assigned does? Given that it's taking the handler ID, I'd assume it's probably going to change the handler ID on the from service. And I would expect it to make a change to the status. But that's it. And this is where you can find a bug. And yes, I actually found this particular bug in a production service, and it was causing us no end of headaches while we were trying to reconcile services, because the mark service assigned was also enabling the from service, which is infuriating because that's not what it said it was doing. It said it was marking the service as assigned. Now, to be truthful, that might have been part of the domain logic. That's what it means to be assigned, to be enabled. And so I might be wrong by going off on that. We found out it wasn't that was not the case in this example. And as a result, it caused a bug in reconcile services because the function here did not do what it was saying it would do. Now, you could obviously adjust the order of your code and just mark it disabled after assigning it, and that would fix the bug. But that's allowing mark services assigned to technically do more than it says it will, and leaving a side effect in place. Now, as to how you might change this, put some unit tests in place. Guard it. Provide independent verification that mark services assigned does exactly what it says it does. Of course, at the start, you need to also make the statement that it will mark things enabled. And then over time, as you're able to refactor it, you remove the enabled check and assert that it is now not changing enabled or disabled. But that is a way to remediate untrustworthiness with unit tests. And I'll get more into that a little bit later. And so before I move into practices, I want to take a moment to pause for any questions that may have come up. Let me go here. Whew. I'll take just a moment to breathe before we move on to the next piece. So one of the questions I have received in the past in this area was a question about which of the principles do you recommend starting with? Is there anyone you have to do first? And my best answer here is that, aside from it depends, is that you need to consider your situation and what works best and what you can actually change first. It may be that your code is, honestly, a large legacy application with no unit tests and is full of side effects. Okay, then just promoting trustworthiness isn't going to be enough. You're going to need to start somewhere else. My preference is to start with informative names because I can kind of do that on my own via independent refactoring or variable naming choices, whatever. But the best answer I can give you is start with where you have the option and the influence to make the change. Just pick one. Now, that said, you can't get very far without starting to pick up all of them, because having an informative name really only works if you trust the computation under it. That's an interesting question. I just got a question about when is a code base too small for unit tests? Short answer, honestly, I tend to lean kind of pragmatic on this, but the purest answer would be never. You should probably have unit tests from the beginning. However, I tend to favor test what matters. Don't waste your time testing or retesting the framework you chose, because if you don't trust it, maybe you shouldn't be using it. But the moment you add business logic or a intentional behavior of this button shows up and then that button shows up, you should test it. As that helps you to A, keep your test designs, helping your actual code design be fruitful. It helps you to be certain and confident in the code you're writing doing exactly as it intended to do, which helps keep your code base trim and ready to go. And it'll inform you when you broke something, even if you didn't intend to. So that's my usual approach. Good question. Now, moving on to the practices where we can dive a little deeper. First, on informative, remember dry. Do not repeat yourself. The pragmatic programmer does a wonderful job in exploring this. I'll recommend it to you because it talks about how dry needs to apply to more than merely the classes we have. It's not just about avoiding repetition in your code, but rather avoiding repetition of your code, your decisions, and of your information. This should apply to your variable names. This is one of the reasons why I get so frustrated with simply descriptive names. Because the descriptive name, like the top one there, literally repeats what my code just did. I added nothing to it. I could have found that out by reading my code. But when I push towards informative, when I try to capture the intent, the answer to why am I executing this computation, rather than just what is this computation, I am adding value and capturing new information in my code. the billing credit limit exceeded is far more useful to me as a developer when I am reasoning about the code than billing total greater than 1,000. Because it allows me to say, oh, maybe my credit limit also needs to entail not merely this invoice, but all open invoices. And I can think about what that means for my business in terms of, well, the business. And so when you're looking for informative names, steal them from the domain. Speaking of which, save on your RETRAM. Speak human language. Remember why we're writing code. We're writing code to communicate our intended behaviors between myself and another developer, which might be future version of me. So lean on the business domain. What am I doing inside this block of code? Where does it matter? Borrow their nouns, borrow their verbs, like an invoice. What does an invoice mean for this business versus a line item versus posting or a credit limit? And aim so that your code can read like terse human prose. Seeing the example down there on the bottom, can compute billing total states I have to have more than 0 line items. And when I read the if statement, if not, can compute billing total, return 0. Terse human prose. I might describe that in my expectations inside my ticket for my acceptance criteria. And I could show that to human and be reasonably certain they could verify that without having to know how the code compiles. But that won't always work because naturally we are working on systems where not all of the code is just about solving the problem or actually executing the desired business computation. Sometimes it's about how we chose to implement our infrastructure to allow maintainability, extensibility, or any number of these other ilities we want our code to have. And so in those cases, speak developer. Now this deals with pattern names. Speak the developer when it's appropriate. Now, be careful here. The pattern names can reduce the contextual burden, but if not everyone on your dev team speaks the same language, if they're not all familiar with the design patterns from the Gang of Four, for instance, or they're not all familiar with CQRS, using the name that makes sense to you may not be as informative to them. But when you look and read the code here, travel by car for some distance, I create a car with a factory, make one, red, shiny, and loud, and then car goes zoom, zoom for the distance. That's pretty informative, pretty descriptive of what I'm trying to get at. But my business domain may not be manufacturing. It may be car rental. And this could just be an example test case. But the factory in that case does not refer to manufacturing, where it might have an overload in the domain name. It means I am implementing a creational design pattern. So when you're doing this, be careful of the names you choose so that it describes not only what you're doing, but the intended use of that thing. I have been in companies where the design pattern names were misused, not because they had an overload in the domain, but because they were not well understood by the larger group. Okay. And so you have a choice. You can either, stick your heels in and hope that you can convince everyone to go your way, or you can flow. And in my personal recommendation, pragmatically, flow. You're not going to win the fight of trying to change everyone's opinion to your definitions. However, you can start building the definition list, just captured in Confluence somewhere, or heck, even add it to a docs section in your repository so that we start speaking a common language. But whatever you do, please, just please, don't add the name manager for any of your class services. Manager is so overloaded, it's a little scary. And is not incredibly descriptive. So while naming things is hard, and you may not be able to use the patterns, be as informative as you can about the intended use of the pattern so that when you instantiate the factory, people know what it is and how they're expecting to use it. Lastly, we get to this trustworthiness. And best solution I have for this one is write tests. If you're struggling with side effects in your existing code base, start writing unit tests. And importantly, write unit tests that state that the side effect occurs first. Here's why. Now, when someone goes to read the tests, they understand exactly what the function is doing. And when they refactor it, they can actually start practicing TDD, red, green, refactor. When they refactor, they break a test. Now they go fix it to make it green again. And ta-da, we're back into our happy path. This is the same recommendation I make when you find bugs. Document that the bug happens first, fix the bug, fix the test. In this way, you gradually improve the trustability of your code base without constantly breaking it, because you don't have to fix everything at once. Heck, if you're a junior dev and you just got dropped on a massive project that's been written for 40 years, here's a good place to start. Add code tests. Start testing the files that you're exploring based upon your understanding. This adds value because now your code is starting to get tested, if it wasn't already, and it allows you to explore what you should expect when interacting with these classes. And you start adding value because now you can ask questions. Hey, is that what that's supposed to do? Or it seems like our business domain suggests that this and this should happen at the same time. Is that right? And of course, if you're stuck with a really unreadable module, guard yourself with unit tests. The only way to be certain in moving forward rather than programming by coincidence is to know that your change had the intended effect. The best way you can do that is to write tests against what you believe the code is trying to do. Once they're passing, then make a change. And now you'll be caught of any accidental cascades from the change you just made, especially in the unreadable modules where they happen to share things in window. So in my opinion, unit tests are an incredibly versatile tool, especially around the trustworthiness of your code. And if you have a question, start with unit tests. If you need to figure out a way to make it more informative, have your tests there so that you can assert that it is still behaving as it is intended, even as you change the name. So in summary, you will find that code is written 100 times, read 100 times more often than it is written. And so we really need readable code to enable more effective development, because we don't understand what the code is supposed to do. We cannot predict the effects of a change we intend to make. So remember that when you're writing your code, it should be incumbent on you as the writer to take on a little effort to make it easier to read in the future. And your future self will thank you. Now, to help you summarize and handle this in a slightly more humorous turn, I would like to share the following haiku. Code for the reader. Trustworthy, respectful, with informative names. I very much enjoyed my time with you and would like to say, if you're hopeful for more content like this, check out my blog at danielscheifler.io, or check out the other great writers that also work for improving at the Improving Thoughts page. And now I'd like to leave room and space for any questions we might have. Hello again.
Hey, Daniel, that was a really great session.
Thank you, sir.
Wow, I loved it. I loved it. Code cleanness, code readability. That's something I love. And this was, even I learned a lot from it. I used to write like a first method, okay, by 1,000, and now it makes sense to me. And there's no need for commenting, David. You keep complaining about commenting, right?
Well,
I like self-documenting code, not going to lie.
Well, self-documenting code is great. But a lot of people, number one, don't do that, right?
Yeah.
And number two, there are some instances where, you really need to document why you're really doing this thing here,
Yes.
because then as the person reviewing it, like I do all the time nowadays, I have to go, okay, why the heck did they do that?
Exactly. You need to capture the intent for the code. Comments
Right.
are a decent place for that because they're not about what the code's doing.
Right. And like, for example, on the project I'm on, there's nobody on the team that was there in the beginning of this project, right? The company goes through a lot of changes, hiring a lot of consultants, and like you can't find anybody that really can give you an answer to things in the code base. And if they just wrote even one sentence, it would have really helped me out in a lot of cases. So I think, I know I spend a little more time on doing things like this, but, probably like you, I do it for a reason because, number one, if I come back to fix the code, I want to know what the heck I did 6 months ago.
Right.
But number two, as an architect, I want to write the code and let other people deal with the rest, right? And so I strive to make sure that code is easily read by even a junior developer, right? And that's what I strive for.
Nice. So I think Daniel, David does a conference on code quality and performance. You would be, I think, perfect to come and talk about the same topic, because that's one of the things people are missing. Especially, you said junior developers, they all have these, deadlines where managers are pushing them and all that, and they just start doing things up and left and right. Yeah.
One of the bits of insight that was shared with me pretty early on in my career is to start taking a more professional attitude, especially when we have those time crunches coming up.
Yeah.
You don't get to ask your surgeon not to wear gloves while performing surgery on you because that's not healthy. Even if you asked, he'll probably say, okay, and then wear them anyway. And there's a balance that can be taken there when you're professionally developing code to take the time to do it right, even if it takes a smidgen longer. And the trick is more about managing expectations than just responding to pressure, being proactive, explaining why you need to do it this way so that next sprint, you don't have to go fix it again.
Yeah, I think you need to talk at every conference there is, because sessions like this aren't at major conferences, and people really need to understand this, especially junior developers. And the one thing I want to mention real quick, because I know we're short on time, is that the problem is if you have a spaghetti code base and you have junior developers, right? Guess what they're going to learn? How to code. Spaghetti. And so you're starting them off a bad way, and yeah, it's not a good idea.
That was awesome. That was great, Daniel. Thank you for coming, and awesome. And we would love to, again, as I said, we'd love to have you back again. And certainly, Simon will reach out to you.
And you can come on my show too. Actually, I don't want to say that every session. So all the speakers on the conference are welcome to come on Rockin' the Code World down at Dave. Just reach out to me, let me know, and to get you on. So yeah.
Sounds good.
Sounds good.
Thanks.
Thank you.
And have a nice opportunity.
Thanks.
All right, that was awesome, David. That's actually one of my favorite topics is writing, semantic and clean code, which is obviously readable and makes sense to people, right?
Right.
Yeah. So, well, all right. Let's look. We are on time, right on time. A couple of minutes behind. Let's bring our next guest. That's Joe G, our favorite Joe G. He's going to talk about .NET 6 and what are the new features in it. I think he said 6 and so on, maybe more. Sometimes we get some surprises. So let's bring him in.
Learning pods have been an amazing addition to this site because they gave families who had difficulty accessing internet service or computers access to them. I also think that an additional benefit of these computers is that they fostered such an amazing sense of community among the youth who've used them.
Our relationship with the Armin Roy Foundation means so much to us. They've been a consistent partner this past year, and we're humbled that our work together will honor the love that their beloved son, Armin, had for technology and allow us to tackle the digital divide head-on. Having access to a computer is of great value. Students can more easily complete their homework, and parents can take online ESL courses or job training courses to develop their skills and help lift their families out of their current situation.
Hello.
Welcome to the conference, Joe. How are you?
So
I am doing wonderful. How are you guys?
All good.
Yeah.
I love every time I see that video. It reminds me how overweight I was when I first visited the C Sharp Corner Conference in India.
There you go.
I'm sure glad they haven't found any of my fat pictures either. You know, they're out there, but they haven't found them yet.
Well, you have newer pictures, recent ones, so you know.
Yeah,
Yeah,
I've lost a
yeah.
lot of weight,
Yeah.
so it's
But
good.
that's a good. At least you're going in the right direction, Joe.
Yep. I
All
was
right,
looking
sounds
at that
good, yeah.
last session, and one of the things that always stick with me when I know, Dave, you're a big advocate for not having code comments. I one time talked to a developer that said he didn't believe in leaving code comments or naming methods with clear names because he always felt that if he documented his code, what it was actually doing and made it readable, that he would be the potential for losing his job. So he always wanted to leave messy code so that he would not worry about losing his job, which I always told him was a terrible thing. I'd rather leave my code readable so that I could leave at any given point in time.
Yeah. Well,
Yeah, an insecure person would say that.
Yep.
Obviously. Yeah.
There's I worked on this short contract because I couldn't stand it for UCSD, and one of the developers there wrote something in Access, and he did it all in Polish or something like that. Some other language that nobody knows, right? And so nobody could work on the project, and so job security, I guess.
Yeah. That's not how it works. Come as soon as I will find out and get my chance. First, easily the first one to leave.
Yep. Pretty much.
Yeah. All right. Sounds good, Joe. Stage all yours. We don't want to take too much time.
Cool. Well, thanks for having me. My name is Joe Guadagno. I am a director of technology at Rocket Mortgage. We're here to talk about 6 or so new features of .NET 6. So let's get started. If you want to reach out to me, you can reach out to me in any one of these different ways, at Jay Guadagno on Twitter, Joseph Guadagno Net on Facebook, LinkedIn, etc. As a reference, there will be a lot of links in this demo. If you want to write any of them down, they all start with jjg.me/6 for 6 or so reasons, and then underscore something, as you'll see in the future. Well, enough about me. We're here to learn about some of the changes in .NET 6. So let's take a look at the agenda. We're going to talk about C# 10, some of the changes that were there. We're going to talk about some ASP.NET changes. And then we're going to talk about Maui. Forget that. We're not going to talk about Maui because Maui didn't get released with .NET 6. We're going to talk about some Windows Form improvements and then walk into some performance improvements, then new API changes, and then some other things that are important to know about .NET 6. But before we get started with that, let's talk about .NET as a whole and where we are. So the purpose of .NET, you've heard in the past, there's .NET Framework, .NET Core, now it's back to just .NET. The purpose of that is to kind of unify the platform. So Microsoft has this vision of a unified development platform where you have cloud, web, desktop, mobile, gaming, IoT, AI, and they're all using .NET 6 or 7 or 8 and so on, with a common set of libraries and a common ecosystem, NuGet, GitHub, other libraries, as well as a common set of tools, Visual Studio for Mac, Visual Studio Code, or the command line. So no matter where you are, what platform you're developing with, or what technology you want to use, meaning gaming, mobile, desktop, etc., .NET is the platform to support you. So how do you get started with .NET? Right now in Visual Studio or the command line, basically your CS proj file needs to have this new target framework moniker, which is .NET 6.0, in order to use the .NET features. There are a couple other monikers that are available depending on the OS you want to target. Now, these are specific OSs or specific monikers if you want to target. Like if you want to use Android specific, meaning you're only writing your app for Android, You can do .NET 6.0-Android, and it will target Android specific APIs. Like if there's an API that's available only on Android devices, but not maybe the Mac OS or TV or Windows, you can do that. If you're targeting .NET 6 as a whole, you get the highest level of compatibility. And then each of these drill down, very similar to the way it used to work in .NET Standard. You get the highest level, and then you can drill down into the specifics. So let's take a look at the changes that were made for C# 10. There were quite a few of them. I'm not going to go into every one of them, but we're going to take some highlights. First thing is global usings in code. Right now in your code, you can do using system.console, using system.environment, and so on. Your code, each code file is usually littered with a bunch of using statements. Now you can do a global using, which kind of sets this using for anywhere, meaning every one of your files or every one of your classes, namespaces, etc., automatically have this using statement in it. And there's a couple of different ways to do this. So you have this one first, which says global using system. This is putting the system in every one. So now you can do .console and all the others without having to worry about system.console or adding a using to your file. You can also use static ones. So here saying using static system.console. So now I can just do right line globally instead of the couple of extra keystrokes of console dot all the time. You can also rename some of them. So here you see I'm using env equals system environment. So everywhere where I want to use the system.environment, I only have to type env. So it's about making it easier for you to, use your code and not have to repeat yourself over and over again. If you don't want it in your using statement, you can put it in the config file. There is no requirement as far as when to use global using or where to use them. But for most blog posts I've seen and some of the work I've done, most people are putting it in a global using.cs or global.cs so that you can discover it. But there's nothing stopping you if you have 5 files to put one global using system in file 1 and then another global using in file 2. That just makes your code unreadable. So in most cases, just put it in one file. If you don't want it in a single file, you can put it in the CS_proj file. So using the 3 examples before, we have here where in that item group section, you use a using include equals system. And this has system will be used anywhere. Then you don't have to worry about what file it's in, but this will be specific for that project, which is the same case for the other one. In the other example with static, it's pretty much the same statement, except there's a static equals true at the end. This includes the system.console in all your files with the word static on them. And then alias equals env for the last example. Now, if you're like me and want to know how this happens, behind the scenes, there's a file that gets generated that stores all these. There's also another way if you use some common projects where there's now something called the implicit using, which looks something like this. Now, this is done inside the project file, and you can set implicit usings equals enable. You can actually just set it to true too. Essentially anything that returns to a Boolean true or false. So if you do your implicit usings enabled, it's going to automatically infer some usings based on the project type you choose. So we look at some of the project common types like Microsoft.NET.SDK, SDK.web, SDK.worker, Windows Desktop for both WinForms and WPF. It's going to generate a series of using statements. So with the .NET SDK, it's going to generate these usings. So it'll automatically assume you want system collections generic, system.io, system.link, etc. And you can see a full list of all of them at the URL below. If you're using a system.web project, you'll notice it includes a lot more. And it does this based on research and analytics that are captured with how many people are using what using statements. So here, it's going to include system.net, HTTP, JSON, a bunch of ASP.NET cores, builder, host, HTTP, routing, configuration, dependency ingestion, hosting, and logging. And for workers, it's going to be configuration, dependency ingestion, hosting, and logging. For the Windows desktop world, it's a slightly different. So it's basically everything in the system.NET SDKs. So that was the system, generic, system IO, system link, HTTP, etc. Plus it adds system drawing and system.windows.forms. If you're building a WPF app, it's the same except it removes system.io and system.net HTTP. Another cool change to help eliminate some of the quote unquote noise that we see in our code is file scope namespaces. So here you see an example where it says namespace equals Joseph Guadagno and then a class file namespace. So now I only have to put the namespace at the very beginning of my file, and .NET pretty much adds the namespace over it. So now this class, it belongs to the Joseph Guadagno namespace. So it's Joseph Guadagno.filescope namespace. If you like that, then you might like one of the language features I suggested, which is why not take that to the next level and put the class on there. So you do class Joseph Guadagno.filescope namespace. If you're interested, look at GitHub. There's a bunch of issues around this format. There's also some Lambda improvements. So if you look at line 2, we have this function here, which has a string and int. Parse equals string s, which goes to int.parse string. Now in .NET 10, we can kind of infer what that return type is based on the class. So here it's going to infer, if you were to hover over the parse, you would see it's going to infer that you want a string and int back because you're passing a string in and you are getting back an int from the int.parse, which is kind of cool. Again, less keystrokes, making your code hopefully a little bit more readable and relying on your IDE. You can take that step, you can take the Lambda improvements or this particular feature one step further with Lambda records. So if we see this example here, function int read console, now you can infer that I can just do var read equals console.read, and it's going to know that read, or read in this particular case, is going to be an int because console.read only returns an int. However, the action, where it's action string write equals console.write, doesn't work because write has multiple overloads that we don't know. So here, line 5 is a valid statement because we know that console.read only returns an int, but var write doesn't because write has multiple overloads and it doesn't know which overload you want. Let's take a look at some of the other improvements in C# 10. So we have multiple improvements to struct, and there are too many of them to list out or even show you code for. But basically, the biggest improvement is that now we can include within our structs parameterless constructors. That's always a hard word to say. Even the next feature is even harder to say for me. But essentially, let's say you have a struct, first name, last name, date of birth, or favorite color. You can default some of those classes, some of those class members to a value. So I can say first name equals Guadagno if I know I'm only creating classes with, people that have the last name of Guadagno. Or if I want to have a property true or false, I can set them all to false. There's also a lot of improvements to interpolated strings, which was a feature added one version ago or two versions ago in the C# language. There's actually a very lengthy blog post, something like 40, 50 pages on the changes that were made. Essentially, they've optimized how the string creation is done by handling the memory better. So if you get into the internals of the interpolated strings, what ends up happening is every time you have a curly braces and a number or a value, the framework would take that as a string dot format. And every time you had one or more string dot formats, you're creating memory and destroying memory, copying things over. So they got away from that and started with reading the string and recreating the memory right way, or a better way. There's also now support for constants, so you can do a constant first name equals Joe, or first name equals and then parentheses name for a person. There's also the ability to override how the interpolation string handling is done if you really want to tweak the memory. I don't suggest you ever do that, but some people like to. If you want to know more about the language improvements to C#10, you can take a look at this blog post, jgg.me/6_C10 to see some more improvements. ASP.NET has had several improvements that we're going to kind of walk through some of them. We're going to do all these at a high level. It's just too much to talk about in 45 minutes. So let's take a look at the first, minimal APIs. If you've seen anything in .NET 6 or ASP.NET, minimal APIs are everywhere. Essentially, minimal APIs allows you to get rid of a lot of the startup cruff, as it's called, or startup stuff, controllers and all that, if you just want to return basic things. So here's your typical hello world, where we're essentially creating an app that at whatever the default port is for your app, in this case 4000, because that's the default typically, we are going to expose one get method that returns a response of hello world. But technically you can do anything you want here. These are generally intended to work with file servers, where they're one-offs, or maybe reading status updates or returning one file, one or two different things. They're not meant to replace full-on APIs, although you can, but then they start to get messy. You can also mix these with quote-unquote regular MVC style controllers and methods. Oh, and as another point, you actually don't even need line 2 for this. This is just shown in case you want to do it. By default, it's going to create a builder for you. If you want to know more about it, check out the URL below, and there's a lot more links for you. Some other improvements in ASP.NET Core, again, check out this link. SignalR has had a lot of changes. There's a new HTTP activity feature that you can check for long-running processes or set up processes long-running. There has been a new activity added for application insights to add in applications insights telemetry to your calls. There's been a new way that hub caller clients are arranged to use once per connection versus every connection. Some other memory management features, which I probably won't cover here because they're a little bit more technical. There's some Razor improvements. Right now, Razor uses the new source generators, which I'm not going to talk about for this presentation, but it basically behind the scenes will generate code for you, so you don't have the compile time, runtime reading of your CS, HTML files, etc. Hot reload was a very hot topic right around the release of .NET 6 because there were, fortunately, some of the features got delayed with it. Right now, hot reload allows you to, or not necessarily allows you to, but your application will automatically refresh based on changes that you make in your project. Right now, this works in Visual Studio 2022 as well as the .NET CLI. So if you're running an app there, you make changes behind the scenes, it's going to compile the code and automatically reload your web page or your application. There's been some changes now to ASP.NET for HTTP3 support. It's basically in there. You can interact with it. It's not going to be turned on by default. There's improved SPA templates. Now the single page app is a little bit more fine-tuned to work with .NET, as well as the web app templates have been updated to version 12 of Angular. So let's take a look at some Windows Forms development. Yes, Windows Forms is still a thing. There are lots of companies that still use it. There's been a lot of changes to the accessibility for it. So you see the checklist box, link label, panel, scroll bar, tab control, and track bar have all had UI automation providers added to it to allow you to add in accessibility things to it, like on, off, yes, no, that kind of stuff. For those you don't know, a UI automation provider, essentially an object that's passed to the application's UI so that an accessibility client like a screen reader can know what that is and can provide more realistic feedback as to what the object is. Some other changes in Windows Form. Now you can set a default font for your application across the board. So instead of taking, whatever the Windows operating system was, which I believe was the default for Windows Forms, you can now use the application set default font and set it to whatever font you want. That will change the font for every part of your application where there is a font accessible. It won't use the default Windows font. So this is your opportunity for everyone that loves Comic Sans Serif font to add it to your app and turn your app into the most comical app around. There's also support, just like we have in the C#10 with namespaces and single file apps. You now have that ability within a Windows Forms app. Now, this one is not taking it to the max to avoid confusion. Microsoft wanted to keep these templates the same. So here, class program with the STA thread as an attribute. You can technically remove that, but they thought it would create too much confusion. There's actually a template that's out there without that in it. But you'll notice that the static void main, for those of you who do Windows Forms development, is a lot smaller. Right now, you just have the application configuration.initialize and then running your application. Behind the scenes, the initialize event is actually doing a lot more. So it's running the enable visual styles, the set compatible text rendering default, the set default font, the set high DPI mode. You can still change those if you want, but by default, it's going to initialize them with all default values. Again, one of the things with .NET 6 was to eliminate a lot of the redundant code that you type and let the compiler figure that out for you. Some other Windows Form updates. There's been a lot of template updates. There's been support for the new application bootstrap, which I showed you on the last page, essentially those two lines. Global using statements, file scope namespaces, nullable reference types. There's a lot more runtime designers. I think they added something like 40 runtime designers. These allow you to change additional properties within the IDE while you're developing your Win format. Single file apps in .NET 6, they created the ability for in-memory single file apps are now available for both Windows and Mac OS. So it creates everything that's needed for your app to survive in just one file, which means you can get back to those Xcopy deployments that we had a while ago. To see more on what's been updated, check out the blog posts below. By the way, all these blog posts are not just to my site. There are a various set of sites, mine, Microsoft, as well as a few others. One of the biggest things that are touted about .NET 6 is how fast it is. This is definitely one of the focuses within the .NET Framework team. One of the things that was improved tremendously was file I/O. In Windows, they worked on file I/O a lot. They did it on the Macs also, but in the Windows device, they really made changes to the file seek, file positions, and they were able to increase performance dramatically. So here's a quick look at it. So here they wrote a sample app, and then you can go to the blog posts below to read more about it. But they created a method called write 100 meg async. And as you can imagine, that's going to write out a 100 meg file. In .NET 5, it took an average of a second, 1.3 seconds or so, and allocated about 3,000 K of memory, actually almost 4,000 K of memory. In .NET 6, that same file writing out took 306 milliseconds. So about 25 to 100% faster, depending on how you look at it. Or here, as it says, 65% faster, and uses, I can't even count the fraction of memory, but they reduced the memory footprint on it. It's almost 1,200% or 1,200 times less memory for it. There's countless other I/O improvements that were made. Check out the post below to see more details. Here's another one. We're going to be talking about source generators in a minute, but essentially, we know that a lot of us are doing processing of JSON files, whether it's a file coming in off a hard drive or someone FTPing it or downloading it from the web. So we spend a lot of time reading these JSON files and trying to parse them. We've ended up, or the Microsoft team ended up really working on the serializer to great extent. They have also built a new source generated serializer, which we're going to cover a little bit. But here you can see that the average time for a reader, now this is in .NET 6, just to show you the difference between the serializer and the source code generated serializer. The average time was about 1 to 6 times faster, or 1.6 times faster than the other. And we'll walk into a little bit of how you do that. But the overall gist is performance was a big part of it. If you go to that previous blog post that I showed you, this one, you'll see a lot more on there. So let's take a look at some of the new APIs that were built out. So the first is a series of JSON serialization APIs. So this is a sample class in the namespace test. It has a person that has a property of first name and last name. Now, what has been in most cases, we take this property and we're going to do a JSON deserialize into this. .NET uses reflection to see what properties are in your class and then goes through and tries to parse out the first name and last name based on the property first name and last name. And that has a performance hit to it because every call to reflection does that. If you have an object that has 100, 150 properties on it, and you're trying to read those in, you can imagine how that adds up. But now with the serialization to it, you add in this context, very similar to an entity framework context here, which has to be a partial class. And call it whatever name you want. The general best practice is to do it similar to the name. So this my JSON context is probably not a great example. It probably should be person JSON context, and then it inherits from JSON seriable context. But the key part is the fifth line, JSON serializable type of person. So what this is going to do is do the reflection at compile time and generate a class that can read that for you. So the source generator is going to generate something like this. And this is a partial class. So it has a method called default, which is going to return the default of whatever that object is. So for the person, the default will be a null person. And then it's going to expose a class that would be the person, which is of JSON type info person. So that compiling, oh, did I lose the stream? Am I still there? Sorry, it looks like I lost connection, or at least on my screen, it looks like I lost connection.
Joe, we can hear you. You're still online.
Oh, my screen disappeared, so I thought I lost you. Thank you. Hopefully we heard everything that was part of this. I don't know why I can't see it anymore. Nope, now I got 2 copies. Sorry, my screen just went blank, so I apologize for that background noise. The MyJSON context exposes a bunch of options to allow you to change like the case sensitivity, etc., that kind of things. And then the get type info just returns the class of the information so you can do your own reflection. But that's a lot of behind the scenes stuff. In most cases, you don't need to do that, but let's just take a look at what how you serialize that class looks like. So if we come to the next slide, we'll see here's a sample person, has first name Joe, last name Guadagno. And then we are going to serialize this using 2 UTF-8 bytes. And we pass in the class of person, as you see on the 4th line. Now, these are only spent to multiple lines just for readability in PowerPoint. But, really, this is 3 lines of code. So here we're creating a byte or creating an array of bytes of the person and saying to use the default person serialization. And then to deserialize this, we're going to take that same code as if we read it on line 3 and say use the myJSON context.default.person to deserialize this. And what we'll see from this is that we get much better throughput. With this sample class of just 2 parameters, we got around a 1.6 times performance increase into it. It reduced startup time of the serialization, so you can serialize almost instantly now because we don't have to do that reading of reflection, reading of the class, and then doing that parallelization. All that's done now in the code. Also cut down on memory usage because we're not caching the structure of the object and so on. You can read more about it on the site listed below. Let's take a look at some of the new APIs that we have for ASP.NET. So a community contribution was done for WebSocket compression. So now you have that ability within .NET 6. There's also a support for SOCKS proxies. If you're using SOCKS, this is a very helpful one. There's now in the Microsoft extensions hosting, you can now access the configure host options API directly instead of having create an instance of the host and then access the host model, then access the config options. You can now access them directly when you're creating it. There's now a extension method to do it. Most cases you won't need to do that, but it's there for you. Again, trying to minimize the amount of repeat code that you're doing. There's also another new thing added to logging. Now we have compile time source generation to it. So within .NET 6, there is now a logger message attribute that's added. Now with the logger message attribute, you can add some pre-configured things to it. So in this particular case, I'm creating a method or a log method that says could not save user, and I'm giving it a random event ID of 0. This would be whatever yours is. This is also assuming you're going to the Windows Event Manager store, so whatever the ID is for you. You can set up a level for it, in this case, level critical, and whatever message you want. So now within your code, you just call logger.log could not save, and then pass it in the logger instance and the user ID, and it will automatically log the event. So it's a lot less code that you have to write. It also eliminates boxing and unboxing of variables when you start taking things from integer to string and so on. If you're a fan of system.link, which I believe a lot of us are, there are a lot of changes to system.link. First one is now there is enumerable support in index and ranges. So that means within a range, you can now loop through only parts of it. So if you have a range of 100, you can say, I just want to iterate through 5 and 9 using the for each and not necessarily for. There's a try and get non-enumerated count. So this exposes an API that allows you to get the count of your overall collection or array or anything else that's enumerable without having to for each loop. So if you're thinking like SQL Server, this allows you to do a select car without, or select count of star without having to go through each item in the array. There's also new distinct by, union by, intersect by, and except by that have this new variant that allows you to use key selectors. So now I can do select distinct by x to x dot primary key, and it will return that as opposed to putting it in a loop and finding it out yourself. Same opens for the same is applicable for max min and max by. You can actually specify the property that you want the min and max by, just like you could on the intercept, except, union by, without having to iterate through the whole collection. There's now a chunk, which was a community contribution that allows you to break up your IEnumerable into chunks. Let's say you have 100 records being returned. You can chunk and focus on 10 records at a time. This also works with first or default, last or default, and single for default. They actually have default parameters now. So by default, you can do first or default, and the link will determine what the default type is for that variable. So if we use the person class we had before, it's going to return a null person. But you can actually override that now with this community contribution that says if a person isn't specified, give a new person with these characteristics, or if an int is not specified, set it to -1 instead of default and 0. There's also the zip contribution, which allows you to compress the enumerables in multiple different ways. There's a priority queue now that allows you to control how items come off the queue. So you can do it based on property as opposed to just first in, first out, or last in, last out. Some other changes that came to the API is some command line changes. So now from the command line, you have the ability to restore, install, or list workloads. So now you no longer have to run the Visual Studio installer to change bits and pieces. Like if you want to add the .NET, ASP.NET part to it, or if you want to add the Windows Forms part, you can now do that via command line, which means you can actually control your builds a lot better. There's also the ability to check what SDKs you have on your machine now. So now I can do a .NET SDK check, and I can see in this screen sample, I had .NET 3.1, .410, a bunch of different versions of 5.0, and a couple of different of .NET 3. But one of the things you'll see, and hopefully the resolution is good enough for you, that you can see now the status of them. So in the second part of the runtimes, you see that I have version 2.1 of .NET Core, which is out of support. My version 3.1.10 actually has a patch that's available to 3.1.22, so I can effectively get rid of those. .NET 5 is going out of support, and for my .NET 6, at the time I took this screenshot, there was a patch available. Okay, .NET New is not new, but there's been some changes to it. Now there's a search that gives you the ability to search for new templates. So if there are items that are not installed as part of the basics, so like the out-of-the-box .NET template, so for example, the Uno platform, you can now search for those. There's also an interactive thing that, or an interactive flag that allows you to put in the parameters that you want to search for. If there's, if you're using a private NuGet store that requires login credentials, you can do that with this. Then there's an update check and update supply. There's also 16 different Roslyn analyzers added, as well as 6 that were from the community. You can see more about that on this site. And with a minute to go, let's remember the last thing is .NET support. Now that .NET 6 is out, with the original release date of November 8th, it's going to be supported until November 8th of 2024. What that means, more importantly, that now that .NET 6 is out, .NET 5 is now running out of support. You have about 4 months left until .NET 8 is out of support. For more on that, check this out, that link. Here's a little bit of example. The purple lines kind of show the export. The even numbers of .NET have long-term support, which means they're typically supported 1 year after the second even number comes out. So .NET 6 is supported 1 year after .NET 8 comes out. But the odd numbers, .NET 5, .NET 7, are typically only supported for 1 year after the next version. That's all I have to say. We have about a minute left for questions, if there are any. I can't find my screen to see. Oh, there you guys are. I moved you to the front screen. That's why I couldn't see you before.
That was a lot of updates. I like it, love it. I love your...
Yeah, it was hard to squeeze in 45 minutes.
Yeah,
that's
well,
why I put links to all the blog posts.
I think it was pretty good. It was good.
Thank you.
Hey, Joe, I had a question because, I wasn't aware there was a source generator for serialization. So is there like a list somewhere that lists all the source generators that are built into .NET?
I have not found one because I had that same exact question. Because what I've noticed is as you're reading blog posts on what's new in .NET 6 or checking out the GitHub repos, you'll randomly see, and there's a source generator for this. I don't know. I can check with someone on my team that really knows about source generators and see, but I have not seen one.
Yeah, I have a question too. Go ahead, David. You want to finish it?
No, that'd be great to have. You know, if Microsoft, if you're listening, put out a page with all the generators that are built into the .NET.
So it looks like there's a lot of work being done on struct somehow, but classes are left alone. Looks like nobody likes classes anymore, and there's new records, obviously. So what's going on there? Are they trying to make a struct as a duplicate of classes?
Yes and no. What they're doing is trying to provide a minimalist approach for those that just want to do one or two things. Classes give you a lot more flexibility as to what you can do. It's kind of one of the reasons why records were created, to have a smaller subset. Like there's no reason to overwrite toString. Most people don't overwrite, get hash, etc. So they created records just to do that. Behind the scenes, it creates a class and everything, but it's small. It's a lot smaller on, in your UI. So you're not worried about a lot of that. The structs, they realize that there are some benefits to setting defaults. I think a lot of this has to do with the nullability that was said in .NET 9 or C# 9. They're trying to make it so that we have less objects that can be returned nullable. So creating constructors in structs allows you to be able to avoid that if you're using properties in them or objects in them.
Yeah.
Great. Awesome. Well, that was great. Anything else, David, before we let Joe go?
I just realized I need to get more sun.
Yeah.
Look at me. I'm so pale.
Well,
there's no sun here, so I pretended I have a sun behind me.
Yeah. You got that bright ring light right in front of you, David.
No,
I know you haven't been out on the beach.
That was a great session, and I can't wait for Joe to be on my 20th anniversary show for .NET on the 12th. So
yeah, he's a lineup one for me too on my growth mindset.
Take a number, both of you. Okay,
All
have
right.
a great rest of the conference, guys.
All right, Joe.
yeah, thanks,
you.
Joe.
All right, so that was great, David. I loved so much. It's looked like there's so much in C# 10 and .NET 6. It's just amazing, and obviously the performance is one of the performance, code cleaning, faster coding. These are three things. They're pretty big.
Yeah, we need them, especially, we mentioned this yesterday that, performance is a big deal. And that's one of the reasons why I've been focusing on it for the last, 3 or 4 years. I put out a book about code performance because not only should apps be like that anyway, but, the big thing now is the cloud. The longer your code takes in the cloud, the more money you're going to be charged. And so,
yeah, and funny thing is, we have a new project, and our architect decided to use Node.js, and then after yesterday, I nope, we're just going to do .NET Core, .NET 6.
Yeah. Yeah.
All right. With that said, let's bring our next speaker, Redis. Redis is one of the middleware and kind of storage we use for different applications. And our next speaker, Steve Lorello, is going to show us something cool things in Redis Search.
20 years ago, a seed was planted and cared for. We painstakingly nurtured it and weathered it against adversity until one day it blossomed and the fruits of our labor began to show. Today, millions have learned, shared, and been inspired by what our community has produced. We proudly serve 21 million users from 204 countries in 2019. For our 85,000 technical articles, code samples, and videos, our 450,000 forum questions, and our highly anticipated conferences and events featuring keynote panels, live streams, and industry experts and influencers, we recognize and reward members Redis for their dedication to the community. Through content contributions and mentorships, we ranked number 2,620 in the world with a reach of millions across our social media channels. Thanks to you, our global community of software and data developers grows stronger each day. For more information, visit us at csharpcorner.com.
Hey, Steve, welcome to the conference.
Hey, thank you for having me. How are you?
Hi, Steve.
Hey.
I'm glad we picked this session because I've used Redis off and on at different projects. The project I'm on right now, it currently uses it. So, and I know Redis is used a lot these days. So,
yeah, it's got a lot of, we have a large user base, but I would say that like 95% of the folks out there are just using Redis as a cache or just doing basically sets and gets, and there's nothing wrong with that. But actually, this talk is going to be about using Redis for a little bit more than that.
Yeah.
So,
Yeah, and I think the obvious reason I can add my own point here for a minute. That obvious reason is we don't know that. I've been, in C#.NET for years and years, and same thing with you, David. We just don't know.
Yeah, I think the common thing for folks on our team that when we go to conferences, if we're in front of a physical crowd, it's like the first thing is everyone raise your hand if you've heard of Redis, and probably 60 to 80% of the hands go up. And then like this next thing I'm going to be talking about here, maybe like, do you know about that? Maybe like 1 or 2 hands goes up. No, maybe we've used that before, but it's actually a pretty neat technology. So looking forward to talking about it.
Yeah.
Awesome. Before taking up too much time, the stage is yours.
Sounds good. Let me just minimize that because I hate seeing myself when I'm giving a talk. So hello, everyone. My name is Steve Lorello. I am the .NET developer advocate at Redis, and I'm going to be talking to you today about indexing, searching, and aggregations with Redis using Redis Search and specifically .NET. All right. Before I give any talk, I usually like to give a little bit of an agenda of what we're going to go over. First, I'm just going to start out with a brief introduction of what Redis is. And then we're going to talk about some of the Redis data structures. Then we're going to be talking about secondary indices, and then specifically building secondary indices with any version of Redis that you could find out there. And then a little bit more succinctly, how to build them with Redis Search. Then we're going to be talking about writing queries with Redis and writing aggregations with Redis. So what is Redis? Like I said, when I was just talking now, Redis is a NoSQL database. It's completely in memory, and it's fundamentally a key value store. And those 3 things together make the database, when you're using it for like its simplest purposes, like caching, extremely simple to use and extremely fast, which makes it very popular. But Redis is also a multimodal database, so you could use it for a lot of other things other than just using it as a cache. And that's sort of what the theme of this talk is. But before we get into that, I think it's important to cover a few of the Redis data structures, because these will sort of set us up for understanding what indexing and searching in Redis really looks like. So some of the Redis data structures are, and there's more than this, but strings are very popular, sets, sorted sets, hashes, and JSON. Now, strings are a single key that retrieves a single value in Redis. The values can be encoded further down as either numerics or strings, and they are the most basic data type in Redis. And like I was just saying, most users that use Redis never go beyond using basic strings when they're using Redis, and there's nothing wrong with that. But there's more than this. So, for example, like the classic example here is if you set foo to bar. Sets are a set of Redis strings. They're unordered, they do not allow duplication, and they support set operations. So, for example, right here, we're doing like an sadd with the classic person example, :name, :Steve, and then I can pass in an ID to it. And this should be giving you a little bit of a hint as to what the indexing that we're going to be looking at a little later on is going to look like from just the any Redis perspective. But this can be very useful for building things like secondary indexes without Redis search. Sorted sets are ordered sets. They basically have the same properties as sets, but they store a score as well as the actual set member, which is the string. They also don't allow duplication of members. And when there is a collision between at insertion, you specify the behavior that it uses to aggregate the two results together. But I think generally the last in wins. So for example, going off of our person example from before, we can have a person : age, which is an attribute of a person. And for person 1, we can set their age to 32. For person 2, we can set their age to 45. And that's using this zadd command. And then you can order things in sorted sets by things like their scores, or if every member of your sorted set has the same score, you can order them lexicographically too. So you can do things like alphabetize things with using sorted sets. Redis hashes are where we get into seeing things in Redis as more than just flat strings. They're field value stores within a within a key value store. So there's essentially, it's like storing a dictionary inside of Redis. They're great for things like flat objects. Their field names are always strings, and their field values are also strings. So, for example, here, if I wanted to add a person to Redis, I could say hset person : 1. So that's the key name or ID that I'm going to use. And I could set their age to 32 and their first name to Steve. And if we look back here, we see that this person : age has the ID and the age. And again, the person : name : Steve has this ID. So this hset here actually sets that key to these values, and then I can go in and I can actually index it further with that. But we'll get into that in a little bit. And the last data structure that's important to talk about in the context of this talk is the JSON data structure. So you store objects as JSON, and you can access them and update them via their JSON path. JSON is not a native module of Redis. It's part of a separate module called Redis JSON. It's available under a source available license. So if you just want to bring it into your application and use it, you can for free, but you can't use it as like a SaaS product, and it's not necessarily available in other instances of Redis like Elasticache or it's not available necessarily in those. But it's available under this source available license. If you're interested in it, you can look at it. But anyway, but what's powerful about JSON is that if you're storing more complicated objects in Redis, you traditionally would just do a set, and then you would just pass in a string with a bunch of JSON in it. And the problem with that is if your objects are really big, you essentially have to pass the whole object in, and then whenever you want to change something, you have to retrieve the whole object, deserialize it, change the one thing, and pass it back in. And that's fairly expensive, and Redis is supposed to be really fast. So what's nice about Redis JSON is it lets you just go in and manual update individual fields. So I could just go in and change the first name field to change it to something else like Bob if I changed my name for some reason, or more likely if I had to update my age to 33, I could go in and update it to 33. But yeah, that's JSON. And so like we have these two data types, hashes and JSON, which allow us to do things like store sort of objects in Redis. Now, that actually brings us to the topic of this talk, which is finding stuff in Redis. So in Redis, you can't just search for things like you would in a SQL database. There's no like select star from people where first name is equal to Steve, nor is there a select star from people where age is less than 35. You actually have to explicitly build a secondary index to be able to search through things efficiently in Redis. Now, secondary indices are just they're able to efficiently find items inside the primary index based off of other attributes. So in Redis, the primary index are the key names. And secondary indices are also explicitly declared. And traditionally, they would require separate maintenance and updating. And that actually brings us into secondary indexing with just vanilla Redis, like you can just do a Docker pull of the Redis image and do this in that image of Redis. Now, for secondary indexing with that type of Redis, for exact match text, you can either use sorted sets or unsorted sets. Same thing with exact matches for numerics. If you want to do something with sorted numerics or lexicographically sorted strings, you would have to use a sorted set. And for full text search, you could also build them with sorted sets. So, for example, here, person colon name colon Steve is a set that contains just person one. Okay, and then this other sorted set over here, person colon age, is a sorted set, and the IDs and contained in it are person one and person two, and their scores, which are the age, are 32 and 45. So, doing exact match checks basically means that you have to go out, store the data in the hash. Then for each field that you're indexing, you have to create a new set. And then when you want to query it, you have to do an S members on that set and actually pull back the members of the set. And then you have to go back to Redis and ask for things. So with numeric range queries, it's a little bit easier. You just store the scores in a sorted set for a particular field, and then you can use range queries to find things in there. Now, the pros of doing this in just regular OSS Redis is that it can be done on any Redis database. You have total control over what you index and what you don't. And I do say somewhat facetiously in there, it's good for job security because it's very complicated to do this kind of data modeling. And the biggest issue, actually, the biggest con of this sort of data modeling is that it's impossibly to horizontally scale across a set of sharded databases and still be able to update them atomically. So in consequence, you need regular consistency updating throughout your Redis cluster if you're building out any sort of larger data set. And that brings us to Redis Search. Redis Search is a module of Redis that is maintained by my company, Redis. It allows you to define a schema of a secondary index and ship that off to Redis, and then Redis will take care of indexing everything for you, and it will automatically index your data and provide you things like full text search capabilities. You can do like geofiltering. You can index automatically, and that index, unlike with OSS Redis, you can actually maintain them automatically across your shards. There's something called the Redis Search coordinator that allows you to do it cross shard, and this is available under the same source available license I was mentioning earlier. So to spin up an instance of Redis Search, you could do something like a Docker run -p 6379:6379. We still have 6 days until Docker Desktop goes. You have to pay for Docker Desktop, so you can still do that for free. For creating indexes, you can create an index declared directly on the type that you're indexing. So by type, I mean hash or JSON. So you could either index hashes or you can index JSON. And then indices can be declared on prefixes. So for example, person colon would be the prefix of a key name that you want to index. And then indices contain a schema for mapping fields to index types. And there's 4 types of indexes you should know about if you really want to get into like the guts of Redis Search. There's tags, which allow for exact matches and faceted matches. There's text, which allows you to do full text search. There's numerics for numerics, and there's geo for geo coordinates and searching and doing geo filters and stuff. So querying in Redis is based on the type of the field that you've indexed. For a tag field, you use the @, the field name, and then colon, and then in braces, you put the actual data that you're searching. For text, you basically the same syntax, except you're not using the curly braces. For geo, you have to add the geofilter subcommand on this, and basically pass in the field name, the longitude, the latitude, the radius from that point, and the unit that you want to base it off of. And for numerics, you basically have the @field name, and then in square braces, you have the lower bound and the upper bound. And then also Redis Search provides aggregations, which allow you to query your data along the same syntax so you use for standard querying. And then you can build pipelines to transform index data into Redis. And then you can group like items together and run reductions on them. And you can filter data based off of the results of those aggregations. For pretty much the neat thing about, to me at least, about aggregations, you can run apply functions of them. So you could essentially tell Redis to perform an operation on all the things that your filter has brought back and store them in something else. And you can use this for a variety of mathematical string and timestamp functions. And you can store the results of apply functions in the pipeline and use them further down the pipeline for other things. Group bys and reductions allow you to group like items together and run reductions of them, like sums, averages, standard deviations. There's quantiles, which lets you like calculate medians and stuff like that. Then group records can also be further passed down those pipelines. And that actually brings us to Redis Ohm, which is the library specifically for handling Redis search in a slightly more .NET centric way. And I didn't get too deep into the syntax of Redis search because I was going to be talking about this. It provides a fluent API for searching and aggregations, and it provides object mapping so you can map your objects to your Redis data structures. And with that, I'm going to open up my command prompt, and Teams is going to pester me for my Windows user ID, and I'm going to close that out. And I'm going to go, and we're actually going to do a little bit of coding here. So I'm going to cd into projects, cd Redis, and I'm going to do a, you know what, let me zoom in a little bit because I know this can be hard to see. .NET new console -n test Redis search. Ever since I updated to Windows 11, Teams was really obsessed with getting me to sign in, and I just haven't done it yet. So I'll cd into test Redis search. I'll do a .NET add package, Redis search, or no, Redis.ohm. I'll check Docker real quick, and I'll do a Docker stop. Just start up Docker again with a clean image of Redis. So .NET, Docker run -p 6379:6379, and I'll use the Redis mod image. That'll start up Redis for me, and I can go ahead and open this up in Writer. And I'll trust and open. The first thing I want to do is define a model that I'm going to use here. And my favorite model to use are Muppets. So I will define a class called Muppet. And in Muppets, this into attribute. And now in Muppets, I can add my fields like prop, string, first name, prop, string, last name, prop, int, age, prop, geolock, home location, and prop, string, personal statement. Now, I don't know if I spelled that right. Did I spell that right? Probably. Yeah, I'll just get a warning later if I didn't. Now, just like this, I can add a Muppet to Redis quite easily. But what I really want to do, and what I want to show you in this example, is how you can query things easily in Redis. So I'm going to set indexed on first name. I'm going to set indexed on everything except for personal statement, which is going to be searchable. And when I tell Redis Ohm to define to create the index for me, it's going to take all of the indexed fields and set them as the appropriate data type for the individual fields. And for searchable, essentially, it's going to set it as a text field, so I can just run full text searches on things. So with that done, let me go into program.cs. And real quick, I'm just going to show you how you used to have to set things in with OSS Redis before Redis search. and query them. So var muxer equals, I'll zoom this into connection multiplexer connect host. And if I wanted to set something in Redis, so say I wanted to set a very simple person, I could say that I want to db.hashset. I could pass in person : 1 and new. I don't like that. First name. So I have to pass in explicitly the whole object, Steve, right? And then after this, I would have to do a db.set add person : first name : Steve. So I have to take basically the person namespace, the first name, which is the attribute, and Steve, which is the value, and I have to add that key to a set that's defined with that. And so with that, I can now actually say our people named Steve equals db.set members and pull back person : first name : Steve. And then for each our person ID and people named Steve, console.writeLine, or no, wait. I have to get it from Redis. So var also Steve equals db.hashget all person ID. I think that's actually, I think you send that to a string, and then I can do a console.writeLine or for each for field and that will let me actually, I didn't mess anything up, print out the first name of Steve. So that was basically me adding a person to Redis, updating the index, then querying all the people named Steve out of Redis, and then going over each of them and pulling back another one. So it's 1, 2, 3, 4. It's 4 different operations to just index and query one field. And so that is sort of the cruft that we're trying to avoid with Redis search and Redis Ohm. So with Redis Ohm, on the other hand, I can just connect to Redis with a Redis URI. So Redis : / localhost : 6379, creating this new Redis connection provider. And then all I need to do to actually create the index is I have this Muppet object here, which I've already decorated with a bunch of basically fields that I want to index. All I need to do is say provider.connection.create index async and pass in the type of Muppet. And that will actually create the index for me. And after this, and this is something I want no one watching this talk to ever do in a production environment, just so I can reset it every time I run, I'm going to run a provider.connection.execute async /db, which will clear out the database for me, because I'm going to run this a bunch of times. So I'll just wrap everything in a try catch and drop this inside this try catch. Now, that's actually not going to show me anything, but if I went into I went into Redis and I monitored it and ran this again, you're going to actually see it creating this index for me. So it's going to pass in this ft.create, and it's going to basically build the index for me. So ahead of time, I went ahead and created a few Muppets. So I can just do a cat. I have a bunch of Muppets in here that I'm going to use as example objects, and I'm just going to drop them right here. I have to import stuff for modeling, but basically I have initialized a Kermit, I have initialized Beaker and Bunsen, and I also initialized a little restaurant where they're going to go meet a little later, called Nobu's, which is in, there's a chain, there's a bunch of them, but there's the one in particular is in LA. And so all I need to do to actually add one of these Muppets to Redis after I've initialized the class is just say connection or provider.connection.set Kermit. And I can pull back Kermit's ID, which I'm going to generate when I do the set. And that's actually going to set Kermit in Redis for me. And then if I wanted to get Kermit back, all I need to do is say also Kermit equals, you know what, I should probably await this. Also Kermit equals await provider.connection.getAsync Muppet Kermit ID. And I can just do a console.writeLine Kermit ID Kermit, or also Kermit dot first name, so Kermit dot last name. And what that will do for me is it'll print out Kermit the Frog. Can I zoom this in? I can zoom this in. Good. So Kermit the Frog. So it actually stored Kermit in Redis, got it back, and then I was able to write it out. So that's pretty interesting. You can, you know, store things, get their IDs, and retrieve them pretty easily. But that's not quite searching yet, right? What we want to do is we want to be able to search for things in Redis. And so with that, if I wanted to actually search and query for things in Redis, there is a iQueryable interface that's built into Redis Ohm called a Redis collection. And I can create one by just saying var Muppets equals provider dot Redis collection Muppet. And this collection now is a iRedis collection. It's also an iQueryable. And I can use link to actually query things inside of Redis now. So for each, let's say Muppets.where first name equals Beaker. So Beaker is up here, and I should probably add him to Redis before I do this. Await provider. Connection dot set async. I'll also add, for good measure, Bunsen. So now I've added all three of the Muppets to Redis. I can now search for all the Muppets named Beaker, and I will call this Muppet. And then I will say console.writeLine Muppet.first name Muppet.last name. I'll just do a quick delimiter up here. It's named Beaker. Let's run this, and you will see that now Beaker, and I put his last name as Meep because I think that's funny because that's the sound that he makes. I put all the Muppets named Beaker that have been added to Redis in here, and then it goes beyond that though. In this query language, you can query things by age. You can, combine queries. So if I want to say Muppets named Beaker or Kermit, I could say x.first name is equal to Beaker or x.first name is equal to Kermit. And that will print out Kermit and Beaker. I could also do a query by like age. Muppets younger than 65, and I believe that should only be Beaker and Bunsen, because I used the date that they first appeared on the Muppets as their age, as their birthday. So yeah, so Beaker and Bunsen should come up if I'm doing this query. So I could just say x dot age is less than 65. And yeah, Beaker and Bunsen both came up. So you can go. So that's essentially doing exact match or sort of range searches. You can also do things like full text search using this. So remember earlier in the Muppet class that I declared personal statement as a searchable attribute. So that means that when the index was created, so if I looked in here, no, not in here. If I looked in here, and I looked at the ft.create for this, it created the personal statement as text. And what text means is that it's full text searchable. So what I can do, instead of searching for an exact match, I can use that same language, that same syntax, Muppets that are scientists. I can use that same syntax to actually search for things with full text search. So personal statement equals scientist. And that's just going to match that text. And I believe I spelled scientist correctly. Let me just copy paste it so I don't embarrass myself and not spell it correctly. And this will print out Beaker and Bunsen again. So Beaker and Bunsen both get printed out because they're both scientists, because in their personal statements, they wrote, I am a humble lab assistant and scientist for Beaker, and for Bunsen, I am a scientist and inventor. So this library and this framework allow you to do full text search with Redis, as well as as well as just object mapping. So that's quite a lot. But the next, it actually gets even cooler though, because you can do things like geofiltering. So say all the Muppets wanted to go out to dinner somewhere, and they all wanted to go out somewhere nice, and they wanted to find somewhere that's relatively close to them. So they settle on Nobu's. I'll say Muppets closer than 10 miles to Nobu's. And I actually went ahead and I added Nobu's up here. And all I would need to do is say x dot, instead of a where clause, geofilter, say dot geofilter, and I would pass in the attribute that I wanted to use, x dot home location, and then Nobu's dot longitude, Nobu's dot latitude, and then 10 miles. That will print out all of the Muppets within 10 miles of Nobu's, which are apparently none of them. That's not good. Oh, that's why, because I did latitude twice. I did longitude twice. I say I tested this. So that puts all three of the Muppets within 10 miles of Nobu's. But what if I wanted to constrain that search and I wanted to say Muppets within 5 miles of Nobu's? Less than 5 miles from Nobu's. I could do the same thing, but I could drop it down to 5 miles. And that will only actually print out Beaker and Bunsen. Full disclosure, these are not actually where the Muppets live. I just assumed that they don't actually live anywhere. I would just assume that they were all in Hollywood because I think that's where they shoot the show. And I used Nobu's Hollywood, and I just dropped random pins around Hollywood for my example here. So yeah, that is essentially geofiltering using Redis search and Redis Home. It's a fairly intuitive way to search for things and use things in Redis, but there's actually more that we need to talk about still. the next thing I'm going to talk about are aggregations. So aggregations are essentially operations that you could run on all of your data that's stored in Redis. So, and I came up with this clever little, what I think is at least clever, little syntactical way of interacting with aggregations in Redis. So let's start off by creating our aggregation set. So similar to how we got the Redis collection for the Muppets from this provider, right up. Right up here. I can also get my aggregation set. Provider.aggregation set for my Muppets the same way. And now this aggregation set essentially has allows you to, using a similar syntax to a Redis collection, using essentially LINQ, it allows you to build the functions that you want to run against your data in Redis. But the first thing we need to do before we do any of that is we actually need to go into our, our Muppet class, and we need to set all of these to aggregatable. So I'll just go and I'll just set everything in here to aggregatable. And what that's going to do is it's actually going to allow Redis to sort of load things ahead of time for you and use them. It takes up a little bit more space on Redis, but now you can use them without actually explicitly loading them in Redis in aggregation pipelines. So with those now set, remember, I'm just recreating this this index every time. I can now go off and I can actually perform aggregations. So this aggregation set lets me do things like apply. And the parameter that I'm passing into this aggregation that I'm running. So this apply function is something I'm going to apply to all of the records that come back in the query, whatever that happens to be. You can also do where expressions on this too. But this aggregation result that it's using has two attributes in it. The first attribute it has is a record shell. So if I want to take the age of a Muppet, I would access it through the record shell. So I would go x.recordshell.age. And if I just want to update everyone's age by 1 year, I can just say x.recordshell.age plus 1, and then I would just pass in an alias that I want to give it. So age incremented by 1. And this is now iterable. As a matter of fact, something I forgot to mention is all of these are actually async iterable. So I could just add awaits around all of them, and they're all now async. I was just doing everything synchronously before because that was for the sake of time. But with this result now, I can now use the second attribute in here, which is the aggregations that have been performed in it. So this record shell, when it enumerates, will not have anything in it. It's always going to be null. So you never access the record shell after you actually go through your apply functions. But the results in there I can just use. So console.writeLine new age is result dot sub. I can just pass in the new age, set the age incremented by 1, which is what we just created in our aggregation. I can run this now. You can see that now it's calculated the new ages for all the Muppets. If I wanted to go a little further and actually say something like, and create like a formatted string or something from these. I could say for each var variable in aggregation set dot apply, and I could do string dot format, and I could say 0, 1, 2, and into here I can pass x dot it's not very well not rendering very well because of the zoom. Sorry. X dot record shell dot first name, X dot record shell dot last name, X dot record shell dot age. I could say is 2 years old, and I can pass in after that. I need to go right here and say formatted age string. And here I can do a console write line, and I could say here I would just say result sub age string, and that would actually allow me to print out this formatted string that Redis actually generated based off of the data that was in Redis. And then the last one before I go, because I think I only have 3 minutes left, is to like up here when we were doing geofilters, we can actually also calculate the exact distance from a particular place. And so my example up here will be to take an aggregation set dot apply, and I can actually use a bunch of apply functions that are built into Redis Home and do apply function dot geodistance, and I can take x.recordshell.home location and Nobus and just say call this the distance from Nobus, and then down here I just say distance from Nobus is I have to rename this so it's not this variable. Result sub. And that will print out the distance from Nobus in meters, importantly, for each of the Muppets. Yeah, so that's Redis search and Redis own. And before I go, because I only have 2 minutes left, just a little bit more about me. Again, I'm Steve Lorello. I am a developer advocate at Redis. You can follow me on Twitter or GitHub, or you can find me on LinkedIn. Some resources for this talk. A lot more about Redis is available at redis.io. A lot more about Redis search is available at redissearch.io. The Redis search Docker image is hub.docker, Redis lab / Redis search. The actual Docker image that I use is Redis lab / Redis mod. And the reason I use that is because it has all of the modules in it, and sort of it's just easier for me to think about that way. The project for redisome.net is still in preview, so we still would appreciate a lot of feedback from the community. But it's available on GitHub under Redis / redisome.net. And if you want to learn more about Redis, you can either we have free online classes at Redis University, or you could hit us up in our Discord channel, our Discord server, and come talk to us if you have any questions about Redis. So yeah, that's it. And I guess now I have about 5 minutes for questions. I think I hit the nail right on the head.
Well, that was perfect timing. Great session as well. I think I learned a lot on Redis team. It was great.
Good.
Yeah.
See the idea.
One thing I was wondering is, do you have any benchmark performance information about using Redis for this type of information?
Yeah, so like we actually had a blog post that went out when we released the newest version of Redis JSON, which included Redis search in it. That basically compared it to other document style databases.
Okay, great. Yeah, that's always, it's always a great thing to have that kind of info because it's a great thing. But okay, well, tell me about
how does it work? How good does it do? And in general, like the trick with Redis is that like we use complicated data structures with very strict time limits, which and very strict. We're very strict about like the timing of things. So like it just the way that the whole platform is built out just lends itself to speed when you're going over and just trying to index things. So it's actually a really neat technology.
Yeah, great. That was a great session.
Great. That's awesome. Yeah, and I think so. We tried to implement Redis on C# Corner. It just took, I don't know, it didn't work out for us.
Well, you should find us in Discord if you have any questions.
We just gave up on that. But it's not because of Redis, because we didn't have enough expertise on that.
Well, like a great free resource that we have is our Discord channel, and all questions about Redis are welcome in there. So like if you have any question about Redis, you're welcome to come in, stop by and ask it.
That's great. I mean, Discord is great, but I mean, a lot of enterprise developers really, they're not even on Discord.
Yeah, that's true.
It's hard for me to tell like a company, Comcast or big companies like, hey guys, go to Discord.
That is totally fair.
And that's where I ask your question. And manager will say, what are you guys doing chatting in your apps? So I'm not sure about that.
That's actually a very fair point. But yeah, like we're out there. We're all over Stack Overflow. If you ask questions on Stack Overflow, we monitor that pretty well.
That's probably the best. Yeah.
Well,
very cool. Yeah, go ahead, David.
Well, Mahesh, now you have his information, and his email, so now you can just email him.
And I just tweeted him out, so I have his Twitter now, so there's no way he can hide from me now.
As a matter of fact, you have my personal email too. So
there you go.
Just gonna get
that's it. So now that's it. We're gonna follow you and pick you on their brain when we need you.
Sounds good.
Awesome. Thank you, Steve. Thank you so much for sharing your expertise with us. Anytime you have anything else you want to share, your new releases or anything, C# Corner is a community where we're always welcoming person like yourself. Come and share your knowledge about what new product launches are. Simon is there 24/7, so we host AMAs, we host Coffee with Pros. So anytime you feel like you have new release or something you want to share with C# Corner community, just ping us.
Sounds good. We'll do.
All right. Thank you.
Thank you.
Thanks.
All right, David. That was great.
Yeah. I've been looking forward to the next session just because of the title.
Let me go change my clothes. I think we were supposed to be naked to watch that, right?
Coding naked.
Yeah. Should I take my clothes off?
No.
Oh, okay. All right.
Well, when it's summertime, I code in my underwear. Is that okay?
Yeah, I guess. So a lot of people are looking forward to this next session. It's a coding naked. This will be awesome. So next speaker is Caleb Jenkins. Did I say it right? All right, let's bring him in.
Hey guys, that's fantastic. Please leave your clothes on.
Caleb, welcome to the conference. I think your volume is a little low.
Let me see if I can adjust that. Here, is that better? Let me know if that gets too loud.
That's good.
No, that's good.
Is that good right there?
Mm-hmm.
Yep.
Perfect.
Yeah. David, you want to start? Any comments?
Yeah, this I've been looking forward to this not only because of the title, because just because of testing and unit testing is a not used well enough that I see, and also that it's not written very well, right?
Right, exactly.
Or in the case of the project I'm on right now, I can't even run most of the unit tests on my dev box, right?
Right.
So the only way all the unit tests run is when I commit the code and it kicks off a build, and that is not the way to do it.
Right, exactly. Yeah, it's really interesting. I'll say what drove me to create this talk. And by the way, the code is, you don't want the code to be naked. Not the developers, the code, right, is what we're talking about here. But it really, what drove this is so many of the test driven and TDD talks that I'd been to and looked at were they didn't match what I was facing day to day.
Yeah.
Right. We didn't dig into sort of those challenges. When you first start looking at TDD, everything makes sense. And then you go write code and you're like, well, I can't test that. How do I test that? And so it really comes down to some fundamental good coding practices, following solid principles. But looking forward to jumping in. By the way, guys, been really enjoying the conference, following it yesterday and today. And I think Mahesh, Dave, Simon, you guys have all been just doing an awesome job pulling this together. Good stuff.
Thank you. And
thank you. It's all really Simon and these guys doing work. We're just chatting and drinking.
Mahesh is just the figurehead. Mahesh is just like the president. He doesn't do much except for to show up once in a while, right?
That's great.
But where do you live in Texas?
I'm in the Dallas area, so just North Fort Worth, technically. Yeah.
Cool. My daughter and my grandkids live in Dallas, and my son and his wife live in Austin. So
nice. It's a good area. Yeah. It's funny. I grew up in California, but I've lived here for almost the last 17 years. And when I tell people I grew up in California, I explain, my dad was born in Dallas, so we have roots here.
Yeah. Well, great. I'm looking forward to this.
All right, Caleb, on to you. Stage is yours. Looking forward to it.
All right. Well, everyone, thank you so much for hopping in, and I hope you're really enjoying this conference. I'm excited to get this as a topic I'm really passionate about. So we're talking about unit testing, a lot of those hard to reach places, and so let's jump in. I'll tell you a little bit about myself. That picture is outdated. It really is. My name is Caleb. I obviously have a beard now. There we go. That's better. And have a family. That picture is also outdated, but I still love that picture because it just shows the energy and excitement that I'm around every day. If you're following along, I really hope, feel free to use the hashtag, what is it, .NETConf 2022. You can at me at Twitter, connect on LinkedIn. I'd love to connect with you. I'll say just a little bit about my background. Been building software for a long time. Worked with a lot of companies. Right now I am working in the fintech space. Our team is exciting. We're doing some really neat stuff, and we are hiring. So I'd love to connect with you and hear more about the kinds of challenges that you're running into and the things that you're doing. All right, we're going to keep moving. Some of the talks that I've given over the years that are a lot of fun, just so you can see the topics I'm passionate about, the things I really like focusing on, good culture, really coding practices, getting down to good engineering. Okay, in this talk, we're really going to split it into two areas, and this is the thing to think about. So whether you are new to unit testing and test-driven development, or you've been doing this for a long time, I'm hoping there's something here for you. The first half, we're really going to drill into just some fundamentals. And so if you're new, or if you've given up, let's say on TDD in the past, and you just want to build some fundamental elements, there's some foundational components that I think will really help you to make test-driven development worth it and useful. And then we'll dig into some real strategies on some of those roadblocks that you might run into and the things that can make it hard and not obvious. And so let's get in there. All right. The kind of the drive for this talk came from, is test-driven development really only for coding elites, or is it something for every developer? Is it something that we should all be doing? But how do we make it the norm? How do we make it so it's not this out of place thing? but really make coding without tests as uncomfortable as coding naked. That's really the drive behind this talk. And just for clarity's sake, that is not me. Please leave your clothes on, and we'll all do great. All right, so the 4 big areas of unit tests, I don't know if you've ever thought about this. There really are 4 big areas. There's the code that you're building or you're about to build, the tests that you're writing, the test framework, and the test runner. And so the application that you want to test, the code that tests your application that you've written or that you're about to write, right? You can write your test first, and that's great. The framework that you decide to use, there are a lot of frameworks out there. We'll touch on some of those. And the runner, the reason that is a separate thing, because there are different places where you end up being able to run your tests. And so keeping those separate is valuable. And you can visualize it this way. You know you have some application that you're building, and you're really poking that application to make sure that it's doing what it's supposed to do. At the end of the day, that is what your tests and your test coverage are doing, is just trying to find those edge cases, trying to poke, make sure that the reason you have your application, that it's working, that it's working as intended. All right, so let's talk about getting started. There's really 3 things I find help people to think about getting started. The first part is just start. If you're not doing automating unit tests, get start. And you say, well, Caleb, where do I start? Well, start by picking a framework, get a runner, and start writing some test code. So let's take a look at that. So this is an example. Let's see, this is NUnit, right? You can tell because the attributes are test. If it was MS test, they'd say test method. If this was XUnit, I would see a fact there above the test. And so those attributes really help the runtime know these are automated tests. They're public, they are void, they have an assert inside them. They assert either ultimately to something either true or false. So, and then of course there's a lot of asserts, and depending on the framework, there can be a lot of asserts. Why are asserts important? Well, they really help the readability of the test. They read when you're looking at, did this test do what it was supposed to do? What are we actually evaluating? The evaluation comes in the asserts. I'll tell you, I actually like using assert libraries that are not included necessarily with the test frameworks. Should is a great one. I've been using fluent assertions a lot lately. I just like the readability. And the other thing I like is when I've done consulting in the past where I've moved maybe from one client to another client to another client, and they might be using different test frameworks. So one might be using NUnit, another one might be using XUnit, another one might be using MS Test. At the end of the day, if I'm using the same fluent assertion or assertion library, my tests tend to read the same regardless of the test framework, and I'm not having to learn a new assertion library depending on where I'm doing. Also, by the way, just the fluent these will all actually work with even if you're using something like SpecFlow or any of the BDD frameworks. So, and then you think about, I have a test runner. This is an old school, the original NUnit test runner. Now I have adapters and everything's baked into Visual Studio. It's an old picture of Visual Studio. It's been there for a while. If you're using something like CodeSharp or ReSharper, I will say one of the things I like about using CodeRush is that I have a consistent workflow. Again, if it's NUnit or if it's MS Test or whatever it is that happens to be the test framework, I hit T space and I have the right test template out for me, and I have the same kind of workflow regardless of the testing framework. So those can be helpful. But also, what about environments? Dave mentioned this a second ago, where I'm not running my tests locally, where I want to, I'm running them on another server. Why is that valuable? Well, so that I know I get away from it works on my machine, right? I know that, hey, this build actually works and it doesn't have to be on my machine. It can work anywhere. And so that's where we get into things like whether it's Git, we'll now do this in GitHub. This happens to be a screenshot from TeamCity, but I think you get the idea that there are a number of different continuous integration environments where you can run your tests and make sure that unit tests really are the staple to reducing your technical debt. It's really the number one way to know that your application is working as it's designed. So here's some just, again, we'll stick with the fundamentals for a second. The 3 A's of a unit test: you arrange, you act, and then you assert. And so arrange is where you're simply saying, what is the context for this test? What is the scenario that this test happens in? What kind of setup do I need to do? Do some sort of action, and then you assert against the results of that action. That's the fundamental flow of a test. And so I like to think of it like if I'm building an application like building blocks with Legos. The challenge here is, okay, I have this block that's sort of down in the stack, but I want to test it and make sure that it's strong, it's solid, it's working well. I want to keep my test small, fast, focus on really one thing. Think of your application. I really want to build pieces that work well together as opposed to one giant Lego piece, right? Of course, the difference between, we have all the same components: UI, rules, services, data, workflow, UI, rules, services, data, workflow. Of course, this in a giant monolith, how do I know one part's working versus another part? I sort of have to run the whole thing at once. I don't get to isolate those components and make sure that they're all working independently. It also makes it hard if I want to replace part of my application or upgrade it. And so we really want to keep thinking in terms of modular code and independent pieces that work well together. I'm not going to spend too much time talking about red, green refactor, but I will say it is important when you're writing tests that those tests can fail. If you're writing tests, I encourage you, if the code is always written and then you're coming along later and write the test, change something in the code and make sure the test will fail. I have certainly inherited tests and picked up tests from other people that were so complicated, and again, if your tests are complicated, it means your code's probably overly complicated, that the test would never fail. And so seeing a test fail, getting it to pass, making sure that it's passing, so then you can go into refactor. And refactor is really important so that you can make your code more readable, more approachable, more maintainable, but you know it's still working as designed. So this is a really good rhythm and workflow to get into. All right. So here we are, we're back at this Lego piece, we're trying to test it, and fundamentally, we're essentially faking some input so that we can get a response and validate that this piece of this Lego block, this piece is working as intended. That's really the goal. So again, I've mentioned NUnit, I've mentioned VS Test, XUnit. There's a number, you may not even be doing .NET, right? So you may be in a number of other areas, and you can Google that, right? Depending on your library of choice, whether it's Python or TypeScript or Java, right? Wherever you're at. All right, so let's keep going. So you get started, you've got some test code going, but then you run into these scenarios, right? This picture makes no sense, right? You don't want your test to not make sense. So if you have a test where it says test 1, test 2, test 3, that's not helpful, right? So as you're writing tests, make sure you set the scene. Make sure you spend some time thinking about what is the context for this application, right? We do user stories where we say, as some role, I will do some functions so that I get some value. Well, what if we shifted this a little bit and we said something like, well, given this class that I want to test, and when some scenario happens, then this should happen. And so this is really the foundation of behavioral driven development, where we're not just writing tests, but we're really testing the behavior of our code and does it work in the right scenarios. And so there are a number of BDD frameworks that are available and are out there. I will say I tend to follow a BDD style even if I'm writing unit tests. And so often I'll end up my namespace and the class and in the setup, I will have some sort of when statement so that I'm really writing a test for a specific scenario. And so when I run those, I really like the readability of that. So if the user's looking up an account, when the account needs to calculate mileage, it should add up the mileage, it should initialize the parts, it should maintain odor info, and I'm really describing the behavior. And I don't have to use a specialized BDD framework in order to make my unit test descriptive so that I understand what I'm testing, why I'm testing it, the expected behavior. So I really recommend, take a look though at some of the SpecFlow is a great tool. I'm not going to dig into it right now. It's really you could think of it as Cucumber in .NET, and it's a great tool if you want that ubiquitous language between your technology people and your business people, so that you're speaking the same language, and that when they're reading through, they can read through your tests and they understand that your tests are doing what they're supposed to, and that they're in fact testing the code, and they understand what's happening there. So not going to spend too much time into SpecFlow, but just I wanted to call it out specifically. I'm using it. I've been using it a lot the last couple of years. So, all right. So we started with getting started. We talked about setting the scene. Now, it's important to handle your dependencies, right? What does that mean? I will say this. This is a great quote I got from a book, so you know it's important because it's from a book. The single greatest thing that you can do to make your code more testable and healthy is to start taking a dependency injection approach to writing software. I don't know, does anybody know what book that came from? It's okay, so it's a book I got to write. That's from the chapter I wrote. But so it's still valid. It's important because it's in a book, so it makes it more valuable than if I had just said it. But it really is true. It really is true that if you take a dependency injection approach to the way you write software, then it will make it easier to test those hard to reach places. And so take the case, we'll come back to this domain validation that I want to test, but it's calling a service proxy, and that's calling data logic, and that's calling some data access, and it's got all these under the hood things calling. And I just want to test as this domain validation works. I don't want to have to set up some database and run my tests in some environment where I've got all these dependencies that have to be live. Those aren't unit tests, by the way. Those are very much either end-to-end or function or integration tests, but they're not unit tests, and so they tend to be more fragile, harder to run. I can't run them frequently. I end up with a lot of setup needed. So what do I do here? Well, we already talked about faking the input. So now I'm not only faking the input, I actually fake the dependencies. And so I tell it, because I'm not testing service proxy in this case, I'm not testing the database. That'll be separate. I'm going to have other tests that test the database. I'm testing, in this case, this domain validation. And so by faking out the service proxy, I can say, look, service proxy, here's the scenario. I want you to throw an exception. I want to make sure that I'm handling those exceptions properly. Or I want you to always return this if I pass you this. Or in this scenario, I want you to return this, because I'm testing that my domain validation is doing the right thing in this context. And so again, this is where I want to leverage dependency injection in my software. I'm also going to probably end up using a mocking framework. So I have a couple of slides if you want to go to my blog, /DI for dependency injection. And I'd love to take some of your questions later if we want to dig into DI. I will say this, here's another quote from a book. A mocking framework allows you to create fake classes on the fly. By the way, you don't have to use a mocking framework. You could, if you are injecting interfaces, if your dependency is on interfaces, you could create a fake class. And for the purposes of your test, pass in a fake class that implements the same interface. So you have a class that implements the same interface that's not in production, but when you call that method, it always throws an error. And that's perfectly fine. The problem that I generally have with that is when I'm reading through a test, I now have to go look at those fake classes and see what they're doing under the hood in order to understand why the test is doing what it's doing. The thing I like about mocking frameworks is that the behavior of the mock is in line with the test. And so I can look at the test and I can read exactly what I'm telling the mock to do, so I understand the context for the test. So, oh, hey, that's a great quote from the same book. That's humor. All right, we're going to keep going. I will say there's a lot of good mocking frameworks out there. In this particular talk, I'm going to be referencing RhinoMock in the slides, but if you download the source code, the sample code, you're going to see mock used. So RhinoMock's in the slides, and in the demo code is mock. So just FYI. All right, let's take a look at, again, this is just the fundamentals of unit testing, right? So, okay, so take a step back and take a look at this code for a second. What is it we're doing here? So first of all, we have this Acme account service, and it's the system under test. It's what we're ultimately going to be testing. And you can see I have this method called getAccount, and I'm going to pass in some ID, and that's the method that I'm testing in this unit test. So how are we doing that? So in this case, I'm using RhinoMock. I could have used MockQ just as easily, and I'm setting up a mock instance of the data layer. Okay, I'm setting some expectations so that I'm giving it some behavior. So I'm saying, hey, when someone calls get all accounts, you return this sample account. That's the expectation. That's the behavior that I need from this data layer inside of the account services. And then I'm injecting that data layer into the system that I'm testing using dependency injection. I'm doing this as my action, right? So everything before here was my setup, and now is my action. And then I'm verifying, which is essentially my asserts. So it's the exact same flow, that AAA flow of unit tests, but by leveraging dependency injection and mocking framework, I'm able to bring it all together to test that this method is doing what it's supposed to do internally, and that I can run it, and I don't have to have a database set up. I don't have to have all of those other dependencies running in order to validate this piece of code. All right. So just a quick review of the first half, the first section, right? What we've covered. You want to get started, figure out your framework, get a good runner. You can use what's baked into Visual Studio. It's great. I love in .NET Core, you can just type .NET Test, by the way, from the console. And as long as you're at the solution level, it'll run your test that it will discover inside of your solution. And set the scene. Make sure you're putting some context around your tests so that they're not, again, test 1, test 2, test 3. That's horrible. I have no idea what's happening here. Let's put some context around our tests, and make sure you're handling your dependency. I'll just tell you, if you'll start with these 3 starting points, you're going to get a better start. You're going to be able to feel more comfortable writing unit tests and feel like your unit tests are doing more. All right, let's talk about some of these problems, some of these problem childs, some of these areas. There's a real challenge with edges of your application. So let's see, here's a common architecture. Take a look. So can anybody tell me the 3 areas of your application here? You've probably built applications like this. You have your UI, your business layer, and your data layer. And I'll just tell you right now, the edges, they're hard, right? A data layer is hard to test because you're typically tied to a database. The UI is hard to test because you're tied to a user who's entering things and clicking on a mouse and simulating browsers. And so those become challenging to test. So what can we do? Well, first of all, I'll just tell you, testing edges is like testing to see if you're good at cliff jumping, right? How do you know if you're good at cliff jumping, right? That looks scary to me. I don't want to do that. That is not me, definitely not. And so with cliff jumping, right, you're either like it works and everyone cheers and you're an expert, or you're just stuck on a rock. There's really no place in the middle. And testing the edges is kind of like, hey, your application works great, but you weren't sure it was going to work, right? You just had to get it out there. It was hard to test. So what can we do? So one thing is you want to take and separate out your data logic from that edge data layer. You want to separate out your UI logic from that edge actual UI. And so there are some patterns that will help us do that. I'll say the edges are still going to be hard. The edges, data tests still take a long time to run. The UI can be brittle because you want to be agile and you're frequently changing. But by shifting the UI logic and the data logic, what we're doing is we are increasing our testable area. So we're also, by the way, making it a little bit easier to make our core application. If we need to change some of the database implementations, a little bit easier. We're isolating our data logic from let's say our CRUD and maybe a repository. It might be our actual where we're actually talk, but we're keeping our iRepository super thin. All your iRepositories is doing your CRUD statements so that your actual data logic is rolled up into your data layer. Same with the UI. Your actual UI might be flexible and might change, but the logic is something that you can write a lot of tests around now. And so some of the patterns you might be familiar with, MVC pattern is very much around separating that logic into testable controllers, and those controllers are separate from the actual Razor pages or from the MVC pages, templates that you're binding to. You might be familiar with a repository pattern, and so these are patterns, but they're really based on a principle. And the principle I'll coin, because I've not really heard it, is, well, I'll just start by saying edges are all around us. It's not just the UI and the data layer. What are some of the edges that you can think of in an application? I will tell you, if you can identify those edges and apply some principles to them, it will make your applications more testable. And so some of the other edges, your network calls, right? You're calling some web service and you find that your you're having to do things like format and do retry logic and all of that. And in order to test your retry logic, you have to make a call to a web service, and you have to have this live web service out there. You're testing some kind of disk that you have to read, some file that is normally there. It's supposed to be there, but now in order for your test to run, this file has to be there, right? That's a really brittle file. And it takes a lot of overhead to move it around and make sure things are in the right place, or you're reaching out to some cloud storage. And now in order for your test to run, the cloud storage has to be configured and set up, or you're dependent on some message to, or even something is like date time. Date time doesn't sound like an edge until it is, right? It's not in your application. It's something that is set in your environment. It's really an environment setting, something you get from the system that you're running on. And so if you have, let's say, business logic that's tied to dates or certain days or close of business, you have to think about that tests that are only supposed to run on certain days are only supposed to pass or fail on alternating days. How are you going to test those when you're doing date time? So these are some challenges. These are the kinds of things that are really all around us. And so the principle that I'll hold is you want to keep your edges thin. And so we'll take the example of a network. What you can do is create sort of like an iNetwork proxy, right? Just create an interface, and the only thing the class is doing is making a call to an endpoint and getting the results, right? You separate out your retry logic, your serialization and deserialization. The only thing you might have in that network proxy might be actual authentication with let's say if you're going through some kind of network access and you need to have some kind of context that call actually runs under to make sure it's able to go through the firewall and that sort of thing. But really outside of that, you want to keep that network proxy super thin so that you're able to test everything that's behind it. And then you end up injecting that into the caller itself. And so, think about that. Think about those terms. How do we keep these things, these edges thin? So I like to think that principles are actually greater than patterns, right? We have some good patterns, MVC, iRepository, but really patterns help you implement principles, but it's the principles that help you create new patterns and also see code smells that there might not be a pattern for, okay? And so the principle, and I'll be actually blogging about this fairly soon, is the thin edges principle. And keep your edges thin, that's it. What is this principle? Keep your edges thin. So, all right. Let's take a look at some code. By the way, the source code for all of this is out on GitHub. You can go to my GitHub, Caleb Jenkins, Acme Coding Naked is the source code. This is my warning. Everything in this code base these are sample code for just looking at unit testing scenarios. None of this is for production software, right? So don't call me, works on my machine. That's my standard, right? So, all right. So let's talk about some strategies as we're digging through this, and I'm trying to keep an eye on the time and make sure we have time for questions. So we'll keep going. So keep your code simple. I'm going to talk about simple in a second. Keep your edges thin. We've talked about that. Use DI to inject complexity. So break down your application so that you don't have a lot of complexity. It's only complex in the whole. Here's something that's not in my slides, and I'll just say this. There's generally two types of code people end up writing. It's either code that decides what to do or code that does the thing that you're going to do. And the more you can keep those two things separate, the simpler your code is going to be, and the easier it is to maintain, the easier it is to test. The more you're intermixing those things, well, if this scenario will now go do all of this, and that's all intermixed, the more complex your code goes. So it's the deciding what to do and the doing, and the more you can separate those, the better. In addition to keeping your edges thin. So if you have a critical area that you really need to test, but it's let's say it's a bunch of private methods inside of a class, extract those methods out to an interface so that you can really test it in isolation, and then inject that criticality into the class. It may be fairly small. It may not seem like it's doing a lot, but by taking the approach where you're breaking your application down into smaller pieces, really helps you to keep it simple, helps you to, here's something so we haven't talked about yet. If your application is doing a bunch of stuff internally and it's hard for you to see externally what it's doing, you can create accessors to be able to see that. So I'll dig into that in just a second. But simple, I define simple as this: keep your classes small. Methods should really be input and output. So made to test is okay. Don't worry about, oh, I'm violating my OO principles, or I'm building things into my application just to make it more testable. That's perfectly reasonable. And pure, so simple, right? So small, in and out, made to test, pure. Pure as in functionally pure. The more functionally pure your tests are, your methods are, the easier they are to test. So non-mutable, you have input, you have output, and there's no side effects. And really the more that your code tends to be that way, the easier it is to test, and just keeps things simple. All right, so here's a challenge. Here's a challenge that we run into. I'm building this class, and I have some kind of counter in it, and every third time we trigger the counter, we're going to log it. Why? I don't know. This is arbitrary just for some business case. And so the business case is log every third time. So how do I test that? Because I can test that I'm actually seeing logs, because I could mock the logger and inject the logger, and I could assert that yes, it's getting, but how do I know what the counter is at? I don't really have visibility to that. It's very much an internal state to this class. So one way is just go ahead and make that visible, right? Safely. So safely, I just mean, create a public accessor so that you can get the counter value. And that could be a read-only property. It could be a method, however you want to do that, but make that value something that you can see from the outside so that you can test it. I will also say your class, if it's implementing an interface, and it should, you don't have to include those things like the counter value in the interface. You can include it just in your class for the purposes of testing, and that's fine. So another scenario might be I have a start and a stop for some method, some business process that's running, and I want to make sure that under the right scenarios it is running. So I could add an is running to my class just so that I know that it's doing what it's supposed to do. And that's a perfectly reasonable way. I really like this quote from Roy's book. Some people feel that opening up the design to make it more testable is a bad thing because it hurts the object-oriented principles the design is based on. I can wholeheartedly say to those people, don't be silly. So there you go, from the Art of Unit Testing directly. It is okay to add things to your classes just for the purposes of testing. That is a reasonable approach. All right, let's talk about, so we talked about the problem with edges, and we talked about keeping edges thin. Let's talk about some of the problems with statics, right? So statics are hard to mock, so because there's no interface on a static class or static methods. Hard to isolate, you end up with shared state. If your static methods are not maintaining state, I'm a little bit better about that, but honestly, if they're doing any kind of state at all in static classes, that's a challenge. I always think of this picture when I think of shared state. So, right, it's everything seems fine until everybody falls down. And I've been through that so many times. That also applies to statics and hard-coded singletons, globally scoped variables. Anything where you're sharing state is generally a recipe for a bit of disaster. So hard to test in parallel. I can't run a parallel test as easily if I have this shared state across my test, because one scenario ends up conflicting with another scenario. And by the way, and I think we know this, extension methods are static. So what do we do with that? So let's start with one strategy. So if singleton, static, hard-coded, they're hard to test, a strategy is don't use hard-coded singletons, right? So, or any kind of static state. If you need something to be a singleton, leverage your dependency injection, right? When we talk about software patterns, one of the first patterns people tend to learn is the singleton pattern, and then they tend to want to use it. Don't. You should know what a singleton is, but if you need something to be singleton, don't build it as a singleton. Leverage your dependency injection in order to have it run as a singleton in your application, rather than hard coding it on the front end. So that way you can still run multiple tests, multiple scenarios. You're not locked into the singleton pattern just because that's the behavior you need in a running application. So what about this challenge? So you have some kind of code that you're running. You go and you notice that, hey, logger.info is what's getting called. So that's actually you want to mock out that that logger.info got called, and you go to mock it out and you realize logger.info doesn't exist. Where is it? All I have is this log method with a log type and a message. Where is logger.info? Turns out it's on a completely different set of extension methods where I end up with like debug and info and error. And by the way, this is exactly what you run into with the Microsoft logging abstraction. And so you start running into this and you think, okay, so now how do I mock this? I have this interface. I'm using mock. I'm doing dependency injection. What do I do? So this is what I think of. It's anytime I'm writing a class and I want to test this class and it has some kind of dependency, so I'm injecting that dependency in, and there's a method on that interface and I want to call it, but then it turns out, wait, that's not I'm trying to call that method, but that's really an extension method, and then that thing is sort of winding around and calling something else. And sometimes that something else isn't even in the main interface. What do I do? So, by the way, I'll say this is what I consider cognitive developer cognitive load, right? So you just want to test that some method is getting called and move on. If it was on the interface, it'd be really easy to mock test and move on. But now you're having to dig in and see and understand. It creates cognitive overload. I will say, depending on the strategy you use, it also creates a leaky abstraction. So one approach is you have these extensions. You may or may not be using all of them. I was at a company once and we had logging extensions. There was probably 100 different methods on there because it was every scenario the company had run into, and this was a shared library. And so we had all these extension methods. In our application, we probably used five methods total out of like almost 100. And so one solution is just create your own interface. It's really your app logger, and write a class that makes calls to those extension methods, right? So that's pretty easy. So if you have an app logger and that's the thing you're actually using in your application, and all it's doing is making calls into let's say the enterprise logger that everyone else is using, you can test that that's working in isolation. But now anytime in your application code where you're using your app logger, it's really easy to test because it's just a normal interface. It's easy to test, it's easy to mock, and you can move forward. So that is definitely a great approach. That's my preferred approach. If I'm able to, if I have the time, it's fast, it's simple, I move on. I just wrap it in an interface, and then I'm just using that interface in my application, right? So what about this scenario though? Let's say I have this extension method's hiding behavior again, the same thing as before. I'm calling some method called do the thing or whatever, and then I get in here and I realize the extension method is doing a lot. It's not just forwarding to a method, it's doing a bunch of other things. I can mock around it, right? So mock around it is if I understand what the extension method is doing, and if I understand that the extension method is really calling these three methods, now I can go mock because the real thing is actually going to have those methods called on it, and I can do that. That's mocking around it. But again, I'm peeking under the hood of a class to its implementation, so that's a leaky abstraction, and I'm having to go do this digging, right? So mocking around is certainly a reasonable approach, but it like anything, you've got a leaky. There are risks involved, right? But that becomes something that's available to you, something you can think about. I just added a new extension method to my sample code this week, and so if you want to pull that down, I linked to the original blog post. But it's really around Microsoft's logging abstractions. That if you dig through their source code, it's nice that the source code's available, but the extension methods that they publish internally end up calling an internal class. And so when you're trying to log that, it becomes challenging because it's an internal class that you can't mock, right? You can't mock that. So, but fortunately, MockQ added some new methods and makes that easier, and that's available in the sample code. Okay, this is a little bit more next. Now we're moving up a little bit. This is kind of the last strategy we're going to dig into. But we don't think of extension methods as being injectable. They don't really lend to DI approaches. But you can if you take the time to do that. And so let's say I had an extension method. I could create an interface for it. I could create a class that injects that interface, right? But then in my static class, I have a public property that's static called implementation. And then so internally in the static class, I'm just leveraging the traditional class that implements the same interface. And what that allows me to do in my test, it allows me to mock out the implementation, set the implementation in the class, run my test. Again, I'm limited on being parallel this way because the changes that I'm making end up being shared if I'm running multiple test scenarios at the same time. It's the standard problem with statics, but this is certainly something you can do when you're building extension methods. It takes a little bit of effort, but it just creates an injectable extension method. That is a reasonable strategy. I will say it tends to be the times I'm using dependency injection or wrapping an interface, I end up with more stable unit tests. All right, so I can use spies or accessors to confirm internal state. I can wrap extensions in an interface. I can mock around extension methods. I could create injectable extension methods. I could use Microsoft Fakes. There are a couple other libraries out there. Pose is another one. Isolate is another one, which is a type mock product. And so there are certainly other, Isolator. And so there are certainly other tools. I will just tell you, here's my challenge with Microsoft Fakes, right? So it's generally MS Test only. You need Visual Studio Enterprise. Getting it to anytime I find I need or I want to use Microsoft Fakes, I end up, pardon me, I often don't know if my tests are failing or if the tool is failing, right? And so getting it to be configured and reliable is a challenge. The time that you should use Microsoft Fakes is if you have no other alternative, and if you're using it in order to refactor to one of the other strategies, in order to one of the other patterns. So Microsoft Fakes is really intended to be a stopgap measure, not a permanent solution, right? It's just, so here's my strategy for Microsoft Fakes. Use some of the other mocking techniques that we've talked about. You could try some of the other commercial products. Don't use fakes. That's ultimately my suggestion that I end up telling people is you can try it, but I run into headaches, right, every time. So let's just quick summarize, right? You want to find the edges, keep the edges thin, and guys, stop coding naked. Thank you so much. I really hope you had a great time. I hope you learned some things, and but seriously, don't do that. Stop it. All right. I think we've got time for questions, and so if there are questions in the chat or on the Twitter, wherever your questions are, I'll be available. And I hope you have a great conference today. Simon, are there any questions you know? Hey, guys.
Hey, doesn't look like there's any questions, but I do have a couple comments. One is I want to reiterate what you said or expand on it, is that use static and singleton very rarely.
Absolutely.
And if not at all, because, as you were talking, I was actually looking at some singleton stuff in the code base I'm working on going, why? And I even made a comment before you said what you said. I go, why is this being done here?
Yep.
It doesn't make sense, right? And I think people don't really know what they're doing. I mean, understand what they're doing. And especially with static, I don't think most developers really understand that if you have a static field variable, that class never goes away.
Yeah.
Right.
Yeah. I worked on an application once where the engineer, this was it goes back 20 years probably, but it was, so it was .NET 1, ASP.NET. And everything worked great. It was this navigation system. And as soon as we put 2 or 3 or 10 people testing at the same time, someone would click on a link and end up on a different page, not the link that they clicked on. And the variable that was holding the what page should I click on, it was static. And so it was like last person won, and it was something that you didn't find until you had a lot of people at once, and it was this bizarre behavior. I also worked when I was consulting with a company that had a upper cap on how many clients they could serve at a time. This wasn't a web client; it was these were physical devices that connect wirelessly to a server, and they realized they could double their capacity or triple it if they opened up multiple ports. But they couldn't because the core service that was connected to that port was hard coded as a singleton, and so it just wasn't available. They didn't have, and it took a massive refactoring in order to restructure that code in order to do some things that should have been trivial.
Yeah.
Yep.
Well, that reminds me of a story of there's a insurance company here in San Diego that have called the company I was working for, going, we've been trying to fix this thing for a month. We don't know where it is or what's happening, and can you send somebody down? And they said, okay, we'll send .NET Dave, right? And so, I go down. So the problem was, and this is an insurance company. This is pretty sensitive data, right?
Sure.
That everything worked fine, one user, right?
That's right.
But as soon as you got the second user on, that second user could see the data from the first user. Sensitive data. And they couldn't figure it out. They couldn't figure it out for a month. I went in there 2 hours after looking at the code. I figured out it was a single field that was static.
Yep.
And the programmer that I told that to refused to believe what I was saying.
Yeah, I want to go work for a bank and put my bank account as the last updated static field.
Yeah.
So every time money transfer comes to my account.
Yeah.
Yeah, just initialize it that way. It's perfect.
Well, that was a great session. And I also want to make sure, I know Mahesh said this a little bit ago, that, we're going to, later this year, we plan to do a code quality conference. And you definitely need to submit a paper for that one.
Perfect.
So, yeah.
Yeah, that would be great. Definitely. This
and I'll
needs to
pick
be
it
done
for sure.
But here's the funny part, right? As a developer, right? And we just finished one project, it was in Blazor for a large client. And from day one, I've been telling our team, like, hey guys, we need to make sure the unit tests are done as soon as we write code. But because of the always is behind and all that, the unit tests were never done. So then what we do, developers do is then as a team is like, okay, let's put all the tests in the end. So
yeah,
that's not good.
I think it was Uncle Bob who said, the right way is the fast way. And I tend to agree with him.
Yeah,
I very much tend to agree with that sentiment and statement that if you spend all your time building code, but you don't really know if it works, and if you're making changes, those changes are scary because you don't know if you're breaking anything. And I didn't talk about this, but if you're teams should be leveraging things like SonarQube, getting some static code analysis, looking at their code coverage, and really reflecting that on every single sprint, right? I tell people, when you first turn on SonarQube, it is such a stickler about coding things that it will basically tell you you're a bad person and you should stop writing software. But it's okay. Right? Everybody's software sucks at some level. The real thing that we're looking at is trends over time, and sprint over sprint. Are we sucking less? Or are we, reducing our technical debt and getting a little bit better, or at least not sucking more? And so being able to measure those things, look at those things, is really critical.
Yeah.
And the other thing I want to mention real quick, because I'm dealing with this right now too, is don't use exclude from code coverage.
Right.
So you don't have to write unit tests. I mean, this is so prevalent in this code base. At the end of every build on the build server, it says how they're doing with code coverage. And I'm going, it's not even true, because some contractor put that all over the place so they wouldn't have to write unit tests.
Yeah, the thing I do like about exclude from code coverage is it's like the broken windows principle, right? If you say, what's the right code coverage? Some people will say, 80%, 90%.
Right.
My goal is 100%. And the reason I say 100% is because I do identify classes that, let's say it's a bunch of models, I might exclude those, or my test classes, I might exclude. I mean, there might be some things that I go ahead and exclude so that the code that's important is in fact all at 100%. And I know that. But the other thing it gives me is, and I have run into this, you get over a piece of code and you think, this is so complex, why is there no coverage on this? And someone tagged it with exclude from coverage, and you can at least look at the git blame and know who it was. Not that you're pointing fingers, but just so you can have a conversation about how you can restructure this and make it so it is testable. Because if things are complex code is hard to test, so don't write complex code. Keep it simple.
Yes, true.
All right, awesome. Caleb, that was great. We're looking forward to have you again in one of the upcoming conferences and shows. Thank you so much.
Hey, thank you all. Have a great day. I'm enjoying the whole conference.
Yeah, thank you so much.
You bet. See you guys later.
Thank you. So that was great, David. And I think next session is our, minimal API. So it's like a new feature in .NET 6. Our next speakers, Andrea and Marco, are going to talk about minimal APIs in .NET 6.
Yeah.
Let's get them in. Hello.
Hello, everybody.
Hi, how you doing?
Very well, thank you.
Very well.
Where you guys joining us from?
I'm from Italy. We are from Italy.
I'm from Verona, and Marco is from Taggia.
Taggia, yeah, my hometown. We'll see the city during the session.
How's the COVID there?
Very well. Well, it's a bit cold in this day, but it's okay.
Okay. All right. Well, all right, guys. It's Simon is kind of late there. Let's stage is all yours. We're looking forward to this new session. What minimal APIs are in .NET?
Yeah.
I'm looking forward to it.
All right.
Okay.
Thank you.
So I can start sharing my screen.
Marco, share your screen.
Share my screen. Okay, perfect. Okay. We can start. Thank you. So, hello and thank you for joining this session about how to integrate OpenTelemetry in a minimal API project, of course, with .NET 6. OpenTelemetry is a system that allows us to identify software issues, for example, by using telemetry, as the name implies. So, for example, we can use OpenTelemetry to identify bottlenecks or to understand if we need to improve the performance of our software. In this session, among the other things, we'll see also, we talk about briefly about the logging improvement that comes with .NET 6, and of course we talk about OpenTelemetry and the new OpenTelemetry metrics API that are available in .NET 6 using the new system.diagnostics.metrics namespace. So let's start. Before actually seeing how to integrate OpenTelemetry, and so how to add tracing and measurement information in our project, let's take a quick look at the simple project that we have created for the session, and that is based on minimal API. We'll see a simple architecture, some services that we use in this demo, and then we'll see how to improve the code using OpenTelemetry in the workflows of the application to identify problems, the performance, as we said before. Okay, so let's switch to Visual Studio. This is a very, very simple minimal API that nowadays probably everyone knows. So we have created for this example a photo book API, a simple API with a few endpoints that allows us to upload, to browse, and delete photos. In particular, each photo is uploaded to an Azure storage, and then is saved, a reference to the photo is saved to a SQL Server database using Entity Framework Core. Moreover, to complicate the workflow a bit, every photo that is uploaded is sent to a computer vision service to get its description. So we get also this kind of information. So the API is quite simple, as I said at the beginning, but we use many services that works together to create this system. And so let's see how they work, and then how we can improve the code using OpenTelemetry. Let's start by see the API running. Actually, I have already a Swagger running. So let's see if everything is in place. I check a simple API. Okay, everything is in place. So let's start. For example, upload the photo. I choose this one, Taggia, that we'll see better in a moment. Then I try to execute this method. The photo is uploaded on Azure Storage, and then we get the description that comes from Vision Service, and this is the ID of the photo. So if I take this ID and then I go to this endpoint, I can start with this endpoint that shows the list. In this case, I have only one photo, the photo I have just uploaded. If I use this other endpoint, passing the ID, I get the actual photo. And this is Taggia, my hometown, as I promised you some minutes ago. This is my hometown. Now we see the city in for real. Yeah, I'm very proud of the city where I live. So I try to speak and show Taggia in every session I do. In this case, it's perfect because it's fit very well in the demo that we need to do. Okay, so let's see the code. For example, starting for the post, that is the most interesting method, and see how we use some services, the services we talked about in this a moment ago, and then so we can see how to integrate, to improve each of them using OpenTelemetry. So this is the map photos method that is a post, of course. In this case, we use Minimal API. Minimal API, it's a new kind of way to create services in .NET. That is this new method is available starting from .NET 6. At this moment, I think that everyone has know about Minimal API because it's one of the biggest announcement that has been come with .NET 6. So we don't spend much more the words about how Minimal API actually works, but let's see how we use it. We use this pattern in this case because, for example, Minimal API is very interesting, but in this moment we don't have a built-in support for iForm file. So we need to handle an upload of image. In this case, we need to work using the HTTP request manually. So we need to read the files from the form, essentially. In this case, it's interesting because it's simpler to integrate OpenTelemetry, as we see with Andrea after my presentation, but it's something that we need to do manually because we don't have this kind of support, for example, to get the stream from iForm file that we normally do with standard controllers. In this case, we need to write this code, some low-level code, let's say. Then we use an Azure Storage Service and computer vision service and a data context of Entity Framework to handle all the workflows. So let's see with the breakpoint how it works to better understand how we can investigate on the performance of this method. So we try, for example, with the eagle, execute. In this case, we check the form content type, we read the file and check if it's actually an image. Then we call the first service, computer vision service. All the services are registered at the beginning of the application. In this case, we try to get to get the description with this method that takes the stream, and we use the computer vision client, that is the standard NuGet packages that allows us to get the description and other information using this service. So we can add the breakpoint here. We get the result with the description. Some information, the description is the information we need about the eagle flying. So we can go on. Then we save the image on the Azure storage using this save async. We get a blob client reference, and then we upload the stream. Very, very simple. And then, last but not least, we save all the reference of the photo with the ID and the name, the description, and so on Azure, on SQL Server, of course, on Azure, using Entity Framework Core. So this is a very simple method, but we use 3 services that works together to get this result. And also, of course, in this case, we get this information. Now now we'll see the logging part. So let's see again this method. Now it returns 2 records. In this case, we call this endpoint, this one. We use, for this example, two messages for the logger. So we inject the standard iLogger parameter in the handler. We log this message and this one using the standard logging system that we are accustomed to use in .NET since .NET Core 1.0. So we call log information, and in this case, log information using a message and a parameter. Okay, so in the output, we can see, for example, this message, request map get photos, and then a response map get number of photos 2. This is the standard way we use logger. But with .NET 6, we have the possibility to improve the performance related to logging by using source generator. So the ability of .NET 6 that we have with .NET 6 to use source generator to create at compile time the code that actually perform logging. Because in this case, we can stop the application for now. In this case, we need every time we want to log something, we need to use the appropriate method corresponding to the level, and then we need to pass the message and use set all the parameters we want, and we need to be sure that we pass the correct parameter number and so on, and the messages are correctly formatted. And this message, this instruction works by dynamically create the message, for example, concatenating this number to the message, checking internally if the logging is enabled, and so on. So this workflow works. Everyone knows this thing, but we can do better. We can get better performance using source generator. In this case, source generator of the logging part allows us to create methods that at compile time are created statically and allows us to use logging method in a type safe manner and more efficiently. Because in this case, for example, if we open this class, that is the typical way which we create in this case a logger using logging extension. We create a partial class that is the base for having every source generator work. In fact, we use this method without any implementation. For example, we have two messages that we want to log: request map get photos and this one. In this case, we define two methods. We don't need any parameter in this case. In this case, the number of photos. Then we define this method without any implementation. Then we add a custom attribute. this logger message, in this case with this information, log level information, and the actual message we want to use, and this one, the message, and then the pattern of the message and the level as usual. We don't define any implementation of this method because we have, as said before, a source generator for this code, because using this class at compile time, we obtain this one. This file is auto-generated. Visual Studio tells us the situation is auto-generated, and we get this code that allows us to invoke directly this method rather than this other, using a code that statically perform a login enable check and then contains the message that we want to use, because we have this automatically generated method that with this logger message .define with the other information contains automatically the message that we want to use. So we can use the logger in a type safe manner, because in this case we can safely add something like that. We use builder services, in this case add singleton. The logger is a typical situation in which we can use a singleton for the logger. A logger, in fact, the iLogger factory, in fact, is a singleton that allows us to get reference of this kind. So we add this program logger. Then instead of this one, we use program logger. Then instead of this method, we just need to call the method that we have defined, map request, log request map get photos, without worrying about passing the message or the parameters if there is something that we need. In this case, log response, and the only parameter we need is the parameter that we have defined in the partial method, that is photos.count. Very simple. So if we pass incorrect information or we forget something, we get a compile time error. So we have much help in writing code, because this information are available at compile time. If now we try to execute again the application, as we can expect, everything works. But in this case, we use a source generator. So this is a very, very simple example. So we don't see any particular performance improvement in using source generator for the logging rather than the original solution. But in general, in a big application where we log much line of our workflows, this approach can lead to better performance. Okay, the application is.
Sorry, Marco. If log level is not correct, so we use information and we want to log only trace. With this feature, we skip writing log because there is and if log is enabled.
Yeah, it's this auto-generated code.
Yes,
it's automatically inserted. So this check is performed at directly in the explicit code that is generated. In the other case, this code executed dynamically, and the message is processed. Then we check this parameter, and if we don't need to log the message, the message is processed but without any effect. In this case, we get
skip some code and some.
In fact, in this case, the point is this. In fact, in this case, logger message .define use this parameter, skip enable check, that in a normal context, when we use logger.log information, for example, we have this check automatically performed by the method itself. In this case, as we are using the log generator and this code, this kind of check cost as a cost. In this case, we use source generator. Source generator automatically add this code for us, and in this case, as we do this check before, we can skip in the logger message.define, getting better performance.
Yep.
So the application is up and running again. Now, if we try to execute, we get two results, and as we expect, we have the same result that we see before: program information map request map get photos, and this one. So the result, it's the same, never changes from this point of view, but in this case we use source generator, and so we can get better performance. Very simple, but very powerful and interesting. Okay. Last but not least, as you probably have already noticed, seeing this file and also this project, this Docker Compose, the application uses Docker. In this case, we have a container for the API and a container for SQL Server. Very, very simple. Andrea will tell us how to add many other containers to realize all the other features that we need to add to this base solution. Okay? So the presentation of the API ends here. Now Andrea will continue the session, showing us, as said a moment ago, how to integrate in this project OpenTelemetry and much more, as we'll see. So Andrea, it's your turn.
Yes. I'm waiting
Yeah.
that my screen is sharing.
Yeah.
Oh,
Okay.
okay.
Perfect.
Now in this second part of the session, we must explore OpenTelemetry. OpenTelemetry is a collection of tools, API, SDK, and so on. So we have an open source tool that can interact and help us to collect many information from our application and act in the correct way to fix eventually application. So OpenTelemetry is divided in three components: metric, log, and traces. Metrics aggregate summary statistics. So in metrics, we have only number that describe our application and performance. Logs is similar that Marco showed on console application, but there is a collector that catch all the log from our microservices. In this case, minimal API is one microservices, and the last component of OpenTelemetry is distributed tracing, as known as traces. So we must see all of these three parts in the OpenTelemetry declination. We start to talk about tracing. Tracing is have many span. A span is a single unit of work. Trace is an array of span, and from parent span to child span, there is data that that share from parent to child, called distributed context. This is a representation of trace. We have 5 span that describe one trace. Trace start with an endpoint called messages. Then there is 4 section that application do business intelligence or business logic or cache or database query and so on. Okay. Now, before demo, we use with OpenTelemetry one component called OpenTelemetry collector that is a particular Docker image with some logic. We can find receiver, process, and exporter that we see in the demo is a free part of OpenTelemetry collector feature. We can receive information from microservices. We process all information and then export information to the correct products. We use free product in this demo: Zipkin for tracing, Prometheus for metrics, and for logs Grafana Loki. So we start with a demo. We use same code of that Marco explained before, and add many code. So
and many containers.
And many containers. So we start from application and add this package. This package is OpenTelemetry and API. We add in this application OpenTelemetry exporter. So this application export all information that can instrument in the application to OpenTelemetry protocol, and then we can use different instrumentation. So we can collect information from ASP.NET Core. We can collect information if our application call another microservices via HTTP client, and then we can collect information from SQL Server to every query that the application can execute to database. And we use OpenTelemetry exporter, OpenTelemetry protocol logs for send information from our application, in particular iLogger, to OpenTelemetry exporter. Now start with some code. We can start to from program. In particular, we add tracing. In this case, add only tracing. We add OpenTelemetry tracing. We configure one source. In this case, source is called photobook. Every API or every minimal API must have a particular source name. So in all trace, we can identify correct name for correct microservices. We configure SQL client instrumentation. We add ASP.NET Core instrumentation with some filter. We don't trace, in this case, all about Swagger. So when we show application of Swagger, we don't send this information to OpenTelemetry. We add HTTP client and configure OpenTelemetry exporter. This is a configuration. So OpenTelemetry is, in our example, a Docker container. And then we add some code for collect this tracing. We add and use this activity source. Activity source derived from historical component. In particular, in .NET is implemented in system diagnostics. So this is implemented from ASP.NET Core, .NET and .NET full framework and .NET Core. So we can add OpenTelemetry also in application that has .NET full framework. So we use system diagnostics, only system diagnostics, not a particular API for metrics, but only system diagnostics. We define activity source, and then in our code we can add an event, set tag, and so on. So we can start with a simple get. If in this endpoint we see an array of photo, in this case one photo, and we can see information on Zipkin. Zipkin is a particular product that that can explain our trace. So if I run query, I can see this call on /photo, and we can see free span in one single trace. So we can click show and get information of this free span. We have one trace and free span. In this information, we can see endpoint call, so /photo. This is another span that collect information. This span is created from this start activity. So we can define that minimal API is called in this time, and then when application arrive at this point, we have this latency from the start of endpoint and the executing start activity. And in this case, we have also a select from database. So database select is a minimal part of all trace, and only 6 milliseconds.
And the interesting part in this case is that we have defined nothing in the code to trace also the SQL query. We just say that we want to add tracing for SQL client, and automatically the query that we have done with Entity Framework is automatically traced in this way.
Yes. Yes, because we have add SQL instrumentation package and registered in extension. So this is first of 3 component of OpenTelemetry. The second component is used in map post for collect metrics. In particular, we have computer vision service. In this case, computer vision is used in this interface. Okay, we have add also computer vision metric service. In this class, we have defined 2 metrics, 2 counter metrics, and 1 histogram metrics. This meter is a new class of .NET 6 and is a part of system diagnostics, and we have another namespace, system diagnostic metrics, that can allow us to create different component of metrics. This is a class that is registered as singleton. So this is a singleton class. So one instance of computer vision metric service in all application. In this case, we use this implementation here. So we use metrics, payload counter. We add number of length of byte array of the file, and request counter add one each time it call from minimal API. And then we add also histogram information. In particular, we add confidence. This is information from computer vision. And then we add information in key value pair class. So we have a string and a key of string and an object of another string that is a description. So we run the API and see how it works. Try it out, choose file. I upload prosciutto. Okay. I upload this image is a plate of food, and we can see this at Zipkin. We try. Okay. This is a call that has 8 span. We have endpoint that call many activity that we create to segment a piece of code. So we create an activity for read stream, one activity for computer vision. We don't create this particular activity because we add HTTP instrumentation, and when SDK of cognitive service is called, it call West Europe API cognitive service
using an HTTP client, yeah.
Using an HTTP client, and then this span is recorded in trace in all trace. Okay, and then database call. Okay, perfect. Now we can see also Prometheus information. On Prometheus we have many information. Payload counter register exactly byte array dimension of upload in the last hour. So I upload an image 1 hour ago, and then I upload another image 5 minutes ago. So these metrics calculate exactly the amount of all length of file that upload in this minimal API. The last component is very simple, but we must go to program. For enable metrics, we must add this extension, and we add OpenTelemetry metrics and configure all information. For log, also we must add OpenTelemetry, but not in builder services, but in builder.logging.
Yeah. Because in these cases, it integrates with the standard logging framework.
Exactly. So with this endpoint, with a simple logger, I log request map get photos and a number of photos, like Marco in the previous sample. We can go to Loki. Loki is another product that collect logs for application, and I use Grafana to show information. So I select my service name, I show log, and then I can select log of the last 5 minutes. So we can see information that trace the correct information. I want to search. Okay, I re-execute this endpoint. Okay. Okay. I check the latest 5 minutes. Okay. This information.
There is a lot of information because besides our logging message, there are also the standard messages that comes from the ASP.NET Core and so on.
Yes. So okay, this is body response map get number of photo 2. So response map number of photo 2. This is exactly log that we collect from iLogger. In iLogger, we collect also infrastructure information. So we add Microsoft ASP.NET Core trace and default debug and entity framework information. So we log all
everything. Yes.
Everything. Yes. So last information that we can show in this session, we must configure OpenTelemetry. So we can get to see OpenTelemetry collector configuration. This file, in this file, we can register receiver, exporter, process. Extension is an optional information, and then we can register this free previous service to the correct pipeline. So we register receivers for receive information from different applications. In this case, only for from Minimal API. We register different exporter, Zipkin for tracing, Prometheus for metrics, and Loki for logs. Okay, and then we can register processor for batch. We can collect our information and process this information in batch mode. I register services in 3 different pipelines. So tracing, I register receiver. This is the name. Processor for batch processing information, and then exporter to Zipkin for trace. For metrics is similar, but to Prometheus, and logs for Loki services. Then I configure Docker Compose. In Docker Compose, we have many services.
Yeah.
Only minimal API and database that Marco showed in the first demo.
We have much container for logging and metrics than for the actual workflows of the application.
Yep. So we can we have configured Zipkin, Prometheus, where we mount volumes from this particular file. We configure only Prometheus information. I configure Loki, so is Grafana Loki is a real product. Loki is a short name. And Grafana for see information from Loki. So I configure data source, and in this case, when I explore information, I select Loki, and then I browse and select service name. Okay. I configure also OpenTelemetry. So I OpenTelemetry collector. So I mount volume. In this case, this is the file YAML that mount to particular path in the container. Okay, this is OpenTelemetry file vector configure all, and we can simply configure application in the program in this way. Okay. I share latest information in our demo. I reduce this. Okay. Okay, this is references. We have used OpenTelemetry. We have used GitHub at this link for this project. Marco use main branch, and I use different branch for each configuration. So I use Prometheus for add metrics, and then I use Loki branch for add also log future. And then we can share our information where we can see.
Find us if you want to keep in touch with us.
Yes, Marco is also each Friday on Twitch.
Yeah,
and we are Italian, so we speak Italian and make Italian session. And then this is other social information for question and similar request.
Okay, I think that's all. Thank you very much for the attention.
Well, that was great. I hope you also teach like how to make the Italian pizza too. I love it. No, that was great. That was great. David?
Yeah, I didn't know about the logger message attribute. That's new. I'm going to definitely look into that. That's interesting. Because logging is something that, again, I don't see people utilizing as well as they probably could. And for one of those things is, one of my things that I try to make sure my apps do, or I tell people to do, is log every exception.
Yeah, logging could be a lifesaver in many situations. It's very important to log. And my suggestion is to start logging at the beginning of the project. But because if we think, we add logging in the future. No, now or never. So start logging.
Yeah, but
tomorrow we will log tomorrow. Tomorrow never comes.
Yeah.
Well, whenever I see a try catch block and in the catch I don't see logging, then I think there's a problem with the code. I mean, with this code, everything needs to be logged, right?
Yeah, everything.
And the other question I had is the telemetry stuff you showed. Do you know if Visual Studio uses that framework for the telemetry they do inside of Visual Studio?
Visual Studio itself uses the same API system.diagnostics to perform metrics. So we have in the first version of .NET Framework also we have performance counter, for example, that are related to the Windows system, but works in the same way. And now with .NET 6 we have a better integration with OpenTelemetry. So we have the system.diagnostic.metrics namespace that Andrea shows us that works in this direction. In fact, for this part of the demo, we use just the object that .NET provide us. Then we integrate this information using Zipkin and so on. But all the object to actually collect the information are standard as provided by the framework.
Yeah, cool. Well, thank you. That was really great.
Great, gentlemen. Thank you for coming, and stay safe. And hopefully, we will see you sometime in person at one of those conferences or MVP Summit. David goes there.
Let's hope to see him in person soon.
Well, I want to go to Italy. I don't know about you, Mahesh.
Yes,
but
I want to
I've
go
never been
definitely.
there.
I want to go to Italy. Let's do a conference there. So if you guys
Thank
do
you.
any conference, we would love to come there.
Yes, invite me.
Thank you very much.
I don't
you.
speak Italian, but you know, I'm white.
No problem, no problem, no problem.
Thank you, Marco and Andrea. Awesome meeting you guys. Thank you.
Thank you very
Thank
much.
you. Thank you.
Enjoy the conference. Goodbye.
Thank you.
Bye.
All right, David. That was great. I learned a few things from there.
Me too. I've got, I've got so much to look into after this day of sessions. And, I've written so many notes today that I need to go, I need to check out after the conference is over. And, and I can't believe we're at our last session already today.
Yeah, this is the last session. And I agree with you. Yesterday and today I had Blazor, so much Blazor to learn and write about it. .NET 6 and C# 10 to learn and write about it. So this is our last session, and this session is it's very exciting. It's fast paced, so I guess I need to grab some tea or coffee or something. David is going to show us, how to do all these things in latest .NET, C#, and what are the new improvements there.
Yeah.
All right, let's bring David in. Hey, David.
Hi, David.
Hi. Good morning, or afternoon, or evening, everyone.
Yeah.
How's it going?
Well, welcome to the conference. It's going good. You are the last session, and we are almost done for this day too.
Yeah, I hope everyone's hanging in there. I hope I can bring it home for everybody.
Where are you joining us from?
Yeah.
So I'm based in Adelaide, South Australia.
Okay.
So
wow. Nice.
Southern Hemisphere, and it's
another country I want to go visit. But NDC won't pick up my sessions there, so I've never been. So,
well, I believe the NDC conferences are starting up again in Australia, so in person. So get your submissions in if you want to go to Sydney or Melbourne. And if you're going to Sydney or Melbourne, might as well come over to Adelaide while you're there.
David, that's very early for you.
Sorry, what was that?
It's morning for you.
It is. It's about 7:40 in the morning. So it's summertime, so that the sun is up. Having said that, even though it's a weekday, it's actually a public holiday today. So
oh, really?
So I've given up my sleep in to be with you all today.
Thank you. We really appreciate it. And with any delay, we will let you take the stage.
Cool. All right. Thank you, everyone. So David Gardner is my name, and I'm a Microsoft MVP, and I help run the Adelaide.NET user group. And I also work for a consulting company called 6pivot here in Australia. Today's talk, I'm going to rush through a whole lot of new features in Visual Studio 2022 and .NET 6. And I think you'll be relieved to hear that this is one of only a couple of slides I've got in this talk. Initially, I had a whole slide deck, but we just don't have time to jump through slides. So I'm going to stop sharing and jump right into the talk. Okay, so the first off, we're going to launch Visual Studio 2022. And there it is. And the most interesting thing is after I launch it to jump into Task Manager. And let's just sort and zoom. And there's our process for Visual Studio. And we'll see it's now 64-bit. And that really is a significant change. We've been sort of stuck in 32-bit for years, and I didn't ever think it was going to happen, but it has. We've now shifted to 64-bit. So particularly if you've had to work with solutions with hundreds of projects, that was just almost impossible previously. Now that really is doable. The memory limit, the 3 to 4 gigs of memory that you were stuck with, that's gone. So that's a big change. Doesn't mean implications for extension authors and commercial extensions like ReSharper or DevExpress. they're all having to upgrade to work in 64-bit. And if you've got other third-party extensions, they'll need to be updated to work 64-bit with 2022. But that is a big change and a welcome one as well. And surprisingly, very little has stopped working because of that. Okay, let's create a new project. I'm just going to create a console application. There we go. And because that's fine, we've now got the ability to create .NET 6 applications in Visual Studio 2022. So I can choose .NET 6. Also note that .NET 6 is an LTS, long-term support release, just like 3.1 was. So I can create an application. You can still create .NET 3.1 and 5 applications in 2022. And if you're working in a team that's still using Visual Studio 2019, then you'll probably want to do that because 2019 can't work with .NET 6 applications. So here's a new console application, and assuming we can see all that. And this is all the code we get. So there's no class here. There's no usings. This is all new features in .NET 6. And the templates that Visual Studio 2022 create are taking advantage of that. So we've now got implicit usings. We don't need to include everything out of the box here. We don't need to define a class. The compiler is going to generate one for us. If we have a look in our CS_proj file, we'll also see some new changes here. So we've got this implicit usings enabled. We're targeting .NET 6. And we've also got nullable reference types enabled by default. So this was something we could previously opt into, but now it's the default for new projects in .NET 6. Okay, if we create a new class, I'm just going to add a new class here. And I'll just accept the default. So we've got a regular class there, and I'm going to add a method to that. And just getting some IntelliCode assistance there. It's seen me do this demo before. So one of the new features here, I've got a method that throws an exception. So we've always had the ability to type in 3 slashes to add XML comments. If I now do that, it actually picks up the fact that there's an exception being thrown in this code, and so it adds the exception information into the XML comments. So that's a nice enhancement if you're making use of XML comments in your code. I'm going to make another class here. That's an abstract class. And it's quite interesting how well that picks that up. And this one's got to inherit from that one. And I just need to then override that one. Okay, now I'm going to go back to my program. I want to make use of this. Oops. Yeah, we just have to resolve our usings. There we go. And I'm just going to call that method. And press F12. And that navigates to the override method there. If I make this a var, it's now navigating to the actual implementation. And apparently that is a change. It's sort of, I'm surprised it wasn't the case before, but previously the navigation F12 would take you to the abstract method, but now it's taking us to the implementation, which makes a lot more sense to me. I can now move this class, and I'm going to create a folder just to tidy things up a bit. And I'm going to move that class into that folder. And if I now come up to the namespace, I can get a little tooltip there, and I want to just save everything first. That tooltip, and I can change the namespace to match the folder structure. So that's going to be useful. I do that. I come back here, and this does actually seem to be a bit of regression in the latest version of 2022. It should have updated that namespace there as well. So I'm just going to fix that. And yeah, so we can now easily update the namespaces of our classes to match the folder structure. And indeed, we can do that across the project or the solution. It's not just one file if we want to do that. Okay, I can set a breakpoint here, and I might go into my class and set a breakpoint there. And this breakpoint, I can make it conditional, and I can now enable it as a breakpoint only when another breakpoint has been hit. So this could be quite useful if you've got a breakpoint that normally would be hit a lot and it'll just be annoying because you keep having to skip over it, but you know that one particular code path, that's when this breakpoint becomes interesting. Have another breakpoint that sets and then enables this one. Quite useful for debugging. Okay, close that one. If I make this into a loop, and change my implementation, get rid of that breakpoint and turn this into the right line. And I'm just going to press F5 now to run this application. I'll put that there. I'm just going to put that to the side. And so now if I go in here while I'm running the application under the debugger, and I can go up here up to the top, and my zoom's not zooming where I want it to zoom. And I've got a hot reload button up here. And if I hit that, we'll see that change happen and our application's actually running. So if I make another change here, add some more exclamation marks, hit hot reload, bang, there's that change happening in the application while we're debugging. Didn't have to stop it and restart and recompile. It just happened on the fly. Really cool. We'll see that again a couple of times in our demo today. Really nice addition, and just increases the speed in which we can make changes. We don't have to wait so much, which is always a good thing. Okay, one other thing just to note is up the top here, our tabs. I've only got one project in this solution, but if I had multiple projects, we'd notice that the tabs from the files from different projects had different colors. So this is something that there was an extension that did that previously. It's now built into Visual Studio that you can enable this in tools options to have colored tabs as well, which is kind of cool. All right, so I've got my class here, and I've got my base class. What I'm going to do is turn this into a record. So I'm going to type that one. It's going to be record and record, and actually, no, that's okay. All right, so it is a record and everything's happy. So one thing that's new in C#6 is we can now have a struct record, so a reference type. In doing that, we can't inherit anymore because it is a reference type, a value type, sorry. Struct record is a value type. And so we can't override. If I get rid of those things, then it should be happy. And not sure what. Oh, sorry. There we go, a record struct. And so now this is a value type. So there'll be some instances where having a value type could be really useful, particularly the differences within how value types are managed in memory. So we've now got that option that our records can be value type. But of course, then we can't inherit them if we didn't want to. If I go back to my program, actually, I was going to change this to have a constructor as well. And I'll just use that convention so that I've now got two properties there. If I go back to my code here, and so previously I could deconstruct my property. So actually I'm now going to have to pass in those two values into my record. And I could do var, oops, that was the right thing. And that's going to create those two variables and assign the values of A and B. But now what I can do is, if I didn't actually want, if one of these already existed, so if I had var A up here, I can now do that. And actually, I need to give that a type, don't I? And so I can now mix that up. So I can assign an existing variable and declare a second one here. Something which I've actually been working on code recently where I could have used that. Unfortunately, it wasn't in .NET 6. So it would have been nicer to be able to make use of that feature. While I'm here, I've got these strings. I might want to do a const string that's fine. And I can now make this one use string interpolation and reference stuff. And as long as that evaluates to a constant, it can be evaluated at compile time, I can do that. So we can now, I don't just have to add those together, I can use in the interpolation syntax as well, which is kind of nice. If I went over here and made use of a regular expression, and I'm going to leave that squiggle there. I'm going to go back over here and up the top. In place of that one, I'm going to type in global using. We've now got global usings that we can apply to our project. So by adding that, if I jump back to my other class, we'll see that now it's quite happy with this reference here. It's able to resolve that. So it means that we can now make use of global usings to reduce the noise at the top of all of our class files, particularly when we've repeated usings on every class in a project. A global using can simplify that and make it a lot easier. It just means that these namespaces are imported into every file in the project. Again, a nice feature, and it means you can jump straight down to the actual logic that you care about in a file rather than having to page over a whole lot of usings. Okay. We've now got some new conditionals. So we've got, I don't know if this is going to zoom in or not. It's sort of kind of visible there. So yeah, we've got net 6 and net 6 or greater options there if we want to write conditional code for .NET 6. Now, if I turn this back into a class and get rid of those things, and instead of inheriting, I'll leave that there. And what I want to do is extract an interface, and control dot, extract interface, and that's fine. And I'm going to go to that definition. And so sometimes it would be nice if we can have an interface here. Sometimes it would be nice to be able to have a static method defined interface. So something along the lines of void static stuff. And maybe it might need to be abstract. If I've got my things around the right way, and that one needs to go there. And so okay, when I get things in the right order. All right. And so I've now got a static, and it's still not happy. And if I look at the swiggle now, it's saying that that requires a preview feature. So it's not actually available in .NET 6, but we can enable it if we go into our CS proj file. So I'm going to go in here and type in enable preview features, and set that to true. Hit save. I come back to my class, my interface, and the squiggle goes away. Now that's available. So there's a number of preview features, just like in previous versions of C#, that we can enable and opt in to try out. And so if you wanted to play around with static members on an interface, then we can turn that on. And yeah, there's certainly been cases in the past where I would have liked to have had this ability, particularly when working with generics, a nice feature in C#. Okay, moving on to .NET 6. So some new features in .NET 6 actually revolve around the command line. So we've had the .NET command for quite a while. I can now, I'm trying to think, what commands can I type in? I can now type in .NET suggest, and it lets me know here are all the available commands I could type in. We've got a new one there called workload. And well, workload, it's really quite similar to the idea of workloads in Visual Studio. So we've got workloads there in the installer where we could choose to say work on desktop applications or mobile development or web development. We can now do the same thing from the command line. So I can see what, .NET workload list. And I don't have any workloads installed on the command line. Now that's different from the ones in Visual Studio, which I do have installed. But if I was just doing development from the command line, then they would show here, and I can even see what ones are available. And you'll see they are things like Android, iOS, MAUI, WASM. So potentially we might see other workloads being added to this list over time. It'll be interesting to see what they do with this feature. Okay, let's change solutions. And have a look at some more new features in .NET 6. All right, so first one is a bit of maths. So I don't make a lot of use of trigonometry, but some people do. And one of the new methods in the math class is a sine cos method. So if I run this application, if you ever wanted to know what the sine and cosine of 0.5 was, I can now give you the answer. And it is, and I'll even zoom in. So you can write this down. There is the answer there. So Now, apparently, to actually calculate both at the same time does have some useful applications. So not ones that I have, but I've talked to some people and they go, yes, I could make use of that. The next feature is source generators. And these are not new to .NET 6, but they're being made use of a lot more in .NET 6. And one of the new source generators that's been added is around logging. So I've got over here a logging example. I'll bring this class up. And it's a class, it's a partial class, and it does have a logger being passed into it. But the interesting thing here is that we've got a partial method with an attribute applied to it. And then that method's being called inside another method here. So where's the implementation of this? Well, let's go have a look in the project properties under analyzers, and we've got our logging source generator, and we keep drilling down. I'll zoom in so you can see that better. And there's our g.cs file there. So we can open that file and we can preview what code is being generated by this source generator. And so here we have a look at the code, and actually it's really just creating an if around that the logger call there. And so this is code we could have written ourselves, but now the tooling is doing it for us. And I guess the nice thing about this generated code is it's potentially a bit more efficient because it's checking whether it should call log or not. It means we're not evaluating any of the parameters if we don't need to. So that's often in your code. Previously, you might have had an if logger like is debug enabled or is info enabled before you logged a whole lot of stuff because you knew that the logging itself had a cost. So a nice feature here is that source generators can do that work for us. Okay. Next feature is link. And so I don't know about you, but when I write link, I like my link chunky. So one of the new extension methods in link is the chunk method. So here we've got a range that we're generating, basically a series of numbers. And what the chunk method does is it's going to essentially group those into this many or up to this many items. So create arrays, if you like. Where this could be kind of useful, I think, is if you wanted to batch things and work on things in smaller groups. So we're going to run this application. You'll see what I mean. It's basically going to, there we go. So it's chunked them into groups of 3, and there's the values in each group. So yeah, a nice addition, and I can see that being quite useful. Okay, another addition to link is a change to default. So we've had single or default or first or default in link for quite a long time. What we did have was the possibility of changing what the default is. So by default, the type default value was used. So an int would be 0, a reference type would be null. But we can now override that and say, actually, if there isn't a value here, then I want you to return this instead. So we can see that. And sure enough, there's -1. That, yeah, just seems like a really nice improvement. Some changes to dates. We've got some new types in .NET. So we've now got a date only and a time only type. So rather than having to use a date time and just ignore parts of that, we've now got types that are purpose built to just store a date or just store a time. There's also been an enhancement to the time zone info class. We've got a new method there where we can now convert between IANA time zone IDs and Windows time zone IDs. So if I run this now, we'll see that the Australia/Adelaide IANA time zone maps to the Windows Central Australian Standard Time. The Windows ones are always a bit comical because it's actually daylight savings time here, but they don't ever change the name. Anyway, that's not something that .NET can really fix. Another source generator example here. And this one, I think people who are doing JSON serialization may well appreciate. So I've got a JSON message. I've got a class here, just a very simple class with a couple of properties on it. And I'm going to serialize that with the JSON serializer using the system.text.json serializer. And it's going to use a code generator to generate the serializer. So rather than having to figure that out at runtime. And the way we do that is we pass in this reference to this other class here. And if I go to, so I have to add a JSON context class here. It inherits from this base class. It has this attribute on it, which mentions the type that we're serializing. And this is partial again, so quite common for source generators to leverage partial classes. So the implementation for this one, we can go back up to our analyzers, drill down, and there's a whole lot of classes that have been, or files that have been created here. And so if we have a look at those, we'll see there's a whole lot of code that's been generated. So the advantage of the source generator here is that it doesn't need to now rely on reflection to do the serialization, because it knows at compile time what the properties are. So we can expect that to perform a lot better, and also expect it to have a lot better memory usage than if we were just using regular serialization. So yeah, a nice win there using source generators. Some other changes in enhancements here. So we've had nullable reference types in .NET. That's not new, but now we can actually use reflection to figure out if a property is nullable or not. So I'm going to reflect over that JSON message type we just saw previously, and it had those two properties. One of them was nullable, one of them wasn't. And so now, if we want to, we can use reflection to determine whether they are nullable or not. So indeed, one of them is nullable, one of them is not nullable. So if you needed to use reflection to look at types, then you've now got that ability, which could be useful. And for those of you that like to live on the edge, which is not me, but I know some people do, we've now got some new types to manage native memory. So if I uncomment this code, we're going to get a squiggle because I've got unsafe code here. So I need to enable that. And we can now allocate 100 bytes using the native memory.alloc, and then I can free that up again afterwards. I'm not actually doing anything with it here because I don't know what I want to do with 100 bytes, but I'm sure there's some people out there who would love 100 bytes and would appreciate the simplicity of being able to allocate that memory in this way. Cool. All right, that's some nice features in .NET 6. Let's move on to ASP.NET. So we're going to create a new project. And first of all, I'm going to create a web application. And so we've got our choice again of what framework we're targeting. So we're going to choose .NET 6. And all those defaults are fine. And first up, let's have a look at what's generated. So it looks reasonably similar as far as our project goes, although there are a few less files here. So we have our program.cs, and this is all the code. So there is no startup.cs here. And again, we're using our implicit usings. So we don't have a whole lot of usings up the top. We don't have a class here. Indeed, it's a lot simpler. So basically, if we got rid of the white spaces, it's probably around sort of 15 lines of code here to wire up our web application, which is pretty nice. Just a simplification of the whole process. We still have models, views, and controllers, and that's it for an MVC application. We have a look in our CS proj. Again, we'll see that we've got nullable reference types enabled, implicit usings enabled there. Again, If you think back to, and if you've worked with the ASP.NET web forms, classic CS files where you had pages and pages of XML, haven't we come a long way? And we've now got a CS file with basically 7 lines in it. That it really just makes it so much easier to manage. Really nice. Okay, if I'm going to create another web application, and we'll have a look at some of the API ones now. And that one. And so again, we've got the framework choice there. If I come down here, we've got enable open API support, and we've got this other option, use controllers and uncheck to use minimal APIs. And I want to have a look at that one. Actually, I don't mind. That's not really something I'm going to focus on. So here's our web application, and isn't this interesting? We can now do this in line. So we've got app.mapget. There's our endpoint. This is our entire API. So we've got no other code in this project. This reminds me of, I've done a little bit of Node programming in the past, and wiring up an API in Node. It sort of seems to follow a similar pattern here where we're just mapping endpoints. So for a really simple API, this might be all you need. You don't need to go through all the extra work of creating a controller and all that kind of stuff. We can just do it all in line. So really nice simplification there. Just to contrast that, I'll go and create a web API. Another one, and I'll choose 3.1. I don't get that option now for the minimal APIs. And so you'll see, yeah, a whole lot more code here happening. We've got our controllers, startup. So the startup, I've only got half the code here. I've still got more down just because all the using's there. Program, again, having to have that, and the controller as well. A whole lot of stuff going on there. So yeah, a dramatic simplification. I really like what they've done with .NET 6 in that respect. Okay, so I've got my .NET 5 application here. I can upgrade this to .NET 6. Let's have a look at doing that. In fact, I'm going to do that with rather than 3.1, I'll create a new one. I'll choose 5. And I don't need to do that. Okay, so this is my web application. I want to upgrade this. So first of all, I'm just going to go in, and actually I will show you the project properties. Whoop, that one. There we go. And this is new in 2022. We've got a revised project properties screen for a lot of the project types. So we can now scroll down all the way through, and so we can sort of jump, but it's actually one page now. So if I go down to build, and I just want to enable null reference types here, we'll see all that did was just change the CS proj file. Okay, and if I go to my controller and come down here, and I'm just going to reference a type here. Sorry, content. There we go. That's the one. Okay, and I'm going to come down here and just write a method. And pass that through. Okay, and that's all fine. No dramas there. I'm now going to upgrade this project to .NET 6. So if I come back to my CS project, I'm just going to change that to 6. Hit save. Come back to this file. And we'll now see there's a squiggle there. And just zoom in on that one. And it's saying this may be null. So content type previously was annotated to just return a string in .NET 5. In .NET 6, the annotation's changed. And I don't know if that's because it's just more accurate now or because the implementation's changed. But now it's a nullable string. And so we're now getting a squiggle there to let us know this could be null. And if we had code down here that assumed that it wasn't null, that code's going to potentially break now. So that really just highlights that a lot of the nullable annotations in the framework across the whole framework have been revised. So if you do an upgrade and you've got, let's say, warnings as errors turned on, you might have to revisit that code to make sure that you're dealing with nullable types correctly. Okay, just as a by the by, one of the other enhancements in .NET 6 is the addition of support for HTTP 3, the next version of the HTTP protocol. I can't demo that for you today because that requires me to either be running Windows 11, which I haven't updated to yet, or Server 2022. Or if you're on Linux, then you need to install some extra libraries. But yeah, just be aware that that feature is now supported if you wanted to make use of it. Okay, moving on to Entity Framework. So getting close to the end of our talk today. I've got an EF6 program here. I've got a context. I've got a couple of classes, a blog and a post type. Nothing particularly exciting there. Pretty familiar. I've got a database. I need to create a database. I've got my migrations here. If I jump down to the command line and jump into that project, and so one of the new features in .NET 6 is the ability to create migrations from the command line and create a bundle. So, so I've got migrations, and we've got the bundle command there. So I can do migrations bundle. I'm just going to tack force on the end of that. And that's going to build my project. It's going to look at the migrations that exist in this project. And what it's going to do is kind of create an exe. And that means that previously I pretty much have to have the .NET SDK around to be able to run those migrations. And why did it fail? Interesting. This was not part of the plan. There we go. That was a bit, don't know why that didn't work before. Okay, so now we have an EF bundle and I can run that. And that will actually run those migrations. All I need to supply is a connection string. If I don't supply a connection string, it'll just use the default connection. So just looking for a default instance of SQL Server. So it happens I've got SQL Server running on my machine in a Docker container. Here I've got Management Studio. There's no database there at the moment. So I'm going to run the EF bundle application. That's going to connect to that SQL Server. If I refresh now, I've now got my .NET 6 demo with tables. And if I zoom in, we can see we've got some columns there. And actually, it's got nvarchar max. That's not ideal. That seems a bit wasteful for a URL. So if I come down here, I can now, there's some new improvements to EF as far as being able to change these. So I can set a max length. I think I could always do that. I can now say, actually, it doesn't need to be a Unicode field, doesn't need to be in varchar. So I can set that to false using Unicode attribute. So if I save that, I can now add a migration. And oh, sorry, migrations with an S might work better. So that's going to add that. We'd see that under a migration. It is letting me know that I potentially could lose data there, and I'm going to rebuild my bundle now. Hopefully that doesn't fail randomly like it did before. And then I can run that. And run that. That'll happen pretty quickly. I'll jump back here. And that was in the blog. Yep. So this one, if I refresh, so that was in varchar, and it's now varchar 255. So that's much better. Okay, so I could keep doing that over everything. Instead, we've also got the ability to apply defaults now to a particular type. So for strings, we can now say, actually, every one of these I want to be not Unicode and only 255 in length. So that's makes much more sense. And in fact, I'd be inclined to use this as my default. In varchar maxes on strings doesn't seem real sensible to me as a default. We saw previously that we had new types, a date time and a time only. So let's make use of those. And let's create a migration for those. Let that build. And we get an error. And I'll just zoom in there so you can see that. And it's saying it's not supported. And what's going on there? Well, date time is part of .NET, but Entity Framework EF Core 6 does not yet support date time only with SQL Server. So I'm targeting SQL Server with the provider I've configured here. If I was using the in-memory provider, then it would work fine because they have built support for that. So hopefully this year we'll see a new release. If not, certainly by .NET 7, we'll see that implementation. So if you wanted to use, because SQL Server has a type for a date and a type for a time, so it certainly can be done. It just hasn't been done yet. So just be aware of that. Don't try and make use of that if you're targeting SQL Server. Okay. I'm assuming I'll be told when time is almost up. The last thing I wanted to demo is Maui. And I'd love to show you that in Visual Studio 2022, but I can't. And the reason I can't do that is because it's still in preview, which means I need to run Visual Studio 2022 preview to use it. So I'm going to launch the preview here. And let that warm up. And it's funny, I thought I had disabled that for the talk. I would normally use it. And I've got an application ready to go. Okay, got a couple of minutes to go, so we'll make this one quick. So this is Maui. It's really the next evolution of Xamarin Forms. I guess the advance here. Oh, there's a new preview of Visual Studio out today too. Is that we can now target Windows as well, which is what I'm doing. So we've got our familiar XAML there. I'm going to press F5, launch application. Not sure why it had an error doing a NuGet restore there. Maybe that's what the new preview version is going to fix. So we're building the application. and waiting for it to launch. There's a very simple demo here. Here we go. Coming up in the debugger. And there's application. We can click a button and see that count change. I'll bump that over there. I'm just going to bump Visual Studio over here. So we do have a live preview here, but we also got the application running there. So if I come over here and I change some text, and I might change that to be .NET. Actually, that was the description. I might change this one to be .NET. And you'll notice over here that text changed live. I didn't need to hit hot reload. That's cool. Here's another example. Here's a drop shadow. If I uncomment that, bang, drop shadow in the live application running. Didn't even have to hit hot reload. Hot reload in this particular kind of project happens live. That's a game changer to me. If I was working on desktop applications, I would love that instant feedback, being able to tweak things in the UI straight away without having to stop, build, and then launch again. I love it. Maui's in preview. Hopefully, the first version is out soon. They obviously couldn't make the November release date, so they've wisely decided they're just going to keep working on it until it's ready. So yeah, that's about time up for me. Thanks for watching, and hope you got some insights into some of the new features in .NET 6 and Visual Studio 2022. Thanks, everyone.
Thank you. You're on mute, Mahesh, so I'll talk. David, someone asked in the chat, what are you using to do that color, the color in the console window?
I always get someone asking that. Yeah, so Scott Hanselman had a post on this sort of enhancing your console. So I'm making use of the some of the extensions there just to add some fonts and colors. It's kind of bright and glary, but I kind of like it. So yeah, I like the idea of having extra status there telling me what version of .NET 6 or .NET I'm using in a particular project, and the Git status. So yeah. So
also,
yeah.
I'd also like to thank you for using a light theme background. I tweeted about this today that, you know, the people that use the dark screen background, I don't know if there's any speakers left, but I'm colorblind. And for those of us who are colorblind, and that's 17% of geeks based on my poll, that dark background is really, really hard for us to see, if not impossible sometimes. So I implore all speakers out there, if you're presenting, you know, please just switch to light background when you're presenting and switch back later. You won't cut out 17% of your audience.
No, that's good to hear. No, I try and remember to do that for my demos. I normally develop with dark mode, but yeah, for demos, light mode, and that's good to hear. There's an added benefit for doing that. Cool.
Mahesh?
Well, that was great, David. You know, again, I know it's your holiday, and appreciate you coming out, and it's early, and it's, you know, I know when it's off, you want to sleep in. Yeah, so really appreciate you coming, you know, out and sharing your knowledge with all these geeks.
It's time to put a shrimp on the Barbie.
Yeah.
Well, if I liked shrimp, I would. Probably I'll just stick with the snag, I reckon.
I heard the weather is nice in Australia right now.
It is summertime, and it's a look outside, and it's looking like a nice day. So yeah,
that's great.
All right.
Yeah.
Well, that will end our session for the day.
Yeah, thank you so much,
thank
David.
You so much.
No worries. Thanks for letting me be a part of it all. And
that's great.
hope the rest of the conference goes well.
I hope so. One more day left. Thank you.
All right, that was that. That's great. That was awesome. You know, hands-on, live C#. .NET 6 features. That was great.
Yeah,
I want to try. I want to go back and download the latest VS 2022 and try some of those out.
Yeah, I got a lot out of the conference so far. I've got lots of notes to follow up. I mentioned that already. So for me, this conference has been great learning experience so far.
Yeah, that's awesome.
Yeah, and speaking of the conference, tomorrow's day 3, and I just want to bring up that we worked it out. So day 3 is mostly all Azure cloud talks tomorrow. So if you're interested in the cloud, please make sure you join us for tomorrow. We have a lot of great sessions all wrapped around that, and it's going to be a lot of fun.
Yeah, it's cloud with .NET and C#.
Yeah,
it's just not Azure. Yeah, it's all combined.
Right.
A lot of coding, obviously coding, hands-on. We have good speakers, good number of speakers. Check it out. If any of you have, there's more conference coming up in the future too, and I think we agreed that we need a dedicated Blazor conference.
Yeah, we do.
Coming time, even if it's a one day, it doesn't matter. That'd be cool.
Yeah.
Yeah, and so with that said, I think today was great, and then we have one more day to go. I'm on road tomorrow, so I'm going to try to host from my car when I have breaks. That's what I will do. Not while driving. So I'll try to host a few hours from the car. If not, then you and Simon will be, I'm sure Simon can manage this.
Yep. And I wanted to bring up real quick at the end, so you guys don't forget tomorrow, is Simon, you can put up there you go. So on the February 12th is the Rock in the Code World. And so this will be the day before the .NET anniversary. And so far, I have a very special panel of Carl Franklin, Joe G., who is on the show today, Steve Ardelis-Smith, who has been on my show, and so this is going to be a really great, view into the history of .NET and where we started, where we are, maybe some trials and tribulations. I'm sure we have lots of stories about that in the past 20 years. So this is going to be a really fun show. I hope to give away some free things too. And so I'm really looking forward to this show, especially with, those 3 guests on my show is going to be great.
Yeah, that looks awesome. All three guys are amazing.
Yeah, so don't forget February 12th, mark your calendars, 10 a.m. Pacific Standard Time. It'll be an extended show for about an hour and a half. And like I said, I'll probably give away a couple things. And yeah, it's gonna be fun.
And thank you for everybody who's hanging out with us and staying tuned in, even though during work times and work, everybody's at work right now, Monday, Tuesday, Wednesday. So again, thank you for, hanging out and chiming in and watching, because, more people watched always encourages all these speakers.
Yes.
All right. Thank you all. So with that said, day 2, good night.
See you all tomorrow.